want. We're live.
We're live?
You're on camera and the microphone's on.
Okay, I'll just give the intro. Hey, welcome everyone. Nice to have you here on a June 30th. We got Canada Day tomorrow. We'll go celebrate, eh? Yep. Gives us a good chance to meet the day before and then enjoy the rest of the weekend. I'm lucky enough, I got Thursday and Friday off, so took that as vacation, so we'll just extend it. But welcome. Just a few things. The bathrooms are on, there's an orange door there. Just behind there is the ladies' room and men's room. And there's a second set ladies on this one. And then in the back of this
we don't really let people
thing,
over there,
but they don't usually go there.
Full,
here, yeah,
we
but
have a lot of people, so
yeah, so
there's
overflow washrooms just here. Okay, you'll see the ladies' room in the front, and then the men's room's at the back. What else can I tell you? On this side of the building is all Lubricard and Wear Check right up to the center door, and then that's the other company called Parts Headquarters. But we're going to concentrate all of our stuff right here. So you're always going to be with me or Mike or with Bill or whoever's going to do the lab tours and stuff. So we're always going to be on this side. If something comes up, we're going to go out the exit. So there's one exit door here and one over there. We'll just make our way to the grass behind the parking here, and we'll go from there. That's pretty easy. Like I said, washrooms are over there. I have coffee, donuts, beverages in the fridge beside it, water in the fridge beside it. If you want tea or something, feel free to go in the cupboard. There's a whole box of tea. The unit that makes coffee has a beautiful hot water, like scalding hot water, the Tim Hortons hot water, right? I call that my North Bay coffee or my North Bay hot chocolate, because you can order the hot chocolate and you can't drink it till you hit North Bay. It's so freaking hot, right? The old face melter. Yeah, so I think we're pretty well getting close. Say, Mike, are people online? Are you seeing people online?
Yeah, should be, yeah.
Okay. So welcome to Lube Hero. Where'd you all hear about it? Through email campaigns that Mike sends? Yeah? No, that's good. That's nice to have you here.
I'm the one that spams you.
Mike's my key man. He gets the people in, he gets the emails going, and I show up and do my thing for the day. I guess I'll introduce myself first here. I'm Paul Dumont. I'm the Vice President of Sales and Marketing here for Wear Check Canada and Lubricard. Are you familiar with Wear Check? A lot of you are Wear Check users? Okay, good customers. So Wear Check's been around for about 60 years. Is the birth date, I think, this year, 60 years as in business as a commercial laboratory in the GTA. We handle all of Canada, mind you. People out in BC will send us their samples in box loads here, and we process them, get them their reports, and that is where it goes. Lube Hero training, mostly to the GTA. We don't usually see people fly in for a free course, right? They'll come in and they'll do like their 3-day MLA and MLT training and certification. That gives them the chance to get here. But yeah, so Lubricard we started in 2004, and that's when I came over from owning my own company and coming here and getting Lubricard off the ground. We'll talk more about that as we go through the slides, and that's where I come in, right? Is that we've got a large crowd, so we probably won't do. Should we do individual?
It's up to you.
Why don't we do that? I don't know anyone here, and I don't know where you're from. So why don't you tell me your name and where you're from, like what company you're with?
We're just going to pass the microphone.
Yeah, we'll pass it to
starting with you.
This young lady, and we'll go across, and we'll come across, and we'll go all the way around.
Sure, not that young. Good morning, everyone. My name is Atia. I am a marketing. Well, that's complicated. I've been in research and development for Petro-Canada Lubricants.
Oh, nice.
For the past few years.
Oh, great.
Just moved to marketing.
Well, that's great.
So
Happy to, yeah.
Good morning,
yeah.
Dan Eng,
Yes.
and I work with Petro-Canada as well in the research area.
Nice.
And we're currently a customer of yours for our
Oh.
used fluid analysis on heat transfer fluids.
Oh, that's great. That's a great program. Yeah. Hi.
Good morning. I'm Ryan Sterling. I'm a millwright apprentice at Apotex.
Oh, the big one on 407?
150. The other one.
The other one. I didn't. Oh, I know there's quite a few of them.
There's another one by it, but
Well, good to have you.
Good morning. My name is Asan Sayed.
Yes.
Currently working with Apotex in production technical. Prior to that, I'm basically having food background in maintenance engineering.
Excellent, sir. Welcome.
Hi, we both are from Filtration Global. We do bulk fuel filtration, diesel fuel mainly.
Oh, wow.
So it's an opportunity for us to learn about lubricants and oil.
Yeah, yeah. No, that's great to have you.
Thank you.
Yeah, I'll have a side conversation with you because there's some interest there for me and you. Hello.
Yeah, Basim Gergis, maintenance planner, production technical in Apotex Pharmaceutical.
Oh, nice.
156.
Nice.
Good morning, everyone. My name is Safwan. I'm a maintenance engineer at Atlantic Packaging, a paper company.
Okay, is that, are you with New Forest Paper?
Yeah,
Oh, with
exactly.
Nayan?
Yeah.
Yeah, great. Good to see you.
To you too.
Good morning, guys. My name's Christian. I'm a lubricants account manager at Fru Energy. We're a Petro-Canada distributor. Yeah, happy to be here.
That's beautiful.
Good morning, everyone. I am Pranav Patel, and I'm from Rockwell Group in Milton. And
Notable.
we manufacture insulation, and I think we have been getting all our oil samples done with you guys.
Yeah, long-time customer.
That's right,
Absolutely.
yes.
Good morning. My
Hi.
name is Aruna Ayan. I am a maintenance lead-in at Rockwell as well.
Excellent. Thank you.
Hi, my name is Sean. I'm the maintenance superintendent at New Forest Paper Mills, part of Atlantic Packaging.
Oh, nice. Nice.
Hello everyone, I'm Anojan and I'm from Ontario Power Generation and I joined the components and equipment team recently.
What company are you with?
Ontario Power Generation.
Oh, Ontario Power Gen. From which, Niagara?
Pickering.
Pickering?
Yeah.
Oh, the news area.
It's my voice.
Yeah.
Good morning. My name's Addy, and I'm
Hi,
a
Addy.
maintenance tech at Gracious Living.
Oh, gracious. Yeah, yeah. Lots of injection molding there.
I'm Riley. I'm a mechanical apprentice at Apotex.
Excellent.
Hi, I'm Julia. I'm a mechanical maintenance co-op at Rockwell.
Hi, I'm Mira. I'm also a mechanical maintenance co-op at Rockwell.
Great.
Hi, I'm Sahil. I'm also a mechanical engineering maintenance co-op at Rockwell. Been there over a year now.
Nice.
Good morning. My name is Manju Shivaswamy. I work for Ontario Power Generation at Pickering.
At Pickering as well. My name is Artem. I am a student at Ontario Power Generation at Great. Pickering. So we got a mixed bag of companies, which is, you know, the nice thing is we all deal with lubricant oils, right? And we all have different types of equipment, and sometimes they're all pretty similar, right? A gearbox is a gearbox, a hydraulic pack's a hydraulic pack. It's just doing different things for different people, right? So today we're going to have a good time. We'll try and get this thing working properly. Went into time save mode. So this morning, we'll start with just understanding the role of lubricant and what it means to the equipment. From there, we'll talk about lube storage and handling. You know, why do we need to play around with new oil? You know, new oil's new, but it doesn't mean that it's clean. It doesn't mean that it's dry. So we're going to talk about that and look at some of the poor examples that I've run over in the last, you know, decade, half 20 years that I've been in this, 30 years. And then we'll look at some of the more positive things that people are doing. We'll also take an opportunity to talk about the tools that people use, the dispensing tools. That they, you know, how do you bring your oils to the equipment and top up equipment, do all sorts of servicing that way. What? And then, yeah, we'll talk about contamination control. That's kind of the big one. That's where your tires hit the road, right? We buy expensive equipment to perform duties, and when they're new, they're at 99.9% effective, right? They're full reliability, they're ready to be used. It's when we use them and they start to deteriorate after we don't look after them, if we're not looking after them properly, then that productivity for them reduces. And before you know it, you're not making your 1,000 widgets an hour. You're down to 750 widgets an hour because the machine's breaking down and there's oil all over the place, whatever the case may be. So that's what you have to look at. So machinery reliability, storage, handling, dispensing. We'll talk about grease applications. I got a few slides there. I've got some machine contamination control that we're going to really pay a lot of focus on. And then from there, I'm hoping to be done around 11:30, and we'll go to the small little room that I have here, display room, so you can get a better view of the hard look of them, just so you know what we're talking about other than pictures, right? And then, of course, in the afternoon, we're going to do the oil analysis and sampling methods and techniques. We will talk about training and education, the types of certifications people are going for. And then to end the day, we'll look at building the business case. Because in the end, it's all about investments, right? You got to make your investments, you got to do certain things. And a lot of times maintenance has a particular hard time getting the funds to do certain things because they're always asked for ROI. You know, what's the benefits, what's the cost, what's the return on it? And if you don't have a good business case, a lot of times you get cut off, right? They won't open the purse strings because operations, they see maintenance as a cost, right? So you got to be able to have a look at where you're going to spend your money and what brings the biggest buck for that money invested. So we'll talk about building the business case, and it makes sense to you. You might not be in control of any of that, but at least you can bring it back to your counterparts and say, you know what, this is kind of how we want to, I seen how we could make some improvements. That's a good page to have and move forward. On your desks, there's a questionnaire there for everyone, and basically you fill it in, and when we're done the section on storage, we're going to take 5 to 7 minutes or so, and that's when you guys will fill out that section on storage. There's 5 questions. Each question has 5 opportunity answers. You pick the one that best fits what's happening in your plant currently, and then check it off. Sometimes guys will check 2 off. We'll take the worst one.
Just pick one.
But try to just pick one. And then yeah, we'll go through each section. By the end of today, we'll have 30 questions answered. Mike will put them through the computer system, and about a week from now, 10 days from now, you'll get your emails with your reports, and it's going to show you the score that you are. We call world-class best practice score about 80. If you can score 80, you're doing really, really well. Most people score around 20 to 40 in that range. So there's always improvements, right? That ongoing improvements that you can do. And that's kind of the key to this thing, is understanding where you need to make some improvements. So again, Lubrigard started in 2005, went around looking for suppliers, mostly all stuff from the US through trade show connections and people at their booths. And then of course I needed them to be allowed into Canada, right, to be able to offer to my customers. So the products really came into fruition there. Services, we'll talk about that. We do have some services. This slide needs to be updated, but we'll get to that. One of the things that's really important, and a lot of companies do it, is the benchmarking, auditing your plant. I used to do those audits myself, but they were time consuming, right? So it wouldn't be uncommon for me to spend a week to 2 weeks inside a plant looking at everything that's on the audit, all the gears, the bearings, the motors, the hydraulic packs, you name it, and detailing it all out. That became a very long task. So we partner up with a company called Deskcase. Don't know if you know them, but they're a large lubrication management company. Their claim to fame is the blue desiccant breathers. but they have so much more, right? So we're a huge Canadian distributor and US distributor for them. So we hand that service over to them. So usually the companies will say, we want this service, and then they'll lay out the plan with Descase and they'll quote it. And then if they like it, they'll come in and start the audit. But it really gives them a full array of information on the plant.
How do you spell that company name?
Descase, D-E-S-C-A-S-E. And then, of course, lubrication surveys. Lubrication surveys were developed when I started Lube Hero, and that's why you have the questionnaire surveys there. When we do get the reports, the next thing is if there's an interest, if there's movement to move forward and you want more help, that's where I come in. I travel anywhere around 100 to 150 kilometers, and I'll come in and work the plant with you. We'll walk the floor, look at critical componentry, assess it, and look at everything that each unit has. Maybe if you've got 10, like at your plant with the injection molders, I only need to look at 2 or 3 different models and they're all the same, right? Same with gearboxes. If you have 30 gearboxes and they're pretty well all the same, we only need to look at a few. It's going to be married over. So the assessment is quite quick. We look at the lube room, we look at the tools you're using, talk to the people, go through the plant. So that's a quick assessment, walk around with your report. And that lube assessment, again, is one of the deliverables. Lube room design and construction, yeah, we do quite a bit of that. Like there's a lot of places that have small rooms in different areas of the plant, or they don't have any room at all, and they have to look at C-cans. So we'll custom design C-cans, put everything in it for them. That kind of stuff really works well. But that's in our lube room design area that we work in. We also have an oil analysis program design. If you have a minute, you can have a look at this banner here. This really exposes the 4 differentiators of wear check. And one of the key ones is these barcode tags, right? That's an equipment tag with a barcode. Your oil sample forms have barcodes on them. So you can put the barcode from your SIF form or your sample information form on your bottle. You use your app on your phone or on a tablet. You click the unit, it loads it up. You click the sample bar, that marries them together, and you send your sample in. Press submit, and your sample's ready to be shipped. There's no writing, there's no forms to fill out, none of that. So that means less mistakes. When you do get on that program design, we work with the maintenance team to get a full understanding of the equipment. We need the full equipment and all the little categories involved with it, so that when we enter it into your system on your account and you start using this, when you give me unit 101 and it's a Husky injection molder and it has 2,000 liters of Petro-Canada Hydrex 32 oil, and it runs at 4,000 psi on the pressure side, and it runs at 40 degrees C. I use 10 micron filters on it. Well, all of a sudden, that's pretty great detail for the lab technician, right? When they're doing the report, they're going to give you a pretty sound recommendation after that. If you don't do anything and you're just filling out the form and we know nothing about your equipment, you're only getting half the value of your investment into that one sample. So it's super critical to get everything that you can find out about each component so that the diagnosticians have a much better way of seeing what that machine is. Sometimes we even upload pictures of the machinery, put it right in there. So unit 101, oh, there it is. Looks pretty critical. Put criticalities in that rating too. So all that information gets downloaded into this oil analysis design program. And of course, we used to have a scheduled oil sampling, but our guys retired, so we just haven't replaced it. But it used to go around to companies like at New Forest, for instance, right? Bob used to go visit there and pull all your samples. Now you guys are going to end up having to pull them now because we're not going to be doing that service. So that's what goes on there. And the Lubrigard products, like I said, I spent many, many years attending trade shows throughout the US. Shows like the IMC International Maintenance Conference, the NORIA Reliability Trade Show, SMRP, Society of Maintenance Reliability Professionals, they put on a big show. So those are the shows that I attend. I have my little booth, but in the beginning I just walked the floors, talking to people, the vendors, right? That's how I got introduced to Descase. That's how I got introduced to Y2K filtration and all of these different groups. And then of course they want distribution as well. They want good partners, and we have a great system. So Lubrigard was able to grow quite quick. And where we really concentrate on is here, lubricant storage and filter carts, or dispensing carts. Here you got dispensing container families, lubrication ports and breathers, oil sampling devices. Then you got your nice little oil sample kits. And of course, once you start doing this and you get good results, if the machine says, hey, your oil's still pretty nice, it's still got good viscosity, good acid number, it's just a little dirty, your particle counts are high. Well, what do? You don't change the oil. You go out and you put a filter card on it that's got low micron efficient filters, and you polish the oil. The only time you change it is when the results come back and say, hey, your oil's pooched, the acid number's too high, the viscosity's gone, it's time to change your oil. So you really start to use CBM, right, condition-based monitoring, to be able to push yourself forward without a ton of work and labor and cost of product. So filtration, all sorts of different things. I carry about 4 different distributors. I have access to much more, but the normal stuff is pretty easy to do. Magnetic filtration, very popular for my cutting fluids people and that kind of stuff. Heavy gear load, large extruders and stuff with a lot of metal. Well, we eat up a lot of filters, so we use magnetic if it's got a ferrous layout. So it'll pull out a ton of ferrous metal. And of course, we deal with a lot of different companies with large systems of oil in different industries. So that's an oil purification vacuum dehydration unit designed to take out particulate and water. It's usually a machine that you would put in place, like the Niagara hydroelectrics or OPG at your big steam turbines. Well, these things are there. They're already put in there by the manufacturer at that point, right? But some of my customers don't have it, and they need it. So I have an access to it through multiple distributors, so I can end up helping our customers move forward with a solution. That's kind of the family and where Lubrigard deals with, but it's a full-rounded opportunity. Here we have some questions that we did, and it was 347 people were asked a bunch of questions, and of course we took the top 3 because they were more interesting to me. And here's the first one that I like. How important is precision lubrication to overall equipment reliability? Meaning, how important is oil in your equipment? Well, that's the answer. 1% said that it's not important. Okay, it's small, but it's still 1%. 18%, however, said it's important, but overwhelmingly, 81% said it's crucial, it's critical. Who believes oil is critical in here? Does everyone raise their hand? I would think so. Let me ask you this, when you're not feeling well, and I mean really not feeling well, and it's time to call the doctor, right? So you end up going to the doctor. What's the first thing he asks you to do? Or what's the first thing he will do for you? Get some blood work done, right? Let's see what's going on here. Same idea. How important is blood in your body? Well, if you don't have blood, you're not on the planet, right? You're underneath it, pushing up daisies. So yeah, it's super critical. It's just like the blood in your body. At your plant, have you achieved a level of lubrication that you would consider best or close to best practice? Well, that's a good question. 32% said, yeah, we believe we're there. The larger ones, 68%, said, nope, we're not there. I've been doing this for 35 years, and I would say 32 is pushing it. I'd say maybe 20. 15 to 20% of my clients are there. Every plant I go, every training guy that's here, they're not even close. Not even close. So I know a little bit about that. So if everybody is at 68% saying, or you know, that we're not there, well, why is it? So why don't companies pursue world-class lubrication? What's the caveat there? Well, if we look at the three major problems, it's lack of knowledge and understanding. We just don't know. We can't do anything if we don't know anything, right? It's pretty hard. We'll do the best we can with the knowledge we have and the people that we work with. But if I had more knowledge, I'd probably make a better decision. And that goes to anything in your life, right? If you have better knowledge, you can make better decisions. So the solution is training and education. How about this one? Too busy putting out fires to develop an action plan. Happens all the time. Project management support. Can't tell you how many plants I've been called out to go visit with the guys. I get there and Johnny can't come and get me because he's underneath the machine working. I have to reschedule. Thank God I'm in Sarnia and I have 6 other people I can go see. Yes, I'd be driving home from Sarnia, right? But project management's an easy way of fixing that. How about this one? Lack of management buy-in to provide the funding. Yeah, huge. So that's where we develop that business case. You know, a lot of managers, a lot of decision makers at your companies, they'll send all of you guys here, which is fantastic. But how often do you see the people that make those actual decisions giving up their time? You think they're knowledged? Maybe. Maybe. But if you score 20 on your report, you think they're knowledged? They should be here. It's designed for management. It's designed for technicians. It's designed for everybody to get a vision of what could be possible, right? Where can we go? And that's that developing. If they're not going to come, then we need to develop that business case. This is the overall plan. This is a plan that most companies will try to do. If they're on an embarkment to become world class, they'll start here. And we always work with the oil companies that you're working with. You try to find that good, solid oil company that works with you. And a lot of times you can consolidate oils, right? I went to one company and he has 32 oils in his warehouse. 32 oils. And I said, holy moly, why do you have 5 hydraulic 32s? You got a Shell, you got a Chevron, you got a Mobil, you got a Newco, holy moly, why so many? Well, when we buy a piece of equipment and it comes with Shell, we put Shell. If it comes with Newco, we put Newco. Well, you know, buddy, you can consolidate that down to one good vendor and he'll bring you a good 32 weight oil. Oh, really? So that's what it's all about, right? Is let's consolidate, get yourself a nice little plan. So if I could, the average guy I think that I see is about 10 oils. But I can usually break them down to 6, right? By just getting some out of the way. And then of course, once you have 6, then it's manageable. You can put color codes on them, you can identify them properly, identify your equipment, you got a good thing to do. Time we got, Mikey? 9? Yeah, we'll take a 5-minute, at 9. So that's a real important thing to get started at least. And then you know what? Maybe that's where we do our benchmarking. You've got a good opportunity here with the survey because we're going to understand where you are. So we can get the survey, we know what's going on. Now we can look at implementing best practices. So if we go in and we identify 10 hydraulic power packs and 5 large gear sets and 3 compressors, and they're all critical 10, then that's what we need to look at. We got to concentrate on that. So guess what? We might be putting ports in as a solution along with a filter cart, maybe some color-coded dispensing, maybe it's greasing. And then we'll implement the oil analysis, you know. Here's the kits you need to accomplish this thing. But that's your best practice implementation. Then the quotation comes out and you're able to move forward. Then you have an opportunity to really design your lube room, if that's what excites you. So you can bring it all the way around to the lube room, because that's the area that's going to cost you the most money when you redesign and re-implement, because it's not done on the lowest dollar. They're usually the high-end dollar stuff, right? Cabinets and safety cabinets, and storage systems. But at least we got a plan, and then they get it installed, and your world-class lubrication program is intact. But guess how long that journey is for most companies? Take a guess. Is it a year or more?
5 years.
Who said 5 years? You win the cigar. It's about 3 to 5 years. I'm with some guys now that we've done this 15 years ago, and they've only done pieces. And every year they do another piece. And when we get to the next piece, that guy that I'm working with is gone. I got to train the guys all over again. Convince them that this is the route that you were embarked on. And then you got he might believe in it and he might not believe in it. But yeah, you're right. It's a long journey, right? So I work off of this one, the streamlined. Most companies should be working off, even yourselves, you should be working off the streamline. And the streamline is very simple. You still do your oil consolidation. That's what your oil people. You still do your self-assessment. But boy, oh boy, let's go for the units that have the most impact on your company. And that's that contamination control to the equipment. The equipment is where the rubber hits the road. The equipment is there to produce the product so that you can get it out to your customer and they can pay that invoice. If he demands you the full availability of that equipment to do 1,000 widgets a day, damn it, that machine better do 1,000 widgets a day, right? And we're making money. So if it can't do it, we have to find out the reasons why. So that's where your product plan will come together. Your assessment is going to tell you where you are and why you're having trouble. The work plan will tell you what investments you need to do. Everybody's on board. You know what you got to get. You order your products, we deliver them, and you put them on. Within 3 months, I can easily fix all your hydraulic systems. The ports are simple. You put them on, they're ready, and they're a lifer. Once you put it on, you never take it off. You never have to worry about it again. The only thing you have to replace is the desiccant breather when it turns pink. It's got your sample port there. You got all sorts of nice little gadgets on it that allow you to do servicing. And then once you're there, that machine and your oil analysis turns green again, right? You're sending in samples. If they're continuously red, you got to figure out why are they always red. And then once you start doing your implementation, they start to come down to yellow and then down to green. Green's where we want to be, right? What does green mean on an oil analysis report? Anyone? Means normal. You're in normal state of operation. That's what we're all gaining for, right? When I take my blood, I'm hoping it comes back normal. If it comes back severe, I'm pretty worried, right? But you want it normal. And then, of course, the 18-month opportunity down here is usually around building around your oil storage, right? Because it's a little more costly to do an oil storage room. And it might have to go to capital investment, get it for the next year's budget, that kind of stuff. But that can get you there. And of course, you're talking 3 months, 18 months, you're talking less than 2 years, and you are in a world-class opportunity. Let's take a break. We'll take 10 minutes. I've got donuts, coffee. All right. Just got a few people coming in there with their coffee.
It's going to be a job.
All right, we're going to get started, guys. All right. So we're going to talk about the role of machinery lubrication and what's it mean. What does the lubrication mean to reliability to the equipment? Up here's a little blurb from the National Research Council. $200 billion is the amount of money lost due to friction and poor lubrication. And that's a file that I'll show you on the next slide where that $200 billion is from each year. It all starts up here with the loss of usefulness. And in that loss of usefulness, the way equipment fails is exactly the way it's laid out here. 15% of all equipment is obsolete. So once it wears out and it's done, you can't replace it. So you got to buy a new one and do something, right? So 15% of all equipment goes to obsolescence. Then you have the other 15% is accidents. So the machine gets wrecked and you have to buy a new one, right? So that's 30% right off the top that's gone off your equipment list. But the majority, 70%, is surface degradation. We just basically run the equipment and it wears out. And the way it does it is these two areas. It either wear itself out through corrosion, which is 20% of the 70, but the majority, 50% of it, is actual wear. If you break down the wear side, these are the three most common ones. There's about 10 other ones, but these are the most common. Fatigue, right? Adhesion and abrasions. This is it here, 70% of the component replacements lost are due to surface degradation, right? Here's that file on $200 billion. It was done in 1986 by the National Research Council. Today it's part of our GDP. And it's in the trillions of dollars. And that's in Canada alone. So Canada still, to this day, is spending about $1 trillion a year repairing and replacing equipment. And this is just a little bit of examples back then of utilities, electric utilities, right? $250 million. Lots of industries having issues. So fatigue is 15%. And basically, it kind of looks exactly like that. If you took, the best way of explaining it, if you took a wire and you start bending the wire, eventually what happens? It snaps, right? Well, if you were to bend that like that under a microscope, what you would see is just flakes and flakes of metal coming off. And then eventually it fails. It's a hard particle caught between surfaces if it's under load. And then it creates these cracks, and then spalling comes out, and you're stuck with this metal in your oil. Eventually, you run the equipment from a new state to a failure state over a long period of time. So if you got gearboxes that are running for 25, 30 years, eventually that longevity loses out, right? Heavy equipment, engines, that kind of stuff, the same idea. That's why they say you need to rebuild it, 150,000 hours or something, or miles, and 15,000 hours you got to rebuild and do certain things, because they know that the fatigue is a big part. But to extend the life of components, you need clean oil. If you can catch these particles and get them out, it'll reduce that opportunity to gain more particulate and wear out. The other one is adhesion. Adhesion is more or less two pieces of metal colliding together. So that's an effect based on the viscosity of your oil. So if you end up doing something to the oil in your gears, or especially in gears, you're going to get metal to metal contact, and that metal to metal will eventually just pull itself apart. So you need to be able to make sure that the sufficient oil film thickness is there, and that's truly your viscosity. Temperature, the region you're in, all that stuff has to be a factor. How hot's the plant? How cold's the plant? Because we deal with that in Canada, right? It's hot one season, cold the next season. So you have to pay particular attention to your viscosity and make sure you got the right protection value. Abrasions to 20%, that's the biggest one. And abrasions is exactly what it means. There's something in the oil that is foreign and it's causing abrasions to the metal. And it's a hard particle that basically gets embedded into a softer material, and then it makes a little hook and it wears out. Your machinery runs over top of this little rock, let's say, and it acts as a, what do you call that machine? A lathe. And it just peels material off your bearings, off your gears, all that good stuff. So to compensate for that, you need to keep your oil clean. You need to keep it at a point where that third party wear is out of the system, out of your oils.
Previous slide, the
Yeah.
last point, do you know how much percentage of failures, not this one, the previous one?
That one?
The last point. No, go, yeah, this one.
Alignment balancing?
Yes. How many failures due to this?
Lots. Probably 50%, I bet.
So it's not lubrication, it's
It's just a misaligned. If you got misalignment, guess what happens? You're wearing material off your components, and we see it in the oil analysis. So what's the other, name me the 3 top condition-based monitoring tools that companies use.
vibration analysis,
Vibration,
ultrasonic temperature.
ultrasonic temperature, and oil analysis, right? If you got misalignment, what's going to find it? Usually it's your vibration sensors, right? We'll find the problems with oil analysis much faster because it's wearing, but eventually the combination of this stuff really gets you to a position where you can react quickly to the problem. The other, so we had 50% in the wear. The other 20% of the 70 total was corrosion. What do you need to make an acid? Remember that back in high school? You need water, right? H2O. Even your battery, it runs your cars and stuff. Any battery typically would have water mix in it. That's what you need to create the acid and get a charge. So now water is your biggest culprit. So you need to come down and look at contamination control. In the environment you're working in, if your machinery's outside, your machinery's inside, heated, maybe not so much. Could be your transferring solutions are not adequate. If you got your oil stored outside and in just a shelter, and it's hot and cold, and you're in steel drums, guess what? Over the course of months, you suck up water and moisture and condensation. So water is not a good thing. You have to prevent it from getting into the equipment, and you have to prevent it from getting into your oils, whether it's in storage, whatever. So good contamination control we'll talk about. Now you got the machine failure cycle. That's pretty important. It all starts here with contamination. So whatever's getting into your system is either through a process, the environment, or an improper oil makeup. The process could be, I work at a plant at CRH, the cement plant down in Mississauga there. Well, they're dealing with crushed limestone all the time, and they're bringing it into a powder form to fill their bags of concrete, right? Well, that dust is everywhere. If they didn't vacuum up the floors in that plant, in a month you'd have 6 inches of concrete dust, right? So that dust is a process, and it's coming into your equipment. That's what you got to work for. So some of your, like Apotex is very clean. You're not going to have a lot of issues there. OPG, it's all pretty well clean. It doesn't do a lot of things. I'm trying to remember your companies. Who has a dirty environment? There you go, right? That's an easier way of putting the question. So if we've got that environmental, obviously that's temperature, outside rain, snow. If it's on your equipment, you're going to get it, right? You got to watch that. What's improper makeup? What are they talking about there? What they're talking about there is people putting in the wrong oil. So let's say you've got, you're doing your run and you've got 20 gearboxes that you got to inspect, and you've got your little oiler cart, and each of them take 220 gear oil, maybe a few in the back take 320, and you get through, you got your 2 oils, and you got some hydraulic, and you get to there, and holy smokes, I don't have any 220 left. And he looks around and grabs the AW32, and it only needs like 2 liters. Oil's oil, right? So it's topped up. But what is there a marriage there? Gear oil at 220 and there's that's an EP, extreme pressure oil, and you've got a hydraulic oil, which is an AW, anti-wear oil. One's 220 viscosity, the other one's 32. Over time, definitely the additives don't match, so you screw up your additive pack like that, and you lower the viscosity, so you get that adhesion wear. What if it's 220 and he only has 150 left, and he tops up with 150? And he's not going to get the barrel back. He doesn't tell anybody, but they keep putting 150. Well, now you're not 220 anymore. You're 150. So you've lightened the oil to the spec where it doesn't meet the spec of that equipment anymore. So now you're going to experience wear. So you got to watch that, but we'll find it. We'll find it in an oil analysis because we're looking at additives and viscosity and acid numbers, right? And wear metals and all that good stuff. So we'll find it at the contamination zone. But undetected, contaminants will cause fluid degradation. So over time, if you're not looking after it, it's oxidation is one of them. So it gets more and more oxidated as time goes on. You get additive depletion. And you have thermal degradation in the engine style because it's all under high heat, right? That's why if you don't change your oil at a certain amount of time, what happens to your oil? It gets pretty black, right? Well, that's viscosity change as well, acid number change. You're causing more degradation to that oil. And that oil will lay out its sludge and its components, and before you know it, it only takes 5 or 6 missed oil changes and you're in big trouble, right? So thermal degradation, oxidation, that'll all come to play in the fluid degradation. If you do not find this, it ends up affecting you in your wear and your fatigue, and that's where you're going to see the variety of them, from abrasions to adhesions, erosion, cavitation, corrosion, electrical, chemical. Undetected, you just keep running it, it'll go into machine failure. Then you're replacing it, right? You're replacing the engine, you're replacing the gears, you're replacing the servo valves on your injection molders. So we have to pay attention right up here, and that's through your 3 different methods of testing, and oil analysis being one of the key ones. Let's look at some types of services. So we have the reactive maintenance, right? You replace the component when it fails. That's a long time ago thing, but it still happens today. It still happens. They run to failure. Not an easy way to do business. It's cheap on labor, mind you, for the first little bit, but when it does hit you, it hits you hard. And then they said, you know what, we don't like all that failure. So they started a next entity here was preventative maintenance. And that's fix and repair components before the anticipated failure. Still part of our maintenance culture today, but nowadays it's left to the MRO, right? To hold all the bearings in stock for you and all the gearboxes in stock. Because most companies don't have a big warehouse where they can go and get 10 of these and replace all 10 today. Yeah, it's all budgeting. It's all tightly wound down to that. So we don't see a lot of that anymore either. But here's where the industry has really gone. They've gone to more of a predictive state, right? Condition monitoring for detecting potential failures and control the maintenance actions. And again, that's key. By going from preventative to predictive, it's about a 55% gain in savings. Really, really good. And then, of course, if you're doing all your condition-based monitoring, it's going to tell you certain things. Now it becomes, what do you do with that information? Do you file it and just walk away? Or do you find the bad actors and you go try to fix them? If you try to fix them, you're becoming more proactive. So you need to understand what the oils are, how they're working, how the equipment's working, what breathers are on there, are they rated? Is moisture an issue in your environment? Then you need to probably bring them up to desiccant. All of these things are proactive sources, right, that you can do in improving on the filtration. Having a few extra filter carts in there, right, with low micron. If I've got a nice hydraulic power pack and he's a critical 10, then I want to filter it when my samples come back. Then I've got a cleanliness target that's out of range. My target is this, but I'm up here. I hook my cart on, I filter out the debris, and I'm back to green again. I've met my targets. So that's the key thing about having some proactive source there and really concentrating on being proactive. Really goes a long way. I do a lot of work with companies, and I still see quite a few customers at stage one. Stage one is they have oilers, lube management, no PDM program, they react to firefighting. If they're a stage one, usually 25% of all the equipment in the plant, at least 25% of them will be in a severe state of operation, right? Because they just don't know. They don't have the data to see that. So if I had a client that says, I've got 50, I've got 100 pieces, Paul, that I want you to come in and I want to take 100 samples of my plant to get a 30,000 square foot look at the results. 25 of those 100 will be severe, generally. So our goal in training and goal in the maintenance team at your companies would be stage two. If I can get people to understand it, if they did some things like lubrication crew, get them trained, bring them to training, lubricant management, start getting their CBM going, get a predictive maintenance program in effect, and then use, instead of preventative, try to get to predictive. You can bring that down to 5%, which is a lot of savings. That's a lot of money on it left on the table back here. And if you're really motivated, guys can get to stage three. Stage three is you have lubrication technicians, and now you can get them certified, right? You can have MLA, MLT, level 1s, 2s, certification. Then you got that CLS, these types of things that you can go for. When they start to get world-class lubrication, mature programs and predictive, proactive measures, you can drop it to 1%, which is ideal, right? That's the big saver. There's certain industries, though, that you're hoping that they're there, that they're in the one. And name me two that comes to your mind that should and always should be in the one. Think of services and what they're offering us in terms of the industry that they're in. Power, right? Nuclear, aviation. Would you get on a guy's set of airplanes and his maintenance, his severity problems on his planes and his helicopters is 25%? No, I'm not getting on that one. I'll drive. But yeah, nuclear, like we live right beside them, right? They got to be superbly run. And it's all about the people, right? Ideal. People upstairs, downstairs, on the floor, they're tied in pretty good. And that's where you see that 1%. What do we got? We'll do a little bit of the lube storage and then we'll take a little break. So lubricant storage. What are we going to do with that? Who uses, do you know what 5S? Does anyone know what 5S is? Yeah. That came out about, I'd say 10, 15 years ago. Quite a few people use it. It's noticeable. When I walk a plant and I see people that are employed the 5S strategies, it's easily seen. So it's right that, sort, set in order, shine it, standardize it, and then sustain it. Have a champion that's going to back it up, right? I see it a lot when we do storage systems for companies. They get all these new storage systems, they're all color-coded, ready to go, and nobody looks after it. The filters are in bypass, the desk and breathers are all pink or white, oil everywhere. So they haven't sustained it. They haven't found a champion to really look after it. But if you can get the 5S, that usually disappears. Here's some pretty nasty stuff, guys. This is bulk storage practices. Bulk is considered steel drums, plastic drums, totes, any way in bulk that you're getting your oils into your plant and storing them. And these particular images here, they're very unsafe, right? And I'll talk more about the unsafe. That's why I got it highlighted. But they're filthy, disorganized, wasteful, destructive. So this is one plant that I walked into. And this is his new oils. And then behind the new oils is his servicing equipment. That's a nice little trolley there. I like that. But say you want some oil and you have a new student or a new employee, he's fresh out of school, and you get him there and you send him to that shop and you say, I need 5 gallons of EP220. Johnny, go there and get me that, would you? And he goes through and he takes the shortcut because he can't get anywhere, and he goes through and he steps on this thing, the little cart, and he slips out and smashes his head on this steel pipe here. What happens now? Well, probably splits his head open, so he's got to go to the hospital, get some stitches. Then there's a big report lit up, right? But what if it's worse than that? Now he's in the hospital, he's got blood on the brain. What if he passes away? Holy moly, what happens to the supervisor? Fine, maybe jail. What happens to the company? Sued. Put out of business. You think people think there's nothing there. It's massive. And that's just one. I see it all the time. That's just on the safety side. I hope you guys aren't there. I'm sure you're not there. But, well, good thought though, right? Safety. This is the sister company of this one. A little bit more controlled. He's got it on a rack system. He's got the barrels up there. Obviously, he didn't manhandle that up there, or he would need Jean Ferret, the big wrestler, put those up there. But what do you see here, guys? Why is it poor? Why is it considered a poor application?
Leaks.
Yeah. What else do you see? Absolutely. Look at the amount of dirt on the floor. If there's that much dirt on the floor, guess what's in these open cans? Everything that's on the floor. And you're asking them to put some really expensive AW32 in this top-up jug or in this 5-gallon pail. Who knows? He's going to put a funnel and pour that out of there. What's he doing to the equipment? He's loading it up with particulate. He's got no breathers on the tanks. So every time he wants to fill that, he's got to loosen that bung up to get the gravity air to come in. So if he takes 5 gallons of oil out, what's he replacing the 5 gallons of oil with inside the drum? 5 gallons of air. If there's moisture, sand, dirt in the air, what's going into your tank? All of it. So now I've really messed up that brand new oil. It now doesn't meet the codes at all. It's contaminated. And we're going to put it in a critical component. And then every quarter, you're going to send WearCheck a sample. And you're going to sit at your desk praying that it's green. What's the odds of that being green? that sample? Zero. Unless you got super filters, but you're probably using up really expensive, good filters much quicker. So we have to pay particular attention to that. New oils are new. They have the new spec. They got all the ad packs, all the antioxidants are there. They're new, but they're not necessarily clean. We do about 6,000 samples of new oil here every year, and that's the average code. We're going to talk about the codes. That'll make sense to you. That's the high code. Typical hydraulic system would be here. If you've got high pressure systems like yours at the Gracious Living, those injecting units run at about 3,000 plus PSI when they finally make the press, right? 5,000 maybe.
It depends. I usually never goes to 5,000. That's really high pressure.
What is it generally? 3,000?
Well, when you're creating tonnage, it's at 1,500 to maybe like 3,000 would be the highest.
The highest,
really high tonnage. When you get into the smaller tonnages,
That gets a little.
Just to create your tonnage right there.
Oh, there you go. So anytime you're up in the 3,000, there's good charts online too that you can find. When you get down to that 3,000 limits, like heavy equipment can be 3,000 to 4,000. Well, that means there's servos in there making that open and close the way you want it to do it. Well, the chart will say 19, 17, 14 is too high. You want to be maybe a couple of codes lower, like a 16, 10, 9 or something, right? But if we don't know, we get this as your default number.
And, I'm sorry, was that number from last year, let's say, for example, the samples?
No, that's every year.
Every year? I mean,
Yeah.
that's the average, even?
That's an average, yeah.
21.
Yeah, yeah. So here's some more poor lubrication, right? First in, first out. You'll notice the barrel in the back is all dirty and scummy. That's because the operators that come in, they have 4 barrels in case the machine blows up and they need all 4 barrels, or they're going to do an oil change in, who knows, 3 years. But the company says you need at least 4. So they got 4, but the guys keep grabbing the one that's there, and they pull that one out. That one stays there 2, 3, 4, 5 years. What happens to your ad pack after 5 years typically? You lose your additive pack. Sits at the bottom, depletes out into your bottom of your can. So when you finally need all 4, you've got 1 barrel, maybe 2 barrels that are, you know, not call it not in a sweet spot. Kind of, you know, they're defective. Over on this side, look at the steam in this location. He's got pumps and hand pumps to get the oils up to the compressor end. No breathers, no desiccants, but the steam is just overwhelming in there. This one here, same idea, just a filthy, filthy room. Buckets, wide open buckets, no breathers, so pretty hard. Same on here, this is a heavy equipment shop. Lots of ideas to get your storage up and making yourself more real estate, but it's not helping your oil quality at all. Then, of course, now there's a solution, right? This is one of the, I call them the Cadillacs of oil storage through fluid defense. You can have any particular size of tank from their selection, but generally it's 70-gallon steel tanks, breathered, level gauges, connectors to fill and filtration underneath. You can build them with dispensing bar if you want. They're all pre-filtered, 3-way filtration. So you bring your 45-gallon drum up, you have the hookup, you turn the pump on, it runs it through the filter, stores it in the tank. You switch a valve and it circulates the tank through the filter to bring your ISO code down. And then it filters again when you bring it to your dispensing tools. So that's the Cadillac. And I have guys that'll put hose reels on them, all sorts of different things. But they're costly, right? You got to have a good budget. And it's common stuff. Lots of people are using them. Other ideas here. This is a lube room I built for a fella. So he has 3 bulks. These are 70-gallon tanks, dedicated 3-way filtration. And then on the side he has 30-gallon tanks, and he fills those up from 5-gallon pails. He's got a little handheld unit, and he pumps them in. But generally this is where they would go with the bulk. This is a lube room that won the Noria Lube Room contest in 2019. This is through my U.S. counterparts at Lubrigard WearCheck USA. And you'll notice that they got the big placards on top identifying what's in each tank. The green, blue, and yellow, green, blue, and yellow, green, blue, and yellow in their containers in a sealed safety cabinet. And they basically did it 3 times. So they're using 9 consolidated oils in a nice building. Everything's labeled off and clean. A good 5S example. Here's one that wasn't a good 5S. This is a food plant that I work with. This is the little storage area that they have. So for years they tried, even with all the training we did, they tried to get management to help them move to this. And all it took was a guy to put a pump in this drum, fill up a container, and he walked away. And over the weekend, you gravity feed out the nozzle, and he flooded the room with the oil. So when he come in to open the shift, this is what they encountered. And the manager who has been trying to get this just lost his mind. So he goes up to the safety department, grabs the guy from safety, brings him down and shows him this. And the guy puts yellow tape, do not enter anymore. And he shows him what he wants to do. Because the yellow tape's there, the safety guy says, you're not opening this again till this is done this way. So safety's got power. If you're stuck, use them, because this is what you're going to get. The guy slips on there, the insurance is just not worth it. Now he's got his storage. He's got 5 different fluids. He's got his oil safe cabinets. A lot nicer, a lot easier on his people, a lot safer. We do cabinets in steel containers. This is down at the refinery. Different views of it. This is a 5-gallon pail transfer system, and it transfers it into the 30-gallon tank. This is a system we did for a mining outfit. All his bulk tanks, 2,200 liter tanks with dedicated filtration, and the rest of his oils. On the back side, all of these oils are plumbed into the service shop. So all the hose reels and everything are inside the shop, but the oil itself is in the container. They also have mining equipment that are outside that need top-ups and stuff, so they drive right up here, and in this cabinet here is the hose reel. This is the fill station, so when Petro-Canada comes with their big service truck with all the different oils, they hook up to these, transfer oils into these tanks, and everybody's happy, right? So these are the filtered tanks for heavy bulk oils, and this is just a standard tank for low volume. But if they wanted to put a panel, we'll just isolate a panel onto it. That's the fill with the alarm system with all the different numbered tanks. That's the hose reel heated cabinet. This is a construction shop. One of the things that construction contracts, when they do their contracts with the oil companies, a lot of times the oil company will say, you know what, thank you for buying 10,000 liters a month from me. With that contract, we're going to supply you with the bulk tanks. And the guy says, great, less off my plate. But they don't do anything in terms of proactiveness. You get the tank all right and you start filling it, but there's no breathers on it, there's no quick connects, there's no filtration. And time over time over time, they stay there, they're permanent. So how, with all that sand and dirt, if I don't have good breathers, how long do you think it would be before the bottom of that tank has itself a nice little buildup of sand and dirt and whatever. It's there. So they have to resurface them. So what we did here is we did the bulk sampling of the new oil, and we took it right from their hose reel systems. Right, good place to start is right from the hose reel. Well, there's your 21, 19, 14. Never going to meet. So we just had them put in high efficiency panel units. They've since then put the panel units all on proper hose reels with the digital fill settings and that. So now they're up to the year 2025, 2026. And it's really working well for them. Same idea here. This is a bulk tank opportunities. This is a service truck, and they just simply changed out the regular spin-on heads and they put the Donaldson in with the high efficiency, low micron for their hydraulics. We talk about low volumes now because not everything is done in a large volume. You need small volume. So we'll talk about carts and cabinets. This is what I see in terms of small bulk, just little cabinets, and look at a mess in there. Look at a mess in here. That's not a lot of fun, for if you're a technician. You just put on a brand new pair of gloves out of your thing and you get there and that shit is hanging on there. There goes your gloves, right? No fun. That's just laziness. That's just no control, nobody taking the helm, no leadership. Somebody should really do something about it. If you're storing your 5-gallon pails on wood crates like this, not a good idea. This guy did a pretty good job. He's got it all color coded and everything ready. He's got a spill containment. Problem is he didn't color code the jugs. So each guy that goes in has to decipher which pail he's grabbing. So if it's small bulk, a lot of times you can use the cabinets to put your oil safe containers. You can use a second cabinet and it will house 5-gallon pails. So if I can reduce my 5-gallon pails down to say 5 or 6 lubricant styles, they'll fit in a large cabinet. Sometimes you want to use maybe a desk case cabinet, and there you can put all sorts of breathers, filters, spill containment equipment, you name it, Zerk colored protectors, ID tags, a little bit of toolage, you name it, you can store it in there. Really helps your lube room. Many of my plants have these dedicated lube carts, They'll push them around. The problems that arise here is, like you take this one for instance. You remember there's a slide that I showed that had the big red pails on the bottom and they were all dirty, all cans sticking up? Well, that's their lube room and that's the guy's servicing cart. Like that's a dog's breakfast, right? You can't tell, you tell me what's in that. Now, unless he's dipping his finger, yeah, that's a 220. I don't think that's happening. But nothing's identified, it's just a mess. So you wonder why they're having failures. Over here is an attempt that's a lot better. The guy has marked off what the oils are in these jugs, at least that is done. And then he's got his 5 or 6 grease guns here, and he uses that yellow chalk, to write on it. So he writes down what grease is in this one, what grease is in that. That's all fine and dandy if it's my cart and I can read my own writing. But when I go on vacation and Mike is now grabbing my cart, what the hell is that? So now you're putting the wrong grease in the wrong bearing, you're putting the wrong oil in the wrong systems, all because the guy's on holidays for 6 weeks. This is exactly it. There's nothing detailed what oil is in that thing. There's no badging. There's nothing to say that that's a 220 or an AW. It's got the right idea, but I don't know what it is. So it makes sense to maybe look at some carts, good carts that you can store your oil safe, maybe some oil sample kits, a toolbox, maybe a small little filter pack up there, and you can push it around the floor. At the back end, you've got your greasing, you've got your extra breathers, extra filters. So a nice little cart always goes a long way. We've got some, what do we got here? Yeah, we'll finish this slide and then we'll go for a break. So these are some of the lube carts that are available. We got like dozens and dozens of different builds. The ironic thing about fluid carts is we could have 15 different carts on our website, and the guy would say, hey, I really like that one, but could you do this to it? So I've never sold back-to-back fluid carts. That's wild. But it's fun, though. Like it's an easy tweak here, an easy tweak there, right? And they're back in action. This one's quite the opportunity. I work with a mine site in Newfoundland, and they have some large gearboxes at the back of the crusher plant. Everything's in there under roof, but there's no heat and there's no cement floor. It's all gravel floor, and there's a couple of man doors that you got to go through to get to the last couple of gearboxes, and of course there's no door at the back. So the guys have to put the drums in a pickup truck, get it as close as they can to that third door. Then two guys have to haul it off and roll it 400 or 500 feet down to get it through the doors, and then get it to the gearbox, do the oil change, haul that back, do the oil change, and repeat that 2 times in this area. So the guy says, I'm so fed up. The guys are fed up. They got to find something. So he asked me if I had a motorized cart. I said, well, I don't have anything motorized, not with like a lawnmower engine or something. And then I remembered the guys that were doing my house, and they had this battery operated heavy wheeled unit with a dumpster on it. And they were putting all the cement brick, all the crap around the home, and they'd wheel that and put it right into the steel bin, right? I said, holy shit, I know there's something. So I tracked down the guys that make this thing, and I said, hey, how much can it carry? And we found out that it carries quite a bit. And then I said, can we order it without the dumpster? He says, oh yeah, there's just a flat plate on it. Okay, so he sent me the specs and the diagrams and the measurements, and my designer built me the frame system and the custom tanks, the hose reel for new oil, battery operated, and it had to fit a 32-inch wide door, man door. And that was 29 inches. So he can get through. So that was a solver for him, right? He eliminated possible high-end injuries. Guess how much a 55-gallon drum of oil weighs? Anyone got an idea? It's 310 pounds. So that's not a one-man playing around, right? If you can lift that and start rolling that barrel, I'm not messing with that guy. Because that's a bear. That's fun. That's the fun side of my business. So we're done. Let's take your questionnaires and let's do section 1, and there's 1.1 to 1.5. And when you're done that, let's take 10 minutes.
Online people, it'll pop up on the screen, tell them.
For people online, Mike says that this brochure should pop up for you online.
All right, your mic is off.
Yeah.
Mike's on.
All right.
I haven't met him, but he's one really good. Yeah, yeah.
Yeah.
Yeah, that's the thing, right?
Oh yeah. Yeah. Bill's the owner. Yeah. Bill's the owner. Yeah. No. Bill's here. Do you know Tony Stranges? Yes. Tony works for us. He's our COO now. Yeah. Yeah. And yeah.
Oh, he went.
Gloria, yeah, she's our general manager. Yeah. So we're going to get going, guys.
Right. Yeah. You gotta put time in for sure.
Yeah, that's the thing. Because like a lot of issues.
Hey, guys, we're going to get going.
Oh yeah.
Let's talk about some lubricant dispensing. Again, we looked at some storage, right? So it makes sense to kind of organize ourselves around it, get some color coding going, and make sure that we have a system that can polish and keep the additives rolling around, so it's not just sitting in a barrel for 4 years. What's nice about having it stored with proper dedicated filters is you can turn it on anytime you want and make sure that it's circulating, right? We usually see people doing them, like they'll hold a drum of oil for 1 year in some applications. So every quarter they'll turn it on for 10 minutes just to get the oil moving, right? So excessive contamination is the cause of 75% of all failures related to lubrication. So this is some bulk transfer meaning out of totes and drums. Anytime you've got funnels, that kind of stuff, you're going to have a big issue because people don't clean them out. Down at the, over on the far top right, you've got a massive contaminants over the top of the drum. I don't know if that's an oil leak that's on it or a water leak. The nice part is at least he's got the hand pump sealed, because if he didn't, you've got all that contaminants in there. But what's this thing? That's a breather, but is it a breather? No, it's just a funnel, right? It's just a gooseneck. So anything that's in that environment gets taken into the drum. Here just doesn't fit. It either doesn't fit or they're just too lazy to put it in. But you can see the oil along the edge and all the sand and dirt. Not a very good storage there. This fella here is using a massive air operating pump to pump that compressor oil into the machine, and again, not sealed, just not good for the environment. So the issues here: no oil filtration and no air breathers. So you got to try and pay particular attention on that. So on bulk transfer, anytime you're using bulk, it's always great to have yourself a portable cart. Portable carts are ideal. This one here is what's called the high-end one. It's got all the bells and whistles that you would want. If you're doing good servicing in regards to, I've got to not only do oil changes, but I want to be able to pull the oil out. If I got the right hardware hooked up, I want to be able to do the oil change with the cart. That's why I have a filter bypass here. So that'll take the oil, bypass the filters, and bring it right to your waste oil containment. Then it's simply a matter of hooking up to your new oil tote and flushing the lines. And once it's flushed, you hook them up, put it back into filter mode, and that sucker will clean that drum of oil pretty decently. This one here comes with the before and after sampling devices. It's got the bypass valve arrangement. It's got the Y strainer to protect the pump, and it's got the 2 low micron filtration elements. And of course, we're going to be cleaning out some hydraulic tank oils. That's a simple way of doing that particular task. And then, of course, out of the steel drum, we'll have adapter kits. This is a 2-inch bung replacement. It has the 6-inch tube for the return and the 36-inch tube for suction. And he's got a small little power pack here. Turns it on, it pulls the oil up through the filters and returns it, and you can circulate your tank. Gives you a nice readable ISO code. At the back, putting on a desiccant breather with a 3 micron filter pad in it and color changing desiccant. So anything in the environment that you're doing with your oil is getting protected by that unit. And that comes as a call that a drum adapter kit. It's all included in the little package. When it comes to dispensing and dispensing containers, there's a couple of really nice products that are offered that we carry. This is a nice image though to give you a perspective. A lot of guys will put what's called a gearbox adapter port. You'll notice that it's a black body here with the desiccant breather, and we've got a quick connect hookup. So he's got the female hooked up to the male, and he uses a dispensing container with the actual metering pump. So every pull and push of that unit, you need 10 pulls and pushes for 1 liter. So you can really do your top up, and you can be pretty accurate with it. So if you got a good oil level gauge, you can meter it till you see the oil come out of the plug or in your gauge. Really nice. And that sucker will pump 680 gear oil without hesitating. So nice little setup. You've got your female on the end of the hose. You got your little hook up here. You got your breather on it. So that's a nice little combination. But here's some bad dispensing practices. This is the top view of that food guy's service cart. Like I said, it's just a dog's breakfast, right? Sometimes you'll run into places where they've got to add oil every shift. So they'll take anything and everything that they can find in the plant, fill it with oil, leave it by the machine, and when you're done your shift and the other guy comes in, he can either top it up and continue on. But here's what you get. You get a gas can, unmarked, and no lid on it. And you can see the water on it. It's rain all over it. So you wonder why they're rebuilding a $50,000 gearbox every 3 or 4 years. Then, of course, you got the infamous Princess Auto galvanized steel can with the bendable spout. I love that. You know, you got the nice bend, makes it easy, safe, no drips. What's the problem though? Everything's open. Funnels, look at the mess inside that funnel. Just insane. Water, dirt, sand. Guy's going to need a shower towel to clean that out. It's just not going to happen. So in this one here, I'm going to show you this is the family that we carry. This is the grandfather here, called Oil Safe. They've been around for 40 years. And then you know what happens after 25 years? Your patents become open, right? So then a bunch of people can come up with a better mousetrap. So that's what happened here. So these guys have their kick at the can for about 25 years. And then these guys said, you know what? We're going to do something that people have been asking Oil Safe to do for 10 years, and they won't do it. So we're going to make a better one. And one of the key problems was right here, that quick connect. Because with the quick connect, I don't have to undo the lid. So when I want to top up that jug, I just go to my system and quick connect, and it fills it. You never have to open it. Plus, it's got a breather. You can use a standard 3 micron normal breather or a desiccant breather with 3 micron. The color codes are built into the nozzles. And then they got the protective cap. They got 8-inch and 3-inch, stumpy 1-inch right down to 1/2 inch. And then they got several size containers, very much like the Oil Safe product. But you'll notice that these are the different lids. There's 5 lids and 10 colors. So it makes up for a lot of volume, right? Especially if you're ordering a bunch of them. But it's a really nice product. And of course, you're going to hang badges off it, right? You got the little ring here to hang your badge. You know what the blue is and where it's going. So speaking of that, now you need to look at what? I've got my oil storage labeled and color coded. I've graduated to good containers with the color-coded lids or whatever we're using for color, plastic color-coded badging hanging off it. What is it? That's oil. Now I've got bad lubricant identification at the equipment. Old product names perhaps, non-removable. What's this? Oil. Well, what oil? I don't know. Why is there a drilled hole in the plug? Yeah, to let the expanded gas in the gearbox out, right? If I turn a gearbox off after a shift, it's nice and hot, right? 40C, let's say. Yeah, I turn it off, and I'm not going to turn it on until I come to work the next morning. Well, in Canada, if it's winter, if I bring it to 40C and it cools down to -10, what am I doing inside there? Well, I'm building up a condensation house, right? So that thing there is bringing that, as the heat comes down, it's sucking in air to bring it in. Then I turn it on and I get it to work and it builds up heat. So what happens to the head? Because gearboxes are not full typically. They want to meet the bottom teeth of the lowest gear, right? So if you got a gearbox this big and the teeth are here, you're only putting that much oil. So that means that the 3/4 of the head space is air. So as that oil heats up to 40 degrees C, if that's the running temperature, what does hot air like to do? It rises, right? That's how you get a hot air balloon off the ground. So that hot air's got to come out. If that was plugged, just a plug in there, what happens to the hot air?
Pressure.
Creates pressure. Where does the pressure go to?
Seal.
Least path of least resistance, which is the seal. And it doesn't force the seal out per se. What it does is it takes the metal that's in your oil, especially gears, right? A lot of metal in it. It takes the smallest pieces of steel and under pressure worms it through the seal. And it makes a little 3-micron hole. Doesn't leak yet. Then another one, and another one, and another one. Over a course of a year, now you got a nice little tunnel. Then you start to see some oil. Then another one. Before you know it, it's leaking, dripping on your floor in a food plant or wherever. It's just not a good idea. That's the problem. So they say, you know what, we figured out that it's overpressurized, so we'll drill holes in them. Not a good idea. 629 oil, this is an oil level plug. So the poor guy, let's say I had 50 of them on my run. He's got to pull that little plug each and every time. And if the oil drips out of it, I'm full. Then you put it back. Well, that's time consuming as hell. And what if there is no oil in there? Now you got to figure out how to get your oil over there and put oil in it. What's 629 oil? No idea. Is it a Shell? Is it Petrocans? Is it, who knows? Harmony oil only. Petro-Canada hasn't made Harmony in what, 30 years? Maybe longer? And there's one here, just a gearbox with an oil level gauge on it. What's in it? I don't know. I'm guessing it's 220. So we have to be smarter than that average bear, and we have the tools to do it. We use these plastic ID tags now, and people will do a bunch of different things with them. They just tell us what they want on it. A lot of companies now, you see this one has mobile, Delvac, Super 15. It's not the right badge for this, but the example here is you can put any information you want on it, but a lot of companies now are not giving the supplier name. And the reason is they change suppliers all the time, right? So one minute you're with Shell contract, the next you're with Petro-Canada contract. Well, if all my badges are Petro-Canada or Shell and I'm going to Petro-Canada, they got to replace all of these suckers. At $3 a pop, it's not a fun task. So they just leave it as an SAE 15W40 mineral oil. And they'll color code it green. It'll be mid-green labeled at the top. And some people will put symbols in there. Could be an hour clock, could be a half moon, a star, a rectangle, a circle. And that's to give it 3 identifications. Because not everybody reads, especially English. Not everybody sees right colors. There's many people that are colorblind. can't see green, can't see blue. So that's why we write mid-green or blue or purple or orange, and then the name of the oil. So if the guy can't read, the guy can't see colors, he's shit out of luck. But that's just a simple way of organizing around identifying it, right? Greasing, same type of idea. The Descase family makes these yellow, red, green. There's 10 colors actually that you can get, and they just change the barrels out. They sell the whole gun, as a matter of fact. And then you got the color-coded Zerk identifiers. They're protectors. You take your Zerk out, fit it over, put it in. If it's purple, you have the purple tab on it, and it locks over top of your Zerk, keeping dirt and moisture and all that shit out. And then, of course, you want to keep your tips of your guns clean. They have this nice one here. This is the clear barrel versus the solid colored barrel. These are clear, and the color bayonets are on the end of it. This was designed for the food industry. The FDA demands that if you're going to use food grade in your plant, you have to have it in a clear, because when the inspector comes to your plant, he wants to make sure, he'll tell you, go get me your food grade grease gun. And if you bring it in here, he slaps you with his book and then he writes you a ticket, right? If he sees that and it's got food grade on the unit, you are golden. But that's why that was invented. What's the biggest problem with these pictures? Well, over-greasing, harsh environment, and no ID tag. So we don't know what it is, what grease, where it's going. So this is not this is a sealed bearing, right? What is all this? What is that? That's excessive grease out of the seal. So in effect, what has the operator done to the seal? He wrecked the seal. So if I can get grease out of it, I can certainly get contaminants in it now. It's got a nice little hookup though. I can take a line from there and a line from here, and he just has to put his grease gun on one Zerk and start cranking away. So this one takes much more grease than this one, but he's cranking away. This one might start to leak out first, and then he keeps greasing. This one gets more out, and this one, oh, finally he starts to leak out. So that little application is dual-sided, right? And he might have 20 of them on that belt. If you go down to CRH, down in Bath, Ontario, that's where the actual limestone quarry is. So they blow up the mountain, they bring that rocks the size of your desk, and they dump it into the rock crusher, and he crushes that down to maybe basketball-sized rocks. Then it goes to another set of belts, to another smaller crusher, and finally they get it to about the size of a baseball. And then they run it on another belt, like this, and they run it 3 miles to Lake Ontario, where there's a ship waiting to get filled. The ship gets filled, and he hauls ass up to CRH refinery plant here in Mississauga. And the same process. He now takes those softball size, and then it goes into the finishing mill. And then at the end of the finishing mill, what do you get? You get bags of cement powder. But it all comes from miles and miles of belting. Now, it doesn't take a rocket scientist to figure out, when I lose one of these bearings, what happens to the plant? What happens to the operation? Till that gets fixed. Now, I'm not a bearing and technician. You tell me, could that be a 1 hour job to replace that bearing? Doubt it. Could it be 10 hours? Maybe. I don't know. But let's say the guy says, no, that's 2 days. I got to take that down. When it failed, did it wreck the belt? Do I have a belt? All of these scenarios come to play, and before you know it, you've got the ship empty sitting at the dock charging you $10,000 an hour. Maybe more, I don't know. So does it make sense to be thinking about how you grease and how you identify it? How do you change the scenario? Some other things, right? Like, if that's my writing and that's my gun, I can do it. But I wouldn't ask Mike to take that gun and read it, because I'm like a doctor, right? Can't read doctors' writing. Then you got things like this, just bad housekeeping, right? This is what people get. I like this slide. This comes from the Timken guys, SKF as well. So I was at one of their courses, and we estimate that 3 minutes per lube point. So they say 3 minutes to do one grease point. I said, that's impossible. If I got my grease gun and I got 5 chairs to do, 15 seconds, I should be done all of them in 3 minutes. All of them. But he's saying, no, 1 per. I said, explain that. Well, because the source claims that an average plant employs 2,200 bearings and spends 60 grand in relubrication costs per year. Of the 60 grand, 57,000 is used for labor alone. Oh, wow. Then I look at his labor chart. Okay, where's the biggest one? Working, 35%.
Walking.
Working.
Oh, it's working.
So that means that if you have the grease gun and you've got your list of units you're going out to do, and it's going to take a shift to do, you're only working 35% of the time doing the job. You got travel, you got to go to get the grease out of the thing. Oh, I need a few extra units. You've got the instructions, you got unaccountable, waiting for tools. Holy smokes, we waited 25 minutes at OPG to get the key to go to the lube room, for Christ's sakes. Right? 6 guys. Crazy. But if you add all these up, they're small percentages, but it works out to 65% of lost time. And that's actual in a day. Smoke breaks, brake breaks. It's a neat slide. So when you have greasing, there's some really nice best practice tools. I don't know if you guys use these, but this is just an example of one that I like. And I work closely with the guy from EU on these. But they've got some really outstanding tools. And there's other companies that have great stuff too. But what's neat about this is you have your grease gun, and at the tip of your grease gun's a sensor hooked up to this machine. That little unit is hooked up to the greaser. You'll see this cable coming out, or this one here. That goes to a headset. And that's giving you audible sound of how the bearing is rotating and sounding. This one's running the bearing on the sensor on the tip, and then this right here is a digital backlit unit that's telling you a few things. It's telling you the decibel level that machine is running at, that bearing is running at. If the decibel levels are very high, you know that the bearing is not lubricated properly. It'll also tell you the vibration side of it. So it's pretty good. And then you can dial it in to get it. And then as you start cranking on the grease gun and filling the bearing with grease, the decibel levels come down and you hear it. And then when it gets to a point where it's solid and smooth, you've done enough greasing. If you say you get to 5 grease and then you go to do the 6th, you get halfway and it jumps back up, you stop and it'll come back down. If it stays, leave it. If it drops right back down again and it's noisy again and you crank again and it goes smooth and you stop and it goes again, you got a failed bearing. So it's a really nice tool that allows you to manage that. And of course there's a card in it. Now it's all telemetry. But this one used to have a card like SD card, like you had in your digital camera. You put that in your into your laptop or and it loads everything that was done that day. It loads who did it, how much grease did he put in each bearing, what was the results on each bearing. Oh, he did out of the 10th bearing, 10 bearings, bearing number 6 is faulty. So a real key tool, that people use out in the field. I don't know if this will work. No. You don't have it there, eh, Mike? The sound bite? I don't think so.
No,
it's not on there. But there's online. There's a sound bite called Bearing Lubricated Sound Bite.
Is that on YouTube, right?
Yeah, it's on YouTube.
No, but is that on your screen?
No, no.
It's not linked.
But if you want to hear a good example of that in working, you can locate that on YouTube under UE 401, bearing being lubricated, and it'll give you that one. No, I'm okay, Mike.
Okay.
Yeah.
How many farms are using this? Because
How many? Oh, quite a few.
because from a practicality purpose, especially in the environments we are, it's pretty challenging to do this. You have ergonomic issues, you have water splashing onto you.
Oh yeah, a lot of different.
So we've tried it, but
You've tried this?
we've tried to push it with the millwrights, but it's very hard to get the buy-in from them because
So what are they doing now?
they're using measured like shots where they have a meter where it precisely tells them how much grease there needs to be put in. But yeah, I know this is next level, but
Yeah.
in terms of implementation.
Well, if usually what I find, if the guys are balking on doing something like this, it's because they're checking off that they've greased it and they're walking. It's the only reason. If it's look at the mess in there. I gotta go in there and grease that thing. I can check that off. Anytime you get pushback on a tool, there's a reason. Say, okay, I'm going to follow you in doing your route for the next week. Then you'll say, okay, he gives me his form in 3.5 hours for the last 10 months. Now I go follow him and it takes him 3 hours or 10 hours or at full shift because he has to do it. You just got to, the comment like water splashing on you, that's just part of the job, right? If it's splashing on me and I've got that, it doesn't make a soul of a difference. If I've got it doing this, it's splashing on me anyway. So push back, find out what the real reasons are. It might not be the tool for you. Simple as that, right? It doesn't fit everybody, like that. Maybe it's better to have a nice little sensor on it and let the guys decide upstairs. Don't do that one, don't do that one, don't do that one, but go do that one over there. Because the sensor's giving me the shot. We like using a lot of these products. This is the ATS product. This is a Canadian product. Single point lubricators. Anyone using them? Yeah, if you got the right one, they're really, really good. And it's like trying to buy a car, right? There's like 80,000 of them. But this is the one Lubrigard ultimately partnered with because it's got some pretty nice features. This is called the Ultimate Luber. What I like about it is once you set it in place with the right grease and the right amount of grease, when it's empty, you can recharge it. Whereas the other models, like this one too, he's got a model up on top of it where when it's empty, you buy a new unit. But if you got critical stuff, just leave it on and refill it with the grease you want, right?
So this one is connected with the air also?
No, this one's just in your housing. That's your fill. And then inside that cap is your blinking light. And then underneath the cap is your battery pack and all the brains of it. So the brains, it's a mechanical unit and it pushes a plate that pushes down on the grease. So once you set the amount of grease you need, so let's say you need a 250 mil sized canister with this grease in it, and you need this much grease per shot for 1 year. It'll tell you based on the rotation size of the bearing, and if it says for 250 mil, you can set it for 1 year, and it'll put drops for 1 year to keep that thing lubricated.
Single application.
Yeah. They have other systems where you can do up to 18 lines. It's just a different system. But a lot of single point is ideal.
So when the grease is low, it will give alarm. That
Yes. Yeah.
That's called gravity, right?
Yeah.
By gravity.
Well, no, this is push down. It's got a,
Grease is working as a hydraulics also.
yeah.
You're pressurizing the grease basically.
Yeah, you're basically pressurizing, not through air, not through the gas chambered ones. This is a mechanical spinning plunger.
So probably it has a spring in it.
Yeah, it's a screw. It's a screw unit. Yeah. And the battery, which is the ion batteries, they're good for a year and a half. So you can easily set them up, eh?
So this one is better than the throwaway one.
Oh, hell yeah. Well, yeah, every time you throw it, what do you got? You got environmental issues. Now you got to order a new one full of grease. They have to fill it for you. If they don't have the Kluber high-end grease from England, you're screwed, right? But if you have a bucket of it, you can continue to fill them with the Kluber grease. So it's really flexible that way. That's their lineup of things. This is the throwaway ones. These are the ultimates. Right here's the ultimate refillables. These here are quite, like I've only been with the product a year, and we're getting a lot of inquiries to this one here. This is the actual cartridge style. You just drop them in, and this one's got a sequence. When this one's empty, it moves over and starts pulling grease out of this one. Single one. These can do up to 18 points. Quite a nice system. So why do you use an automatic single point? Well, reduces downtime and bearing failures by 50%. Remember that slide that I showed you from Timken with the 35% of your time doing it? 60 grand was the cost of the program to do it, and 57 grand was labor. How many of these lubers could you buy for $57,000? And then all you have is that open guy, instead of him with a grease unit on his hip, he just walks the floor and manages it, looks at it. Now he's got a CBM chart. How is your grease? Yeah, it's half full. Okay, what does that relate to the chart? Oh, yeah, we should be half full. No, it's still full. It's been running for 6 months and it's still full. Now, there's a problem, right? But it can be helpful in reducing those. Cuts energy cost. Manual lubrication labor by 80%. Wow. One of the biggest problems I find is guys, especially on large motors, you got the front and the back bearing, and the guys just crank it away. And before you know it, you got the whole motor out, you got everything torn apart, and then they look inside it and the windings are full of grease. The machine's down, the line's down. Well, you told me to give it 5 shots every 3 days. Holy shit, who told you that? It was every 3 months, right? But with that stuff, it's the equation's taken out. Beautiful. And your lubricant consumption by 45%, and your closed systems contamination is gone. The biggest thing I find with guys out in the field, they don't take care. The zerks are dirty, the gun tip is dirty, it's sitting in the dirt. A lot of guys will leave the grease gun up in the entryway. Did a Limehouse up in just outside here going to Chatham. Limehouse there. So see his grease gun full of white lime, like crusted. And he's, yeah, that's our grease gun. He says, I don't bring one up, I leave it here. You wonder why he's losing money. His bearings failures are way out of whack. And there it is. So how often do you think he's greased that puppy? Not in a heck of a long time, right? And that's the guy with his grease gun. His grease gun looked like that. So go to your question about, the guys don't want to do it. That guy's not doing it. But I'll bet you dollars to donuts, he's checking it off as done. That's what it should look like. That's with a unit on with a blinker. Centralized lube systems, those are fantastic. Some of them on the blocks, you can put color-coded zones. Let's do 2.1 to 2.5, and then we'll start on the meat and potatoes. The next one will take us to lunchtime, or just before, and if we can get to this lube room prior to lunch, that'll be great. But if we're a little bit late, we can do it in the afternoon. Doesn't take long.
Lunch is right at 12. They should be.
Lunch is at 12. So here's the slide, guys, the section that I think you guys will really get a kick out of. It's called the contamination control. Hey, guys, please. It's called contamination control. I refer to that as where the wheels hit the pavement, right? This is why we have equipment working. It's going to try to work as efficiently as it can and make us money. But if we don't look after it, we're going to have a hell of a time. So it prevents the proven fact that 75 to 80% of all hydraulic machinery failures can be traced to contamination in hydraulic fluids. It's a huge one. So this is a case study of a mill. It's a steel mill. And back on year one, they were having about 80 failures in a year. And then they said, you know what? We can't afford to run our business this way. So they put an action plan. And in the action plan was what? Cleanliness targets, meaning their ISO codes. Sample ports, putting the right sample port in so that every time, it doesn't matter who takes the sample, it's from the representative sample port. And that way there, you got representative oil samples. They improved on the filters and the breathers and on-site particle count. By doing that, after 3.5, 4 years, the improvements they did dropped dramatically the amount of repairs. And then obviously over the next 4 years, with some extra help, they got that thing down around less than 20 failures per year. So the achievements here was 75% reduction in oil consumption and 80% reduction in hydraulic repairs. Now, I don't know if you've ever been in a steel mill. If you have, then you know what size I'm talking about. You're talking about tanks with 5,000, 6,000 liters, anywhere from 4 to 10 pumps, and they're pumping 50 to 200 gallons a minute. So that is a powerhouse of a machine. So these, if you're not looking after that, this thing is failing. It's not a simple part fix. This is complete shutdown. This is 3 months of repair for millions of dollars. So the lost revenues for these guys on 80 failures a year, it's a wonder they're still in business. But they had to clean their act if they want to keep it up. What do you think also happened here? Why did this change? You know what makes that change? The company that owned that steel mill prior didn't do jack, didn't do anything. What happens in our industry in North America, we get bought and out. These companies get bought. And if they get bought by the Brazilians or they get bought from other people who are already doing lubrication best practices, they come to this plant and say, you guys are messed up, man. You need to get your act together. So they forced them into doing this. It's not forced, but you can tell that they said, you got to clean up your act, and this is what we want you to do. And when they do it, then they say, holy eureka, what a plan. Well, you should have never got here in the first place. That's why you sold me your company for 10 cents on the dollar. So why are they doing this? Well, what do we got to get there? So this is the particle size comparison. An ant will be about 1 centimeter, a fruit fly 1 millimeter, and the human hair about 100 millimeters in size. We are going to look at the critical clearance size of many components, and it's going to be around 0.5 to 25 micron. So we're going to be in this zone. And what is that? Pollen and red blood cell. So we're going way deep, right? You're going to see what's causing that. And of course, your additives and your size ranges are going to be in the nanometers and stuff. That's where the ICP will work. It's going to look at stuff well beyond the this 5 micron zone and lower. But it's a whole different apparatus tool, right? It's not the same. We're going to be looking at it through a particle count laser here. And how does it work? Well, let's look at critical clearances. If I have my vane pump up here, you have the vein ring, about 0.1 to 1 micron. Rotor plate, 5 to 13. So if I have no filters on that vane pump or on the system, and I've got contamination with from 100 micron right down to 4 micron, but it's way elevated. How much life I'm going to get out of that? Probably not a lot. We're going to have a lot more problems. How about in ball bearings? Well, we got tons of bearing systems. I just showed you one with that belt, right? With the cement. You got the steel mill with their ball bearings. But that's your oil wedge, and the clearance there is 1 to 2 micron. So that bearing, which is holding that large rod, let's say, it's holding that whole weight on these ball bearings. And the ball bearing is holding itself up through hydrodynamic force to keep it from hitting the metal to metal. So it's the oil that's compressing, right? Holding that bearing where it is so it can spin without getting torn apart. But if I put a lot of dirt in there, I can't get the life. How about here? Critical clearances in a gear pump, 0.5 to 5. And you're going to get this pinch right here, same as this pinch here. That's where the dirt kills you, because it gets crushed in between parts right at the pinch line. And if you've got particles over 5 micron in your oil, you can't expect to get the full life out of that system. And then you have the spools, the valves, and the servo valves on heavy equipment, injection molders, anything that has to do high pressure moves, you're going to have these spools. Well, if I've got between 4 and 13 microns of particles in there and there's too much, they'll get jammed in here and wear it out. Or the oil will just get over-oxidized, heat spots, it'll get thick, you lose the viscosity. You start losing valve spools and replacing and rebuilding your valve heads. They're not cheap. I had a guy just do one, I think it was at your company, the New Forest guys. They did one there last year, the year before. It was a $400,000 punch in the mouth because one of these failed. They sent the whole head out to get repaired, and they asked for a failure report. So the company did the failure report. They came back and says, yeah, your 4 micron particle count is too high. You got to lower it. Wow, the 4 microns is what was winding this thing down, just wearing the crap out of it. So they have to send the whole head out to get rebuilt. So that machine's not working. That's an expensive place per hour. If you're not producing your product, it's big money lost. So how do we go around? How do we make sure that this stuff isn't loaded with particles? Well, we use what's called the ISO code. And it's a ISO 4406 cleanliness code. And to give you the best example, we've got the 3 codes, the 21, 19, 13. The first number, 21, is represented at the 4 micron. The 19 is 6 micron, and the 13 is 14 micron. So those are the size ranges, right? Because most of the equipment, that's what the size range you need to be good at. Well, in this particular 2119, what's it saying? Well, the machine at the lab said that they found 12,185 particles around the 4 micron size. Okay, what does that mean? Well, we go to the ISO code. Between 10 and 20 is a 21. At 6 micron, it's 3,056. It's between 25 and 5 and 19. At the 14, we got 71. Between that is a 13. So my code is 21, 19, 13. Okay, that's excellent. What does that represent? Well, let's look at some codes. So you send me your samples on your hydraulics, and that comes out severe ISO code. And its particle count is 23, 21, 18. I take that oil and I put it on a 5 micron patch, and that looks like the galaxy. Like there's a ton of debris there. And that's on, we only use 10 milliliters of that 100 mil that you send us. So for 10 milliliters of oil, this is what we're seeing on a patch. This is what the particle count is seeing. Like when you can't see through your oil, that's the relationship. And that's the relationship to a 23, 21, 18. Now, if I was going to run it, I'd say, you know what? Is it worth trying to clean this up? If it was 2 barrels of oil, probably I would just, let's start fresh and let's get the tools that I need. Or if you want to spend the money, you might use a ton of filters to get it to here, but that's your choice. You got the cart, you can do that. But if you were to target that thing out like the steel guys did, and you set a new target, you know how much pressure's going there, so you know it's got to be super clean. And let's say you put that 16, 14, 11 in there. Well, that's what your oil should look like, nice and clear. You can see the lines, even the smallest lines. And then I run that over the same patch. Not a lot of debris. Lots of stuff in the submicronic zone, silt and that, but that's harmless. But I got most of the bad things out. And that boils down to your abrasiveness, right? That's third party. That's the stuff that's getting caught. If I'm in an environment where there's a lot of sand and dirt, it only takes a chunk of, say, 5 micron of quartz rock, right? It's 10 times harder than any steel. So if I've got a ball bearing and a raceway and I've got a 5 micron particle there, harder than hell, that ball bearing, when it's got its most pressure, is about 20,000 centistoke. And that pressure pushes that stone into the softer metal, and it just sits there like this. And as that ball bearing or that gear comes together, it starts ripping pieces off. This is what we call an analytical ferrography image. So we do them at the lab here. The diagnostician looks at the wear debris field, and when he sees these chunks like this, he knows that you are in an abrasive wear mode, a severe abrasive wear mode. So now what's your deal now? Well, now you've got to decide, do we change the oil and get it clean and take the remaining particles out? Yeah, that's good strategy. But that's what you got to do. You got to make it cleaner. Got to get those particles. If I told you, this is a 5 micron, and the guy sells you a 15 micron filter, is he going to help you? Can 15 microns take out 5 microns? Can it take out 10? Can only take out what the micron rating is. So you got to look offline typically. Fatigue. A big difference when I do my analytical ferrography slide, fatigue looks like an orange peel or scabs, And the reason being, if that was my ball bearing and my roller, and I've got tons of material in it, well, some of them are going to get by and get crushed. And just the pressure right here will cause these cracks in the metal. And then these break up into smaller ones and they fill the crack. And then the pressure of that in that system explodes. And it just lays out this kind of damage. So we know you're in a failure mode. So filtration will definitely help extend it, but I would say if I'm in this mode of severity and fatigue, what's my next plan? I better have a spare. Better make sure that my guy in Germany has a box for me, because it's six months to get it here. And I'm already in severe fatigue mode. So you have to be ahead of the ball game, right? So if you're not ahead of it, if you're in a stage 1 or stage 2, you're not looking at your oil analysis, you're doing the oil samples once a year, you're going to get caught. So it's important to have the right criticality on your equipment and set up your oil sampling based on the criticality. If it's super, super critical, do it once a month. And what does super critical mean? Well, it could mean a few things. Could mean that the machine, if it fails, is $2 million. And I don't have one for 6 months. I'm going to sample once a month. What if the criticality is, if it's not that big of a box, but if it goes down, I lose the line. And I lose $15 million a day. I am critical. Do it once a month. And do it at ferrography. Don't waste your time. Just find out where you are and where you got to be and how to maintain it, right? And how do you maintain it? Well, a lot of times the machinery just doesn't have filtration or proper filtration. If I got a large gearbox, I can guarantee you there's no filters on them. Comes from the OEM. If it's 30 years old, there ain't no filters. If it's within the last, say, 10 years, they may have given you a filter pack. So make sure that it's got it. And if it does have a filter pack, what's the ratings? Pretty hard. It's pretty hard to filter 680 gear oil. It's very thick. So if they put it in there, it's probably like a strainer style. Micron rating is going to be 40 micron. Not going to do jack for that machine. So depending on the application, the type of temperature you're in, all this good stuff, now you got to isolate and say, okay, what will work in this application? So that's where your filtration company knowledge comes in. You use their knowledge and they'll know all the secrets, right, to help you get along. So this is a 232118, right? We looked at that. It's producing about 9,600 bags of dirt through the pump each year, and that's about 175 55-pound bags. So that gives me about 2 years of pump life. Not a hell of a long time, but that's a ton of dirt. Now, if you had the proper filtration modes in and the right targets set, you can keep it at a target of 16, 14, 11. That transfers to one 55-pound bag, and you extend the pump life to 15 years just by keeping the codes in line. And to back that up, Timken's a huge player in the filtration market in North America, and they put their filters through test stands. So they'll put a known amount of products and particle size into the test stand oil, and then they'll run a set of bearings through the system with that dirty oil, and they'll monitor the filter size. So generally speaking, this is your micron ratings here, up to 41 micron. It becomes useless right down to about 15, 16 micron, where the life on the bearing house is about 3.5 million revolutions. And let's say that was the machinery's OEM unit on it. And you decide, you know what, training has told me if I went to 10 micron absolute filters, I increase from 3.5 to 4.8 million revolutions. That's a nice little step up, but it's not ideal. What happens when I throw a 3 micron absolute on? 12 million revolutions. That's 4 times the life. So your particle counts, your targets, that's where they all make sense. And that's where you really drive your life to not only to the component life, but the oil itself. Keeping it clean, keeping it dry. What about rust and corrosion, right? That's a biggie. We let too much water, too much humidity, too much moisture into the system, and I get some rust and corrosion. When I do my analytical, that's what I'm going to see. This is severe, and look at the amount of rust particles in there. That's not a good place to be if that's coming up. So how do you tackle rust and water contaminants? Well, this is the same Timken idea. And they basically, this would be an idea where you'd have like a paper mill or a turbine system, steam turbine system, something where there's lots of moisture, lots of water. That major tank's going to be contaminated pretty well all the time. So it doesn't make sense to let it go to over 0.10% water. So they will employ these vacuum dehydrators to keep the moisture at 0.01. So the reasoning behind that is you have 0.25 is 1,000 ppm, and what's your bearing life? About 20%. Well, you can't run a paper mill with 300 rollers at 25%. You'll be constantly replacing your bearings and downtime. So they set targets. If you're at 0.01, you're not getting anything. If you can keep it at 0.01 or 100 ppm, what's your bearing life? 100%. Now that's off the test stand. Put that in the real world. It might not be 100%, but what if you could get 85%? If you can keep the moisture out at, say, 0.05, you're doing a hell of a job. At 0.01, you're fantastic. I'm maximizing that equipment life. How do you find your water content in an oil analysis report? What test do we use? Do you know? Carl Fisher. Yeah, thank you. You guys are good. Most people don't know that. But we'll talk about Carl Fisher this afternoon. But that's how accurate it can be, right? We can get that stuff right down to 0.001. And how do you know that it's working? Well, who knows Weyerhaeuser? Does that name ring a bell? Well, Weyerhaeuser is the biggest paper mill for the last 150 years. They're into everything, though, like lumber, you name it. But they're forestry related, right? So they make paper. So in this one here, they have the paper machine bearing replacements. So back in 1980, they had major issues. Back in the 80s, the code used to be 2 codes, 5 and 15. Now it's 4, 6, and 14. But their ISO code was 2017, and their water content was 0.05%. And they had 2 unscheduled bearing failures each month. So that's costing them a pretty penny. And then, of course, they start making some improvements. They replaced the 40 micron filters with 6 absolute filters and installed the vacuum dehydrator. Then they ran a couple of years later, they replaced the 6 micron with 3, and it really dropped. They maintained a nicer 0.01% and a 1613, and reduced by 80%.
Can I just stop you for a sec?
Yeah.
Just give me your microphone. Just swap it with
Is it dead?
I think he left the room and came back.
You mean that they haven't heard any?
No, it's just
You know when you're ready.
Yeah, you're good.
Okay. So yeah, that gives you a pretty neat case study, right? How the heck do you keep it? The beauty about Weyerhaeuser, because they're 150 years old, try and find a company that can give you a 20-year run of wear. It's impossible. These guys, though, can give it to you. So they allow, Weyerhaeuser allows training outfits like ours and Desk Case and RIA. Anybody that's doing this is their case study. Everybody uses it because you can't find this. This is golden. Yeah.
So they use that 3 micron filter on the lubricating oil?
Yeah.
But wouldn't that filter be too tight and strip out the...
No. Yeah, that's always a question. Is there a what's the word I'm looking for? Is there a possibility that it can strip additives out? The question is good because the answer is yes, but not on every oil. There's certain oils that have heavy additives in them, and they're quite large. Like we can't see it, but it's there, like transmission fluids. You'll strip them out. Hydraulic oil, I've never seen hydraulic oil lose an ad pack. Gear oil, very, very seldom. What you see, though, is most mineral oils have additives in there that do certain things, like water separability. Right? You need oil, it has to be built so that when water gets in, it separates it. So a compressor oil or gearbox oil. So the idea is if it's in a compressor, you're going to have water in it after every use. So if you read your service manual, it tells you every morning you go do the water drain off. And you open up the valve, out comes half a liter of water, then you see the oil, you shut it down. If I never do that, what happens? Well, as soon as the machine goes in, it sucks up the water, puts it through the oil, and now your oil becomes emulsified. Try and get water out of emulsified oil. Good luck. You're going to have to get a vacuum dehydrator. So it's important to understand your oil, what's it made of, what's it built with, and if it has good water separability, foaming additives, all of this stuff. If they are compromised, you're in trouble. But that's what you do, is you get that. So yes, there is oils that will be filtered out, but 3 micron up, you're doing okay. Certain products, talk to your oil people, because they'll tell you. But in the standard industrial complex, I haven't seen it, other than automotive stuff, transmission oils and that. This is the breather selection. This is out of the desk case options. So there's a whole family. This big steel one is a replaceable one. You would see that on ships with the big 20,000 liter oil systems. You'll see them in oil farms that have the big 25, 30,000 storage bins. These will be on top, because that's got to breathe. When you bring out, 100 gallons per minute of transfer from that big system into a moving service truck, you're going to pull a lot of oil out. Well, you're pulling in a lot of air. So they'll use these rebuildables. And they make them right down to the small ones. Depends on your application. And then you have the replaceable throwaways. There's a whole variety of family there that is specific for applications, but nice product. Like on this one here, you have the black caps. On the top of that black cap is a 3 micron filter, and in the bottom is a 3 micron filter. And the air has to go through these buttons, through the filter, through the desiccant, up through the next filter, and down into the unit through the core. And it does the reverse. When there's moisture in the head space, it's forced out. It comes up, goes through the filter, through the desiccant, and out to the environment. So you got 2 quick ways of getting moisture out of the gearbox. So yeah, this is a disposable one. This is a hydraulic adapter kit that I'll show you. That's just a complete retrofit. You'll notice that on this one, he's got the sampling device. He's got the quick connect for oil return. And he's got the vacuum gauge to monitor the filters in this. So that's one easy hookup. 95% of hydraulic packs come with that bayonet with the 6-bolt pattern. And then it's got a screen in there, and then a little chrome cap typically. And it's on a chain, right? That's your fill. Not only is it your fill, but it's your main source of air entry for the system. So what you do is you retrofit that with a port adapter kit. It has the gasket, the retrofit bolts. You bolt it right back down. This sample device has a long pitot tube that's cut at the level you want it. And the return line has a return tube cut at the right level, so that when you push oil back in, it's not falling and making bubbles over top of your oil. It's actually penetrating inside the oil and no air bubbles. That whole connection comes again with a separate quick connect that can go down onto the drain. So now you have access to put your filter card on. You put the suction on the bottom connection, your return onto the top connection, and you're golden. Easily serviced. So in this one here, you got low quality breathers, unsealed, no filter ratings. This is just a man-made funnel with a steel cap with a drilled hole in it. This one here had 4 coats of paint on it. That one didn't even have bolts in it. And this one here's a picture I took, and the guys didn't even put the cap back. But you can see all the dirt, right? The mesh size in there is about 1,000 micron. And that's the only breather on that tank. So you can imagine what his particle counts are, right? Do you think he'll meet codes? Probably not. He will if he's got a cart, but he's better to retrofit that. This is a brake machine at a mining outfit in Sudbury. It's a big system. It's got about 2,500 liters of AW32 oil, and it runs, you know, the big drum with the cable that brings the part, sends the box down. You fill it with material and it brings it back, or it might be the elevator unit runs off the same thing, and that's a braking system to stop it. You'll notice that there's our infamous cap with the 6-bolt pattern. In this system, it's full of servo valves, actuators, and all sorts of machinery. Filters are in the back. He's got pressurized sampling device, or not sampling, but pressurized ports to manage the pressures. You can isolate one of those for your sample port if you want. But the idea here is he's got his oil levels, so that's always a nice thing to have. Simply bring that over, drop it in with the tubes. I should replace that picture. I have them now with the tubes. Just drop that in, put a nice desiccant breather on it, and you're golden. Over here, you put the mate quick connect there, and you can do any servicing you want on that thing. If your cart is fully serviced with the bypass, filter bypass hookups, the sampling devices on it, all of that good stuff, now you can drain that when you need to very effectively. Imagine trying to do that now. That's a mess. You'd have to take this off anyway, put a pipe in there and suck it all out. You might as well have the quick connects and use it with no mess, no labor. Works really well. Same example here. At least he's got a nice dedicated breather, a good oil level gauge system. He's got the quick connect down here for really good. He's got his sampling device. So he's ready to do a full proactive endeavor. These are gearbox adapter bodies. Again, you got a return quick connect. You got the vacuum gauge. You've got the desiccant breather, and you've got the body. The beauty about that one is it's three-way drilled. This is dedicated to a hole. This one's dedicated, and the main is dedicated. So if you put an oil gun here or a return or a pump, it's not going to backtrack and flood your breather. It forces it down and into the system. That's ideal. So when you run into trouble, this is where you find it. This is out of one plant. That's the unit here, little filtration pack. This is the gearbox. That's the top fill. It's a burping spring load. So when the pressure builds up, that thing opens up and lets the gas out. If you check your manual, they tell you to replace that every 6 months. I know most people won't touch that for 10 years, and they clog. So if that's clogged, eventually you get leaks, and then you got to replace it. Over here, nothing. It's just a straight plug. So he's going to eventually have issues. This is on the one side of the unit. This is a hydraulic tank with a motor, pump, filter pack, and it opens the big keg so that they can put the fibers in to make the insulation. When I did my walk around, you can see there's the chrome cap, there's the funnel. The filter was broken, wasn't working. You can see it passing out here. And that is his new oil top-up. So every shift, the guy grabs that bucket and he fills and tops up the unit constantly. So eventually that's going to fail, right? So I asked the guy, well, if that failed today, how long would it take you to fix it and get the machine back? Because it's a 2-ton lid that it's got to lift. I don't know. I got to get the new motor. I got to get the pump, fix the filter, get the oil out. 5 hours? 10 hours? Okay, what's your cost per hour? 100 grand an hour, maybe? Well, if I got 5 hours, 500 grand. But this is what we see, right? So these are good gearbox ports. There's another, that's a nice size gearbox. So his oil level's right here. That's a little burping. So if he put an elbow here, he could drop one of these right in. And then that takes care of the top end of the gearbox. What's hard about doing an oil sample from the top of this thing? It's all gears. You can't get a tube down there, right? Hard to get a sample from it. There's no protection. So that's the same mill, you know, with the brake system. That's the big wired tube. And that's the gearbox that rolls it down and rolls it back up. But there's nothing on this gearbox, just a bunch of plugs. So you can concentrate on the top pretty easy. The same sister unit on the other side, this is 3,000 liters. And there's his breather. That's a size of a small pop can. And because it's steel and chromy, that's going to be, in their mind, that's a lifer. That thing will never get looked at, never get changed, because it's made out of steel. Crazy. And not only that, it's like 7 feet off the ground. And then they got the good oil level. That's their drain, a big 3-inch plug. So that's what the OEM sends them, right? The mechanics, the millwrights, they put it in place. It's all plumbed nicely, bolted down. Hell of a nice job. Then the question is, okay, you're going to run that for 3 years. Then you're going to have to change the oil. How do you change the oil? Well, I'll pull that plug. Okay, where are you going to put it? You can't even fit a pan under there. You got 3,000 liters. Well, what do? There's no other portholes. I can't get in. So he's going to have to figure it out. What they should have did is, before they even put oil in it, they should have retrofitted it. Should have retrofitted the top, and then they should have retrofitted the bottom. I'll show you what they should have did in the bottom. These are bullseyes. It either could be this one or this one as your oil level. But if they don't identify it, the guy opens this one and the oil's there. What's he going to get? A pretty nice mess on the floor. So if he doesn't know which one, I would suspect it's this one because it's a different color. But if that is it, and he's got to pull that out to see oil drip out, I think it does. Look at the oil drip already. So that's your oil level. Wouldn't it be nicer just to put a bullseye in there? Now the guy can walk by, hey, there's my oil level. Check. No more messing around with plugs and wasting time and energy.
Normally they take that out also to push the oil out from the drain.
Yeah, you got to take that out to get it out. You need air. Yeah. This is a unit that I worked with a distributor of mine. And they took it to heart because they knew the failure rates on these. And they did the hardware kits, the bottoms, the hardwares, the desiccants, oil samples on the bent tube here. Ideal. So the tops are easy to do, right? Because you can fit them up 5 minutes. After this, we'll go in the lube room and we'll come back this afternoon after lunch and finish off this section. Is this a good sample port? What happens when the guy pulls that plug out and opens the valve and doesn't flush? You get all the crap that's been sitting there for the last month, year, all the heavy metals, all the sand, the dirt, it's all sitting in this pipe. That's a short pipe, so he only has to take a bit of oil out, maybe a liter or two. If he's smart enough, he'll clean it off, but they never are. That's just a nasty environment. What if you had 20 gearboxes like this and they all had this nipple on the end? And now the boss says, hey, I went to a training course. I just bought 12 kits. I want to try this wear check thing. John, go down and start taking samples, would you? You think he's going to pull a sample from there? Well, he might, but what if that thing's running and it's already 40 degrees C? How fast does he have to be to pull that off, drain, put 80 mil in a bottle and then put the cap back? What's the odds of him dropping that cap? Pretty good. And if he does, you think he can put his thumb on there? No, he'll burn his thumb. So what happens? 5 gallons of hot oil go pouring down onto the floor or down 4 floors. I don't know. Not a good thing. So you have to make your choices, right? When you're going to make that investment, you're going to make that change, you have to have it planned out because that's an oil change. And I'm going to hook my hardware once I do the oil change. Same with these pumps and stuff. You can do certain things. But those are poor areas, and that's all there is to it. What's next? Drain ports. Is that just a blank page? I think that was just a... What time do we have, Mike?
11:27.
Okay, let's haul into the lube room area, and we'll look at some hardware and some different things. By the time we're done in there, our lunch should be here, and we'll have lunch. 12, we'll come back at 1:45. That'll give me enough time to get through this section.
And then the lab tour around 1.
Is that what they want to do?
Yeah, after lunch. 1:32, whatever is good for you.
Usually shoot for 2. I like to get them through oil analysis first.
Okay, I'll let Jacob know.
Yeah, get through the oil and then they can go in.
Okay.
And then we'll come back for sampling devices and stuff. So let's follow. I'm going to start just by showing you guys already have this machine, but for my audience, just going to talk about the system and some of the key benefits to it, and then we'll talk about the dispensing containers and hardware kits, along with some breather technology that we incorporate with them. So this is going to kind of mold everything that we just learned in regards to oil storage, dispensing, and contamination control. So this is one of the only Lubrigard product mixes that I make under the Lubrigard name through a distributor out of Kitchener, Ontario. They build this for me, and I promote it to the marketplace, and it's a very economical piece of equipment that we've got here. So my demo unit here is showing us one large bulk tank, which is about 550 liters or 145 gallon storage capacity. The upper one is 265 liter or 70 gallon. The reason why we want that is you want to be able to put a full barrel of oil in there. There's no use having 50 gallon and you're going to be stuck with barrels with 2 or 3 liters in them, right? So you want to be able to have that over capacity. What's neat about it is we'll start from the bottom up. You got the spill containment pen. That is 40 inches wide, 47 inches deep, or long, and it's 10 inches deep. It'll hold 110% of this larger tank. So if we had a breach and it drained overnight, it's not going to be all over your plant floor. If it was this one that breached, I got a lot of capacity. Then as we move up, we've got the steel frame that houses everything. We got the platform, the steel legs, and the steel feet that allow it to sit into the spill containment pen very easily. The next thing is we added a drip tray, and in that drip tray is the drip tray holder and then 3 plastic cleanable drip trays. You put your cans on them and you can fill them up without any mess is the idea. Then you've got your poly tank. It has a breather, so we're connected there, so anything that goes in and out is breathered through a 3 micron and desiccant for moisture removal. So if in the summer where we have high relative humidity, every time we take 5 gallons out, air's going in at 5 gallons, right? But we're taking out the particulate that's in the plant and the moisture that might be in the plant. So you want to have these good rated desiccant breathers. On the right side is all our nomenclatures for gallons and liters. So as soon as I put fluid in there, could be water, it highlights and you know exactly where your levels are. And it goes on all our tanks. The next thing is this custom built steel framing system. That's bolted right onto the steel tank. It's got some specialty molded inserts in it that can allow us to put that in. That plate houses my filter head and my piston pump, and that allows me to use 2 directional valves and quick connects and a filtration media. So depending on what oils I have in, I can get down to as low as 4 micron, and I can bring it up to about 12 micron for heavy viscosity oil or heavier viscosity. The idea is on the back side of this thing is my hose holding apparatus. So each tank is color coded. Blue, this one here I need a blue sticker, but this one here is purple. If you look at my hoses, I've got a suction hose and a dispensing hose, and I have my color coded bars. So blue, purple, so whichever oil I'm going to be bringing in the canister, I can then transfer that by using the suction line and the nimble little, what do you call that? The drum adapter kit. So the drum adapter kit would go in a 2-inch bung. You hook up your lines, and that'll transfer oil through the pump, through the filters, and back into the tank. These valves here allow me to open them so that I got the flow that I need. The side ones are arrowed on the side, so I know whether or not this will be your suction. I want it to pull up and up into the pump to my hookups to the tank. That's transfer mode on the bottom. I check my top, it's going back into the tank. So now I can transfer the oil, no problem. If by chance this was in the wrong mode, it would just stall the pump. As soon as I would, it would start the pump up and start flowing again. So some good safety there. If that was off, the pump would stall. So it has to feel that it's fully open to be able to get that air piston pump to move. If it's not moving, it's probably you got a valve in the wrong direction. So once that's done and you got your oil stored, you would put the drum adapter away and the suction line away. Now what you would do is put this one in the reverse mode and this one in the tank, and now I can pull the oil through the filter, from the tank through the filter, and return it. I can circulate that oil. That'll give me the particle count target that I want to meet. When that's done and you're happy, now it's dispensing. I could put my dispensing hose on with the trigger, put it at the top, bring this lever here to pull oil from the tank up through the pump, through the filter, and run it to this point. So I would turn that one down. So now it's pushing here. Once I click on, it's the dispensing handle that's going to start and open and close the pump. As soon as I want it to fill the container, I press the trigger, it feels the release, and it starts pumping. I fill up my containers, everybody's happy, a lot less mess, everything's secured, color-coded, we're ready to go. The next step is not only that you have it stored properly and you can do all these fancy things, but you better make sure that you have the right containers. So at Lubregard, there's a couple of container manufacturers that we use. One of them is the grandfather of them all, which is the oil safe. And then we have our desk case ISO-Link, and these are quite unique. But you can see that these come with quick connects. The color code is the shroud. So what I like about the dispensers is it's guaranteed to hopefully keep your oils identified, and if you do the right things, keeping the shrouds on, you prevent dirt from getting into them. So they have 11 colors now. They've added a color which is white to both mixes, so it gives me 11 colors to choose from, which is a lot of colors really. And then from there, you just decide on what style you want, and whether these are all different lid styles. This one here is just a nozzle style. So you can get a nice 8-inch long one or a 3-inch, from 1-inch opening to like 1/4 inch. So depending on the viscosity of oil and where you're going to dispense it into, you look at those options. I'd say the most popular ones are the 1-inch and maybe the 8-inch nozzles. And same with this one. You would use I don't think I have one out here, probably in the back. Would be the stumpy lid is what they call it. Then you have to look at your equipment. You have gearboxes, you got hydraulic systems typically in the plants. So if I was looking at doing improvements on a large style gearbox, something that's rated at a 10, let's say in the criticality, it should have a rating there of 10, and let's say it has 5 gallons or more oil in it. Well, that would be a good candidate for oil analysis, and it would be a good candidate for hardware to be able to service that unit, because a lot of times when you're going to take a sample from it, it's going to be an issue of contamination, right? So that means that we can filter it typically if it's not all beat up, if you don't have acidic and the viscosity's pooched on it, you know. If it's simply dirty and it needs to be cleaned out, then you would be able to service it with a filtering equipment. However, if you only have the sample and you don't have any hardware on the gearbox, you'd never be able to incorporate the filtration opportunity. So the best case team has developed for the industry these hardware kits. So this is just simulating a large gearbox. So gearboxes would tend to have an area where you'd have a plug for a drain and a plug at the top to fill it. So that's kind of what you have. And a lot of the newer gearboxes, they're made to go in different orientations, right? So there'll be ports all over the place. But depending on how that is in your plant, you can isolate one for a breather and adapter kit. You can isolate it for a drain. Sometimes you don't need the level. You can put a bullseye type opportunity for oil level if it's up in here. This one's showing us more of an opportunity where it's an older style plant where they have gearboxes that could be 50 years old. Back in those days, big units, they only gave you the drain and the fill. No other options.
That's what we have with most of them.
Right. So now we have to think outside the box. If it's got, say, 100 liters in there, well, if my sample comes in and says, you know what, everything's nice with the oil, it's just dirty. It's got an ISO code or something's in it. Visually, you can see it. Well, let's put the filter card on. Well, without the hardware, you can't do it. So then you would say, okay, well, let's fit it up with the hardware. So on the bottom drain, I would take the oil out, right? Do your oil if it needs an oil change, or if it's still good oil and you're implementing, drain it out into a container. Set up your hardware kit. This one here has got all the doodads that I want. It's got the level gauge. It's got the quick connect for your cart suction. It's got the pitot tube for sampling that runs a tube inside the cavity of the oil area. And it has a sediment jar, so it'll look at the oil that's in the gearbox. If there's water will seep to the bottom. You drain that off. You inspect it before you turn it on, because water will shed from the oil over the shutoff period. So you can take the water out. But the whole thing is designed to give you an opportunity to be more proactive with the unit. The top end is your protection. I've got my desiccant breather. I've got my 3 micron pads that are inside it. It's locked into a 3-way ported body. This is a vacuum gauge to manage the breather. If the breathers are clogged, it's trying to pull air, it'll pull the vacuum spring, and there's a little red tab that'll fold into the view area. You press the button, and of course the unit pops back into green. You come back an hour later and it's back in the red. Probably your breather filter is plugged. On the other side, there's a dedicated drilled hole. That's where I would put the return of my oil. So sometimes I may want to add oil to bring it up. I got the quick connect. If I want to put the filtration cart, I click the suction and the return and I can run it. But you'll notice they're different sized, so it gives me that opportunity for less hookup problems. I got my color code badge, so I want to make sure that the oil that I'm going to take from my unit into my jug is blue, and my blue tag matches my unit tag. I've got my little filler. That's hooked up. I got my oil in here, and it just fills it up to where I need it. If it's a full oil change, you might want to use your filter cart to fill it.
Yeah.
Right? It takes 10 pumps per liter. That's a 10 liter, so that's 100 pumps. If I have 100 liters, you've got 1,000 pumps. Pretty hard on the arm. So you'll use your cart or some kind of transfer powered unit, right? But that's the simplicity of managing a gearbox. Hydraulics, the same idea. What we would do is we would, your tanks are all these.
Yes.
They're bayonets, and on that bayonet is your breather, but it's a fill cap breather, right? That's where you fill it. If I rip that open, the odds of that being 40 micron are probably pretty good. They can get down to about 2 micron, but they'll seal off real quick with dirt, and you won't even know that it's blocked. So now what you've done literally is you've stopped the opportunity for airflow. So that'll cause havoc on some of the sensors on your equipment if it can't read the pressures properly. So the idea is you take the bolts out, you toss that into the waste. Now you've got an open hole. You purchase one of these hydraulic adapter kits. They're designed to have the same bolt pattern. Put your gasket, put your bolts, tighten it down. Now that's a lifer. You never have to remove that again. The beauty of it is it has dedicated portholes in the bottom, and you just basically put your return hose pipe, your return pipe, and your sample pipe. Measure out the depth of your tank and the level of your oil, go 50% of that depth. Now you're pulling your oil from the middle section of your oil level, which is perfect. You're not down at the bottom sucking up all the crap out of the bottom. You're not at the top where there's no dirt. You're in the middle, gives you a good representative sample. You hook up your point, you got your vacuum pump with your hose and your connectors. Same on the gear, same on here. You vacuum it up, you've got a nice sample. Send it to the lab says, you know what, the oil's still good, but it's not meeting the ISO code. So you bring your filter cart, you hook the one on the bottom of your hydraulic tank, you hook this on the return, turn the tank on, or the filtration media on, and you service that unit. Without thinking further ahead on this stuff, you're going to have a hard time. A lot of guys I'll see, they'll take all these caps off, take the screen out, and they'll jam 2 pipes in there. You can do that, like knock yourself out, but you got no breather protection, right? So you have to think outside the box, make the investment once, and you're done. Any one of these things, you're probably looking at less than $500 investment per machine. That's with the first breather. Very, very economical to make that move, right? So together with these ideas, you can use the pumps with your quick connects, your filter carts. If you need to pour oil in and you're not going this route, you can need something to pour in, you can use these dispensers. Very simple. This one, of course, you got to open to fill it. You know, it's what we have. But the new ones have the quick connect options, right? So you can fill them with quick connect as long as your pumping station has the mate. Put the mate on, fill it up. Unhook it. Always have your rags, put it in the spill unit. Everybody's happy. If you've got all your jugs color-coded, they're filled, ready to be used, get a few cabinets in your lube room where you can store all this stuff, right? This one here is just my parts and stuff, but you can imagine it being a lot cleaner and designed for your plant, right? You might have a container or a cabinet with 5-gallon pails in it, or small liters and stuff. Well, that's a good way. The second cabinet could be for your oil safes and pumps and that kind of stuff. We also make a cabinet has all the parts, shelving in them, little plastic parts organizers. So that gives you a full range of managerial opportunities for your lubrication program. And of course, a variety of desiccant breathers to fit all our needs. So when you're working, when you're in your plant and you leave here today with your 50-page report that's going to come, start thinking about this. It's all going to lay itself out for you. And you just have the choice. Do nothing or do something. This is a do something, and it's world class. I didn't invent this stuff, but I preach it because I live it. And anyone in the marketplace that is doing what I'm doing, that's what we preach, and that's what we know has the best results. And this is the equipment that allows us to give you the best results. Any questions, guys? No? Okay, thanks everyone. Yeah, feel free to give me a ring or an email, and I can help you through this stuff. Thanks, guys. We'll go back to the training class. Did okay? The sandwiches are nice and fresh, right?
Yes, thank you.
Yeah, good salad. Yeah, they always do a good spread for us. Sometimes we order pizzas, but it can be a hit and miss, right? But this is okay. There's more there if you want some, by all means. So we're going to move on and finish this section. So we had a chance to look at some stuff in the back room here, but this is, I guess we'll start back over here. We're talking about drain ports, right? And some of the bad areas that you're going to get caught in. Well, these are some of the drain port assemblies that you can look at. A lot of times it's a combination of adding things together, and it depends what you want to do. Some people will use this on an oil level gauge. They've got a swivel and they'll bend a tube down, or it'll be straight into the box with a tube bend up. They use the swivel. I have a lot of customers that will order up. I'll see a PO come through for 40 of these things. So my next question is, well, here's what's going to happen. They're going to put them in place. They're going to start pulling samples. They're usually for gears systems. And guess what you're going to find? Nothing but problems. Gears that typically come back in not great shape because they're gears. There's no filtration on them. So if you're doing particle counts, you think you're ever going to see a red or a green? No. Doesn't matter if you change the oil once a month. It's a gear system. Until you put a filtration media that can keep a code, then you'll start seeing some good stuff. So that's the secret. I can get as many good samples as I want. The question is what am I going to do with the data? If the data is saying that large gearbox with 15, 20, 30 liters or gallons is severe ISO code or severe wear or abnormal wear, do I just change the oil and run it another year and it comes back the same, change the oil? No, you got to step a bit further into the proactiveness. So now he's got to take that out and he's going to say, well, now that I know what I'm getting and it's not good, I better do one of these. So now he gets himself a filtering system. He puts that on the drain in the top, and now he can start filtering it. Now guess what? Now his program goes from red to yellow to green. Now he's got green to work with. Who's happy? Customer's happy, boss is happy. The investment was well worth it, right? So taking samples is cool, but it's going to lead you down the trail. If it's all green, then that's a great, but I tell you, I've never seen a gearbox anywhere come green till you pay a lot of attention to it. So that's what I'm saying. If I pull samples from this puppy, there's no way he's giving me a green sample. Not a chance in hell. It's locked off. There's nothing here. He'll have condensation. He'll have wear metals. There's no way of getting it out. Well, he can put a straight pipe like this right here with a quick connect. He can put the top one on with the breather. He can do a bullseye. Then that's manageable. Same with this one. Same with that one, right? So how do you got your samples, you've got the results, you don't know, you know you're in bad trouble. So what do you got to do about it? Well, 95% of the time, it's a filtration issue. You either have water that's got to be taken out, you either got particulate that's got to be taken out. If your sample says your acid numbers are pooched, your viscosity is gone, your ad packs are gone, you got to change the oil. It's a simple fact.
Just want to add one comment over here about draining. Most of the time, unfortunately, in the industry, we are taking the samples when we are actually draining the oil.
That's a good, here's the secret. That's a good one for guys online. The question, I don't know if it was a question, but the result is a lot of companies in gear systems, hydraulic systems, if there's no ports, they're doing it on the oil drain. That's an okay way, but the method is half drain sample, meaning that if I've got 20 liters in that gearbox, I pour out 10 liters, and then during the drain, 10 liters come out, it's still draining, you can take your sample.
But maintenance is not doing it that way.
No, you got to be trained. They got to understand why. It's like doing an engine, right? Engines typically don't have ports. They don't invest that way because the machine's coming in, say at 300 hours on the 300, and that's OEM rules. If it's a highway fleet truck, it might be 20,000 kilometers, that kind of thing. And they just do the drain and they take their sample, but they do half drain. So they're trained to do it. And that's all that's missing. It's not that it's a bad idea, but you have to do half drain. So sometimes little gearboxes that have let's say you got 12 inches of half-inch piping in a little open close valve, and you only got 10 liters, guess what? That piping plus everything, I got to drain out 3 liters, 4 liters. Might as well do the oil drain. There's just not enough oil in it. So that's where pitot tubes come in.
So it becomes a sample during the half volume of the drain?
Correct. Yes. Yeah. So, yeah. Yeah. That's why ports and devices are so important, right? Because it allows you to leave it in operation. You want to take the samples on a nice, warm, hot oil that's running and mixed. If you got to shut the machine down to get to it, you do the sample within an hour. If it's an engine, you do it within 10 minutes. So it's nice. You can shut them down, but you will see fluctuations in your sample results. But 95% of the time, you're going to have a contaminant in there. And it's not that it's not fixable. You can fix it. Like if it's water, you can get water removers. If we know it's less than 1% water, but it's flagging, you can use water eater filters. If it's got a gallon of water in, say 45 gallons or 50, 100 gallons of oil, well, you can use a different media, like a depth filter media. Nice big 24-inch by 6-inch depth filter, like our Gold Series. That will hold a gallon of water. And if you have a double stack unit, that's 2 gallons of water. Not a lot of water. If I got 2 gallons of water in my system, I'm in big trouble.
I'm actually was dealing a problem that was actually a spiral freezer in a bakery. And they were freezing the dough, so it was like minus 35.
Oh yeah.
And the spiral, they were driving the spiral drum with 5 gearbox which are synchronized. Each gearbox was about, I think, 30 horse. So, and the problem was that they were washing the spiral, and the gearboxes were vertically straight.
Yes.
So the water was
coming down and in.
It was going through the motor into the freaky gearboxes.
Oh man.
And the water was actually freezing inside and damaging the gearboxes.
Unbelievable.
So in that condition, what is your suggestion? What should be done?
Well, how was the water falling on the equipment?
Because they were washing the belts and everything, and the water was just coming like a Niagara Falls.
Yeah, they got to seal that off. If they're going to wash down, you got to seal them off.
But even forget about the water side.
Yeah.
What about the condensation?
Oh, that's almost impossible because of the condition. You're in a frozen condition.
So the gearboxes, those are like SCWs.
Yeah, yeah.
So how?
You'd have to experiment with it. I'm doing some mixers at Maple Leaf, and it's in a cold fridge area, and we've got water going into the hydraulics because they're washed down. And we're getting the water out, but I got a funny feeling that the temperature is not releasing the water out of the oil enough, and it's clogging the depth filter media very quickly. So I don't know what the final results will be.
I'm suggesting let's spark the water which is being used for washing. Let's spark that out, that it's not going. But still, because of the low temperature,
yeah,
and then the gearbox is running, and then it's stopping also. And then the temperature is still cold, so you are basically freezing it. So how we can recover from that condition?
Your guess is as good as mine. You'd have to really look at it and have a filtration, maybe the filtration people look at it, but testing's going to be everything.
So for the water, we we worked with SCW and we make some ports which was taking the water through, so it was not staying in the gearbox. We did that part, but I was thinking about the filtration system which you are talking about. So not filtration, sorry.
The bowl,
Um,
the sediment bowl.
Plus, actually, I'm talking about the way you have check valves and you can release.
Oh yeah, on the desiccant breather.
Yes, I was thinking about that. That can that be installed to help?
Yeah, it probably would help. Yeah.
Because we are
But-
trapping
yeah, you got to try. You're going to have to try several things. One of the guys, like the Cargill food plant, he started using the Donaldson trap
Donaldson, okay.
because it has the flash off media, kind of like my DN35 there with the polymer on the filter. But again, they do a lot of wash down there. I haven't heard back from him if that was successful, but not as cold as you. He's not even in that bracket of coldness, right? So he was okay.
Even any meat industry where they are freezing the meat.
Yeah, in the freezing side, yeah, but I haven't worked with it, so I don't know the solution. But it would be a combination of testing and trying air breathers, trying water removal, and see if it can keep ahead of it, right? If it does, that's great, but cold and water don't mix very well with oil. So, yeah.
Ask you a question about that gear sampling example.
Yeah,
you
yeah.
Just mentioned. So you said if it's 20 liters, you have to drain 10 liter and then start.
Maybe not 10. It depends on how long your pipes are.
Okay.
Right? If you had a 4 foot 1 inch diameter pipe, you got to get that flushed. So there is a calculation that you can do to do it.
So I was just wondering if you are draining a significant amount of oil, you get a sample and you have to top it up.
Yeah.
So you're topping up
With new oil.
By the time you get your used oil analysis, it doesn't really
Won't reflect the new stuff.
Like
Yeah.
the mix that you have.
Yeah.
So any corrective action that you want to do, it's just on a completely on an improved.
Yeah, it's always an improved condition, right?
So it's
But
like not really applicable if you don't have a good sampling.
it's better to have topped up with nice fresh oil than it is to leave that oil in with all the crap in it, right?
That's what we were doing it also. Like every 3 weeks, just draining the oil and putting the fresh oil.
Yeah. That's what they're doing, but it's costly.
But
So,
it helps actually.
oh yeah.
Breakdown is more costly than that oil.
Oh, but that's what's happening to Maple Leaf. So we wanted to try the cart to see if we could extract enough. I'm waiting to hear from him how his befores and after filtration. Yeah.
That's a good point. Actually.
His complaint was that
Your battery's not plugged in.
Hey.
Here, take mine for now.
Where's my? Oh, I didn't put the power pack on.
Here, use that one.
It's not the same.
Oh, it's not.
Excuse me, guys. I forgot to put the power pack. I'm surprised that it even lasted that long. Oh, Mike, I hope I didn't leave that at Elmer's. Nope, it's right here. No, I'm telling you. The course is over. Can you plug it in over
There's
there?
one
Jim?
underneath here. Just look under here.
Oh yeah, right here.
No, under here.
Good.
Okay.
Okay, I guess we'll move on. Is everybody okay? Did I answer your question?
Yes.
I can't remember. Did I answer it? Yeah? Yeah, fresh oil is better than no oil, I guess, hey?
In this problem, can they use heated blankets on the gearbox?
Good question. I think anytime you can get a heater in place is a good idea.
Keep it at 25
Right?
degrees or something.
My God, I recommend it. It's just, do they have the budget to heat everything up, right? Maybe even put a heater on the cart, maybe.
You are fighting actually against it because if you put heat trace around the gearbox and you have a minus 35, the heat trace is gonna go hard and the refrigeration system is gonna work against also.
There you go.
So there is.
Yeah, it's not going to work.
There is no win.
Yeah. I think it's And I'm working with the guy too to try and solve that. So I'll have more info for you. It's just going to take a bit of time to get the data. But thanks, guys. Those are good questions. Let's talk a little bit about filtration, right? We have a couple of opportunities. One, back in the day, filters were nominal rated, right? Meaning nominal. Today, they're called absolute filter ratings. Nominal would be somewhere in this example, you use a known or just a bunch of different sized particles upstream. Then you have a 5 micron nominal, and you can see the holes, just as an example, larger capillary holes, right? So you pass the oil flow through here, and then these big particles and that get caught in here. Well, a 5 micron nominal, the largest particle to get through can be as high as 20 micron. So it's going to be very inefficient at keeping your hydraulics meeting your targets. It's just not going to work. So over the years, when particle counters came to the industry in early 80s, like I think 81 or 82, is when the good particle counters in labs started to come in. So filter media people started really investigating what can we do, because now they knew 5 micron wasn't working, right? Because the testing was telling them. So they started messing around with filter media, different types of filter paper, fiberglass, cellulose, you name it. And what they did is they put it into a same idea with the size of particles, but they run it through an absolute filter, and guess what? They found that the largest particle on these absolutes would be 5 micron. So you could play with the micron size and really get that particle out. But the next thing they had to consider was the efficiency of it, right? So you say you got a 5 micron filter and it's an absolute, but it's beta ratio 2. All right, what does that mean? Well, for 100,000 particles, you divide it by 50,000, gives you a beta ratio 2. So 100,000 particles up front, and we took out 50,000, it's only 50% effective at 5 micron. That B here, is that X microns, that's the size of micron. So here, for instance, is what size? He doesn't tell you here. Oh yeah, he's got a B5. So that's a B 5 micron equals 100,000 over 5,000, or a beta 5 micron equals 20. So that's this one. Not bad. He goes up to 95% efficient. Today's filters are beta 1000s at 5 micron, makes it 99.9% effective and efficient at 5 micron. And if I went down to a 3 micron, it would be 99.9% effective at 3 micron. So you play with the micron size and the beta ratio to really find out where you stand. It's quite a system. I would say 10 years ago, if you tried to tell me that I could get a filter at 3 micron and I could push 680 gear oil through it, it would have to be at 40 C, mind you, but I could get 15 to 20 gallons per minute through it. It was impossible to do. 3 micron, beta 1000 at 20 gallons per minute, 680 gear oil. Never ever going to get done. Today, with these types of elements, that sucker flows through there like crazy. There's just no issues. But it's just the way they built them. The technology of these filter houses and the money they spend on it. They know their industries, right? Boy, it's amazing what they do. But that's a great slide for you guys to go find online if you need to go and find out what your beta ratios are. Most filter companies, when they're on your carts and that, they'll show you 3 micron beta 1000 or beta 200. That's what they're trying to tell you. If there's no markings on it, run to the hills, right? If it's $50 an element, run to the hills. It ain't going to do nothing for you. Make sure you get your beta size and the beta ratio. Where's the best filter locations? Where do you get the most bang for your buck? Suction filters. Well, suction filters generally would be in your hydraulic systems, and it's a big screen that's in the tank, and it's right before the pump, and it picks up dirt and debris before it gets sucked into the pump. Therefore, not a very good spot to put a low micron screen, right? Why? Because the low micron screen is going to pick up all the dirt, and then the oil won't flow through it, and you'll starve your pump. Just won't work well. And it's costly. What about the return filter? Well, that's not too bad, but if I find out that my system's coming back, it's pumping from the tank, going through the system, through filtration, goes through all its components and back to the tank through the return, and I've got this return filter there. It's there, but I won't break any codes typically, because it's one pass. It's picking up the cigarette butts, let's say. Right? It's just not very effective, not very efficient. The second thing is it's on low pressure, right? There's low pressure going through it. So it's gravity kind of idea. Filter elements that are rated at the higher beta ratio, they love pressure. So you need to put a certain amount of pressure through them. And when you get that pressure through them, they're able to absorb and get more efficient because they're soaking up more and more particles. And as they pick up more particles, they start to get the differential, and before you know it, they're in bypass. But this isn't a good area for that. How about the system pressure filter? That's sometimes you can go there. You can go with combinations, but pressure filter is designed by the OEM, and it's designed to allow the machinery to have the right amount of flow. As soon as you start playing with their idea, you are in risk, right? If it's under warranty, you better make sure they give you the blessing, right? If you start playing with pressure, it's going to work. Like low micron's going to work, but it's going to shut your systems down. If you've got sensors, anything like that, it's going to do like the beeper. Hey, I can't take anymore, right? That's the way they work. But they're designed that way. So what's our best bet? A lot of times it's straight offline. So straight offline can be represented by two types. One, you can have it on wheels, and you can move it from machine to machine to machine as the samples come through. So let's say I have your 15 or 30, where's my injection molders, guys? Let's say at your place, you got the 30 machines, you do your sample every quarter, and out of the 30 machines, 10 of them don't meet the code. Well, you can take your carts, put them on, and then the next time you do your samples, these will still be hopefully green, but the others might have 2 pop up. So you just keep rotating it through, and that'll keep control of it. But the most ideal way is to use offline as a kidney machine. So you attack it by putting a machine right on the system. It's designed to handle the amount of oil that's in there and the amount of flow you need to keep ahead of the game. That's really the ultimate. They build them now where you have everything on the tank is monitored by that offline system. All your sample ports are there, your gauges are there. You can have lit up gauges that start green and turn red when they're clogged. They can use water removal, varnish removal, you name it. You can build it to what your problems are. And once you've figured out what your problems are, you can attack it. But offline is always a real ideal way to be looking at filtration because it's customizable and it's reliable. You know what you got, and you know the filter ratings that you got, and you know how much oil it can take and how much contaminants it can take out. Ideal situations. And when you have offline, this stays in better condition, this stays in better condition, and your suction filters stay in better condition. So if I can triple the life on these 3 by using one simple little filter, I'm in the bank for money, let me tell you. That's where you're putting your dollars invested. It really works well.
Are there any filters which can get rid of varnish?
Yeah, I sent off some information to Nayan on it. Yeah, that's our next project, trying to de-varnish some of those large friggin' vessels there. So here's some filter media styles. You have metal mesh. You see that a lot in the military zones. They're a lot more money, but they're washable. So guys that go this route, they'll have them in spin-ons. They'll put that on their equipment. And when the differential pressure goes off, means they're full, you take them out and you put them in an ultrasonic bath, and it just removes all the contaminants from the filter, the metal mesh, and you reinstall it. These are not spin-ons. These are drop-ins. It's like a nice round cartridge. You take the bowl off, you drop the cartridge, and you put it back. When it's full, you take it and you drop it into the sonic bath, and you put your clean one back and you spin it back on. So you're not replacing the spin-on bowl and the filter that's in it. You always have the housing. But it's a nice system. I don't have any out there. This one here, cellulose. That's your beta 200s, like your not Donaldson, but your Harvard style and my Gold Series Y2K. They're the long depth filter media units. Those are very efficient at removing particulate, water, and varnish all in one. And then you get into your fiberglass builds, which is the organic fibrous, so fiberglass and synthetic compounds. What's nice about that is you can really break low ISO code, and you can pound a ton of pressure through them. They don't care about water. They don't care about varnish. They only care about particulate. So that's one of the downfalls, is you're going to get a very clean oil if there's nothing else in it, right? Because that's what they're designed to do. But if you start taking samples, you bought this carton, it's a fiberglass, and hey, my particle counts aren't coming down anymore. What's going on? Well, you find out that the oil's 10 years old, and you just put another 5 years on it. Guess what the particle counter's reading? Varnish. So you've left it in too long. You haven't done any advanced oil testing to find out what condition the actual oil properties are in. You're just doing particle count and acid number. If I got a 10,000 liter tank, I'll never see acid number. It's too much oil, too much out. You got to do advanced testing. This is the family. You got little handhelds, portables, depth media, barrel handling carts, heavy duty, those nice high polishers, high volume, low micron, and of course some vacuum dehydration. For permanently, you can put a panel system together and lay it on a system. Small gearbox panels. These are hydraulic kits and engine kits for heavy equipment if you want. If you've got your injection molders and you want good protection, you slap one of these hydraulic kits on and there goes your problems.
They can be inline?
Yeah.
So that means the system is running and...
It pumps it through there. We use this is a 5,000 5,000 pressure reducer unit. We use them on heavy equipment, but it can be adapted to any hydraulic system through the pressure of the unit.
And they can be connected to a multiple...
Yes, you can put 4 of these on if you want. It takes your full pressure off of your main sending units, brings that 3,000 PSI down to 55 PSI, which then drives about 2 gallons of oil per minute through, and then through the dense filter, and then it returns to the tank.
So how it will gonna keep that same level, let's say in 4 units?
It's series. One fills, the other one fills, the other one fills, the other one fills. And once they're filled, they stay. They're all tied together through the bottoms. But that really works well because you're able to maximize whatever you want to do with the hydraulic system. So if I have a $3 million excavator and I take my samples and the ISO codes are out of whack and there's a bit of water in it, drop one of these on and watch those disappear. And that's like having a mini refinery on your system every minute that thing's running. So if you have 100 gallons of oil and that's doing 2 gallons per minute, doesn't take long to pass 100 gallons of oil through that thing. And if it's running 24/7, I'm getting about 25 to 30 oil changes a year in that runtime through this thing. And the only time you change it is when the delta P ranges out. And the only way that ranges out is if you put moisture in it. That system works on adhesion and absorption. Adhesion is any particle, sticks to the fibers of the media. The absorption side of it is the water. So the way the filter is designed, it has what's called capillary holes, and those holes pick up the water goblets. And then when they get filled, they swell. And that's the only reason that gauge will go off.
Pressure drop.
Pressure drop. If it was just particulate, that thing can last a year. They come out of play when you pick up moisture or varnish because it's filling that capillary hole, the absorption side. Engines, the same thing. You put that on an engine, you want to see a 300-hour oil change, say 500 hours on 150, 200-liter excavator oil tank. Throw one of those on it, and you'll bring that thing to 3,000 hours, not 300 hours, right? Just because that's the percolator, let's call it.
If the filter is taking in water and gives you a fault DP, will it be present when you're doing the oil analysis?
Oh yeah. Well, if you swell that up with water and the pressure differential takes off, does it mean that it got 100% of the water? I don't know. But your sample, if it comes back and you're still at, if you had 1% water and you installed that, you changed it out, and then you put that might take a year if some more water comes in. But I can't tell you, how long does it take to suck up a gallon of water? I don't know. It's like my guy in Maple Leaf, 3 hours, and the filter's clogged.
We've got a situation where we are changing filters, like 5-micron filters every, it used to be 2 weeks, now it's 12 days. And I guess Nan might have spoken to you.
Yeah, and I can't, and the problem with is the sampling's not finding anything. We even did filter debris analysis, and we're not finding anything. I told him to put his good cart on it, get some low micron and see what it does to that. If it fails those at 12 days, then you know you got a big problem. But I don't see it in the oil, so I can't answer it. Then, of course, you got your high capacity for high industrial tanks. That's ideal. That's the money saver right here. Any plant that's got 1,000 liters or over, 10,000 liters, if you don't have that in place, you're playing with fire. These are fantastic things. So let's do 3.1, and then we're going to jump into oil analysis, and then at 2 o'clock, we're going to go through the lab. So finish 3.1, 2, and 3, 4, and 5. Do you know the unit number of that unit by chance?
That's called as a base glue shake. Base glue shake, that's what it is.
I wonder, would that be the name that they have it in the system as?
Yes,
Can
and
you-
it's the same one which you guys do.
Yeah, that's what I'll ask Gloria to pull the last report. What's it called? Base lube?
Base glue shake.
I don't get the.
Base duo shake.
So we'll talk some oil analysis. So Ray Thibault is a good friend. He's no longer with us, but he was instrumental at the CLS, the Certified Lubrication Specialist Trainer. So Ray and I did a lot of trade shows together. Super smart guy. Had key hands-on for building that CLS course and training.
Oh, did you leave the room?
I did.
Give me your, I need your mic. Can't leave the room. So let me reset.
Got the other one?
No, I'll just reset it. 2 seconds.
Don't leave the room. That's why you don't say, I killed her anyway.
That
know
guy?
that show? Went to the
Guy's an
bathroom.
idiot.
Said, of course I did it.
Doing
His
20
mic
to
was
life.
on.
20 to life.
His mic was on.
Sing Sing.
How is it? Good. So oil analysis, right? So Ray has a little comment here. Oil analysis has proven itself time and again to be an invaluable technology in industrial's quest to bring longer and longer service life out of the equipment. And that's the whole point, right? Reliability is all about our life longevity to the component. Oil just happens to be a major issue in regards to how long you're going to keep the equipment running. So it makes pretty positive entity to make sure that our oil is as clean and dry as possible at all times to achieve that. And the way you do it is through oil analysis. So you need to implement an effective analysis program. You need to set up the program right. So setting your program targets and goals is number one. You need to determine responsibilities. This is very important. I'm going to show you an example case study that cost a guy $15 million because they didn't give the right responsibility to the right person, or they just didn't give him the responsibility. Just let him do whatever the hell he wanted to do. That's going to hurt you. Determine machines to be sampled. Yeah, absolutely. That's huge. If I have a plant, and let's say I have 4 hydraulic systems that are nice, but I have 400 gearboxes, and out of the 400 gearboxes, I got 20 that are, say, 30 liters, but every other one of them has 3 liters. Well, does a 3-liter system fit your machines to be sampled? Probably not. I'd love it, right? That's 300 samples times how many you do a year, but I don't think you're going to be doing, a $50 sample on 3 liters, unless it's super critical. But the bigger ones, 100%, get them on. So you have to determine which ones are going to fit that role. Now you need to look at your sampling points, where you're going to get a representative sample, what kind of hardware are we going to use to get that representative sample, if it can be done, if you got the budget for it. Collect machine information. That's where most people hit the wall. They give the lab a bunch of equipment, and they give them a name, the type of oil that's in it, and that's it. So the poor guys are waiting there trying to find out, well, what is it? Is it a gearbox? Is it a hydraulics? How much oil? What oil's in it? What viscosity? What make and brand? There's nothing. Can you please do my oil sample for me? The worst sample we ever got in here, somebody sent us a sample in a rubber glove. The fingers are all bloated out. Take it out of the box. Everybody in the lab just fell on the floor, right? But sample information, collect everything and anything. Not only does it help us, but it helps you guys, because someday that guy that's working there is going to move or get promoted or something. You want to have the data. And if you're using this system here with the differentiators, boy, once you have a clean equipment list, the sky's the limit. Now you need to select a laboratory. How do I put that? In Canada, there's probably 10 labs, but really the certified labs, there's really 4 or 5, and they're all pretty good. I think WareCheck's the best out of it. Obviously, I wouldn't be here 35 years if I didn't think so. We have a spectacular crew of people, a spectacular service. So by all means, if you want to give us a try, if you're not using us, absolutely give us a shot. And we'll show you that we can do what you need to be done. You have to perform the correct testing, right? Would you do a industrial hydraulic injection molder using a Mobile One test kit? Are you looking for fuel in your injectors? Are you looking for soot? No. What else can we find in an engine? Thermal degradation? No. So yeah, there's lots of stuff. So you want to be able to put the sample in a proper container with the proper information so that the laboratory can put it through the proper testing and then give you the proper recommendation. So going back to a select laboratory, guess how many labs there are in the United States? Over 300. Guess how many reputable certified labs there are? Maybe 15, 20. Maybe. So that's a lot of snake oil people. So if you find a guy with the best price, this guy's $35, that guy's $50, but this guy's $6. You know what's easy to do? It's easy to copy a report and put in your own numbers, right? If they can't give you a recommendation in your sample report, and he says, yeah, we found iron in your sample. Not where it came from, not what to do about it, not what to look for. Just there's iron in your sample. Run to the hills. If he won't allow you to come and visit his laboratory, run to the hills. Because odds are he's a snakeman, right? Take corrective action. I have so many clients do an oil analysis. They get the report, it's red, they file it. They file the next one and the next one till it blows up. Then you go back and the guy's all mad and you say, well, look at you had 18 severes in a row. All ISO code. Here's your recommendation on all 18. Use offline filter cards. Change the filters. Check to see if you got rated breathers. All this stuff is noted in your recommendation. Did you ever put a cart on it? No, I don't even know what a cart is. And why are you doing sampling? Boss told me to. I got to appease my ISO code, my ISO people. Holy moly. Talk about a backhander, eh? So corrective actions, you got to react. We talked about that wear check V2. If you have a list of equipment with us, we will provide you with these tags free of charge. You can put them on the equipment. You can put them in a binder, like a hockey card binder if you want, in the shop. Or I can print you out, or you can print out right from your web check, a booklet that labels everything with the code and alphabetically all through your system. From A to Z, or 1, 2, 3 to 1, 3, 4, and all the way down. So if you got 100 units, they're all labeled out. Guy goes out, he puts a little tag on this that says this is unit, that's the chainsaw slasher, and it's unit 101. Once that's in the system, that unit is that. So there's no mixing it up. Guy doesn't have to write it, doesn't have to put anything. Just puts the tag on here, the unit, marries them together on the app, press submit, it's ready, send it to the lab. We know exactly what machine that is and where it's going. And then, of course, that's how you get the samples there and you manage it through your app. But we are able to send you you could have it once a week, once a month, once a year, as a KPI data sheet telling you how your program's working and how effective you are. And these are all dashboards to help you find out. One of them that's really fun to watch is we get calls from customers that says, don't use them, it takes too long to get the sample back, the report back. Then you do a management report, and one of the key things it shows is, here's how long it took the customer after he put his system in. This is how long it took him to get me the sample. And it was 22 days. So he scanned this in on day 1. We got it 22 days later. We turned it around in a day and a half. But in their mind, we had it 22 days. And if you didn't have your CAPEX, your KPIs, who would be right? Who would be wrong? That's a quick way. If you're in management, you're trying to manage a program, you want to know how your people are doing. Let's say you're running 4 plants across Canada and you want everybody to be doing the same thing. Well, guy in Calgary doesn't believe in oil analysis. How are you going to know he's taking his samples if you don't have anything? Then you phone up Jerry. Jerry, how come you got no samples? I don't believe in that. Well, sorry, man, but you either play ball or I'll send you home. Oh, when do you want me to sample? But you got to have matrix, right? You got to have this stuff. That's the beauty of this stuff. What's the role of oil analysis? Well, we got to be a predictive tool, manage abnormal wear modes, determine proper oil change rate, detect environmental and process contamination, and of course, you got your proactive maintenance, evaluate your filtration upgrades, evaluate your lubricant type and brands, 100%. Effectiveness of maintenance improvements, confirm the maintenance activities and root cause analysis if you have to. But that's really the role. You got to know what you have and what the machine is telling you. Once you know that, you can react. You can be proactive. This is for new oils. Not a lot of things to do. Some people send new oils. If you got real crucial stuff like turbines and stuff, send a new sample every now and then. Just make sure that you got the right oil and it's got the right properties. And that's the new oil stuff. The R's are recommended by exception and as required. Where it really gets technical is in your routine oil sampling. That's not counting the advanced testing. So the routine testing, we'd have the blue as fluid condition, the gray as contamination, and red as wear. And of course, on the top, we've got gear oils, hydraulic oils, diesel oils, turbines, air compressors, EHCs, and EHC minerals. And it'll tell you what tests you want to do, right? All the way through. Hydraulics, you want appearance, that's automatic. Viscosity, yes. Acid number, yes. And then what else? Carl Fisher could be added. And then oxidation, RPVOT, these are all advanced. They're on optional. Particle count, number 1, right? Viscosity and particle count. And then, of course, down here, you have your ICP. Our lab doesn't have to worry about you guys having to select. If you tell us what industry you're in, you go into an industrial plant, that's our industrial offering. Industrial 1, Industry 2, Industrial 3. Now we have a plant offering. So you send us anything in the plant. It's one price, same bottle, but you send us whatever you want. If you've got coolants in your plant and you want to send them, you've got compressor oil you want to send, you got gear oil, you got turbine oil, whatever it is, we don't care. If you're on the plant, we take it all for one low price. In the construction fleet, the yellow iron, everybody in that industry does their engines. Because that's a big component, right? They're changing that oil out constantly. And what's the killer of an engine oil? Right? The biggest killer for any engine is coolant. If you get a glycol leak into your motor and you don't catch it, you'll blow your motor in a month's time. If it was like a faulty gasket or head gasket starts to leak or whatever the case and you don't catch it, if you were doing your oil analysis on that, you'd catch the potassium and all of the coolant additives, right? Then the results would be, hey, you've got a coolant leak. We recommend you inspect it. So the guy would take the engine, do the pressure testing. Yes, it's the gasket, fix the gasket, change the oil, take a resample in 10 hours, 20 hours. If it's gone, it's gone. Everybody's happy. If he doesn't do it, that $4,000 gasket replacement blows the engine. Now he's got $100,000 engine to replace because it just doesn't fail easily. Glycols are very, very aggressive to internal units. And what happens is it's like a gel, and it gels up the piston rings. And the piston can't move up and down. And eventually it comes down and it can't go back up. So there's so much pressure there from the explosion of fuel that when it can't go back up, what's the weak point? The piston arm. So the piston arm breaks off. You're flying down the road 80 kilometers an hour, and it can't take it anymore. Guess what happens? That arm breaks off and it goes right through the block. Now you got a hole in the block of your engine the size of your head. You can look in there, and, hey guys. And now that's 100 grand. Because I didn't know there was glycol in it. Holy moly. So if I'm running a fleet, if I'm running my own personal truck, it's cheap insurance, right?
I've seen that one on a 1 megawatt generator.
Oh.
The piston block.
It's a noise. But we do all that. So we can pick this out and we'll set you up the right way. But if you're doing industrial twos, 90% of the market does an industrial two. And you'll notice that these here have twos beside it because sometimes you're doing hydraulics. If you're going to do hydraulics, we're going to do acid number and we're going to do particle count along with these, right? If you're doing gearboxes, you're going to do Carl Fisher and PQ index. That's what you do. So when you send us your equipment, it's imperative that you tell us what it is, and then we'll put the right test on it. Yeah.
So there are certain applications like on a higher temperature side.
Yeah.
Like plus. So we are talking about like in the ovens.
Oh yeah.
Temperature's
way up.
300 degrees, and we are injecting oil. So let's say it's a spiral oven. Where the bread is going in the trays through the spiral and they are spinning inside, and they have like a chain and they have the wheels which are like bearings.
Right.
So you are injecting oil every few hours to keep the lubrication there.
Yeah.
So if those, let's say those bearings sometimes they fail.
Sure.
So what type of analysis we can do?
Is that oil, when you're spraying oil, is it a recuperated oil or is it one use?
No, it's just one time use. It just evaporate.
There's nothing you can do. There's no testing.
In terms of those bearings, so we can take them and...
You'd have to send it to the bearing house for that, but they're going to tell you it's heat, right? Like you can't swab the oil out of it on a swab and send it to the lab. It's like CSI, right? Oh, we wiped the guy cleaned his pistol with oil, so we got the oil and we put it through the ICP. No. Yeah, it sounds good, but no.
There is always some kind of a residue like lube in the tracks or on those wheels or on the chain itself. So if we scrape that out and no, it's not gonna help.
No, it's the animal of the animal, right? You know that's the issue, is the heat. Unfortunately, as far as I would recommend. We can take a nice sludge, break it down, but I don't know what you're going to find other than it's degraded, right? Degraded through heat.
Yeah.
And that's up here, acid number.
Some of them are rated for high temperature and has some silicone oil lubricants.
So this is our ICP. You're going to see that in the field. But ICP determines where components detects process and identifies incorrect makeup. On the example up here, this is a engine up here. And these are your add packs. So he's telling me he's using SO Nudo H32. But when we do the test, it comes back all different. So we have about 15,000 oils in our history, in our database. And when we see this, we can probably expect it to be a super plus 10W weight oil. So they put a whole different oil package in that unit. So we can find that right away. And you notice that the viscosity didn't change. But it's just the wrong oil, from what you're telling us. Down in this one here, what do we got? Right here, process contamination. So here we just took the problems. Iron showed up in the ICP. It's supposed to have a limit of 100. He's at 328. Lead jumped from 40 to 68, but sodium, potassium should have nothing. He's got 384, 336, and that basically is fly ash. So it's an ingress in the plant of fly ash getting into his oil and screwing with his baselines. So we know what it is. So he's got to, what's his answer? Got to check how he's topping it up. If he's got his jugs around where the fly ash is flying around and they're open, he's going to get it in there. If he doesn't have rated breathers, it's going to get in there. So he has to make a good analogy of where is it coming in, because if he doesn't fix it, what's his life expectancy now? Probably not very good. It's going fast because it's super abrasive, right? So how do we got? Oh, viscosity. That's the number one property of oil, is your viscosity. And it takes work to understand it, because everything has more than one viscosity. One's like a hydraulic AW goes from, it could be a 15 to 100 viscosity. Gear oils can go from 150 to 3,000 centistoke oils. You know, from a light there to almost a solid. It gets so thick. But viscosity is what allows us to understand how that oil is working in terms of what its viscosity. So you can either have high viscosity above what the oil should be, or low viscosity, meaning it's lower. And that's how we do it. So for engines, we do them at 100 degrees C. So these oil baths are heated. So let's say that's an engine bath. It's at 100 degrees C. We've got 4 ports here. These are all tubes. The oil is picked up from the robot, and it's an engine oil. He drops it in there, and it rates it. So it starts a finish line, heats it up, and then goes start line, heats it up, and times it to where it hits the finish line. If it goes too fast, means I've diluted it. It's too light. If it takes too long, it's too thick.
Same like concept of Ford car, like a funnel with a nozzle.
Like a funnel.
And the timing.
The timing is everything.
Okay.
Yeah, exactly that. Yeah, you fill it up, it's stopped, you hit the start, and it heats up as it goes through, and that's your viscosity. So up in this one, here's an engine sample. We took the sample, did it through here, and here's 4 months ago. Everything seemed to be nice and normal. No fuel dilutions, good viscosity, no wear metal. But what happens when I start having an injector leak? Well, I got 5% fuel now. My viscosity dropped, and my iron, it's jumped, but still there. I run it some more, and he jumps to 12%. I drop half of my viscosity, and now my iron is gone to 163. So what mode did I put that machine in? Fatigue, abrasion, or adhesion? Adhesion, right? I don't have enough film. So I got metal to metal contact, and it's pulling itself apart. That's because I don't have the right thickness of oil protecting my parts. It's too washed down. On the bottom one, I've got industrial samples are done at 40 C. And in this particular one here, you look at acid number. He was in line at 3.2. His viscosity was good at a 64.8, and his copper was okay. But soon as he started to get acidic, he jumped to 4. Viscosity got thicker, and his big jump in iron, or copper. And then, of course, he got to 6.8, which is super acidic. His viscosity goes to 174, and he doubles out on his wear. So undetected, what happens? He runs that to failure, right? You can't fix it. So that's the analogy of watching it and how you get. When you get acidic in an industrial, that's the lightest material, right? in your system. So this is from a compressor using mobile Delvac. So that bearing is letting go. It's leaching out the copper side. This is a thrust bearing example from one of our hydroelectric guys. And this thing here, was it hydroelectric or? Yeah, hydroelectric plant. So this thing started vibrating and they took it apart, and that's what they found, these big fatigue holes in the bearings raceway. And then when we did the sampling, we found that right in this junction of time, they weren't using a 60 ISO 68 oil anymore. They dropped it down, and they probably got it down to like an AW or a turbine oil 32 weight as opposed to the 68 weight. And soon as that went off, he got metal to metal. Additives were right out of whack. And because it's too light, he pulled all the metals out. So when they've seen this in the results, they did the inspection. And that's what they found. Big stuff. The poor thing about that is they were going into a shutdown, so they said, you know what, we're going to shut it down in a month and a half, 2 months. Let's put it back together, run the machine, and we'll tear the whole thing apart in 2 months. They put it back together, ran it, and it ran for 7 days. And it shook so bad that everything that was lined up on that unit, all on the cement piers and shit, so, the whole length, it shook so bad that it took everything out of misalignment, broke the cement pads. So it took them, that would have been an easy fix. I don't know how much, call it 20 grand, 100 grand, I don't know. But now it cost them $3 million. That's a bad one. Acid numbers, that's what you want. You want to know how bad or how acidic it is. Acid numbers start low and then they creep up over time. And of course, as your acids creep up, what happens to your viscosity? Will it go up? Will it get thicker or will it get lighter with acid? What do you think, guys? Make your viscosity thicker, right? So if my viscosity oil gets thicker, it picks up more debris, it does a whole much more damage, and you'll also see your acid number affect your particle count.
The more acidic, the more the higher viscosity.
Yeah, it thickens your oil.
And it needs to be thrown away.
Yeah, once your acid number's out of whack, it's an oil change, yeah. This is one here for an acid number. You can see the gray line here is your, that's an oil change. And then he runs almost a year, does another oil change. His acid number's holding out well. And then the red line right here is additive depletion. So something went on with the oil additives and he shoots right out of whack right after. So the material from that corrosion etched out his parts on that particular compressor. So you can follow it pretty easily. Particle counts, I think we talked enough about that, but that's what you're going to try to do. You need to implement the right strategy. 1917-14 isn't written in stone. You need to understand the component that you're dealing with. If it's high pressure, you need to get better codes. Almost every piece of equipment, heavy equipment, you name it, the OEM will have the ISO code that he wants you to go after. And then if he says that you need a 16, 12, 10, 12, 9, then you got to make sure you can go there. If you do your samples and you can only maintain a 18, 15, 13, it's not going to be green because this code's going to be much lower. So you're going to have to do something. And usually that's offline because the current online stuff just can't reach it. This guy here, he went way out of whack, lost all of his particle counts. Then they finally, after months, got it back into operating condition. And again, it's guys that aren't paying attention. We give them the recommendation to go out and check what the hell's going on, and they don't. So we said, you know, there's something going on. Either somebody left a hatch open, or the filter clogging indicators are not being watched, or if you have little indicator lights, they might be malfunctioning. Go check it out. So they sent the guy down, and he looked and he says, yeah, the lights are still working. He said they haven't gone in an alarm, but the switch was broken on it. So the light was staying green. Didn't matter what they did. So then when they finally fixed the switching, it jumped to red right away. But it took a long time to get it back under control. We talked about water and corrosion, right? And how do you manage water? Well, you do it with Carl Fisher, and that's our system here. And it's very accurate. It goes from like 0.001 to 25%. So it's a lot of water if you're at 25% water. Holy moly. But that's what you want. You want to be able to use that proper tool. When you get stuff like this, 340 ppm, that's like 0.03%. You can't see that, right? And we're trying to shoot for what? 001. So if I'm in a bearing system that needs 001 and I'm 034, oh, I'm going to have issues. But I'll never see it with the naked eye. Got to do Carl Fisher. This is a good one here. This is a big box. This is 3,500 liters of Shell O'Mala. And there goes his water. Never had water before. And then all of a sudden we shoot the 9. He changes the oil, does a new sample, no water. Then he does it a month later, boop, water. Does it again, water. Does it a third time. He thinks our lab is smoking something because he's not reacting. It must be us, right? It must be the guys in the lab out there tooting in the backyard. Finally, we figure it out. But look at the damage. He let it go, but look at the metal that was pulled out. Now he can't backtrack that. One thing, guys, when you go from a green to a yellow to a red, if you get a second red and a third red, you can't backtrack it. You have now taken the sacrificial layers off of the gears, off of the system. You can't repair it. So now what do? Now you got to put it on a fast track of monitoring. So what used to do every 3 months, you're probably once a month now, because you are in wear mode and you don't know when it's going to fail. Because the material will never stop coming off now. This is a beauty here. What time we got, Mike?
Almost 1:50.
Do we have enough glasses?
Oh, I didn't check. We should. I'll check.
Okay, thanks, Mike. So here is a analytical ferrography slide. This is what the diagnosticians will look through to see what modes you're in. And they'll show you how they make the slide makers, but basically it's a glass slide, and there's a little drop of oil that's being pulled across the slide. And on the bottom of the slide is a magnetic field, and it's pulling all the ferrous metal out. So it starts off with all the sand and the paint chips and the fibers, and as it goes across there, it leaves the trail of wear metal that's ferrous. Then they take the slide, they pre-treat it to give it the colors that we're seeing. If they didn't pre-treat it with heat, it would just be all silver. But as soon as you heat treat the slide, they'll show up in different hardened metals. And this is how it looks. He started off with the hard metal, meaning he was in the casing, didn't do anything. Then it got into the under layer. Then he got into the babbitt, and now he's pure metal. That's the final one. So he actually blew that machine up. And that only took, what, April 99 to January 2000. So 1 year. And there's his sample run. So what do you do with a guy like that? Probably Siberia, right? Just not paying attention to his program.
I have a question. Is any one of the systems of what you showed us here has something like alarm if there is a water in?
Yeah, there's lots of sensors for that you can incorporate into your CMMS. Yeah, lots of sensors. I don't have sensors, but they are available for water, moisture, there's indicators. A lot of my, like all the guys in the cement industry all the way across, all of their gear, all their crushers, everything, have heat sensors, water sensors, moisture, particulate, oil, plus they're sampling in the lab. And it triggers. If something goes off, the machine doesn't start till they fix it. Yeah. So this one here, look at this. This is one, remember when I talked about when you're setting your goals, determine responsibilities? Well, this one here is a beauty. So I used to work with the guys over at the car plant just up the street here. And we started working with those guys, and the guy that they sent me down to work with was an experienced 35-year veteran in maintenance there. Really nice guy from England. And he, with 35 years, guess what else comes with that? 6 weeks vacation. And that guy used to take off for 6 weeks every summer and go back to England. So left everything to who cares who. But his boss didn't care, his supervisor didn't care. He just left Harry to handle everything. And there was 20, 25, 30 of these boxes. They're called a Simonic transfer gearbox. They're not big. There's only like 30 liters in them, right? But they were 300 grand a piece, 250 grand, something like this. And that's what moved the van at the time around the plant. So it would go around the bottom floor, get all the assembly of the drivetrain, and then it would come to a certain gearbox, and the gearbox claim to fame was they'd put these 8-foot ceramic lights, you know, the long tubular light bulbs. They'd put that on the rail, and the Simonic gearbox would come underneath it and pick them up and bring them to the second floor without breaking them. That's how freaking precise this was. And it was going to pick up I don't know, how much does a frame of a truck or van worth at that point? I don't know, 2,000 pounds maybe? That was the key. But he was doing the sample on all 30. And before he left, he said to his boss, look, I've got 3 gearboxes here that we're doing analytical ferrography, and this one in particular is not doing well. So I would suggest that while I'm here, we change them out, because once I'm gone, I don't know what's going to happen. Yeah. You know, the old yeah man. So it comes to pass. Terry takes off, and he forgets about it. Nobody's looking at the reports. We don't even get to the next sample. And this is what happens. So that there, all these big chunks, what is that? Is that abrasions? Nope. Yeah, so what mode am I in? I know, but there's 3 modes. I have abrasions, I have adhesion, and what's the last one? Fatigue. So he ran that sucker into a fatigue mode, severe fatigue. So here's what happens. There's the tooth, rips off, jams in the raceway. Now that machine can't turn anymore. So one downed gearbox shuts the plant down because you can't move the body around. $15 million hit. That's a big no-no. So if you don't give responsibility to a champion who's going to oversee the results, make decisions, have the authority to make the decision, and they don't, this is what you get, a $15 million crack in the head. You don't know you're in a fight until you get punched in the face, just like Mike Tyson says. But they got it. They got it hard. What time we got? Oh, 2 o'clock. How are we doing, Mike?
13 glasses, so half. I don't know if you need them in this part. Do you need them in both sides?
You better ask Dorian. I don't know what's in here. No bottles.
Some of us have glasses.
Yeah, might help. I got some spoons. Couple of coffee cups with some holes in them. Sorry, guys. That's what happens when you're out of town for a week.
No, I used to so I did HVAC for a bit, and then I worked at like a salon job. Like, did you guys just do cylinders all day? Yeah. Just massive lines, saws, CNC machines, assembly.
Well, what if we just put the video on?
Yeah, yeah.
Put Billy's video. Can we do that?
Technically, yeah, we could.
Well, let's just do that. It's going to be. I can't do. You know.
Oh, yeah, yeah, exactly.
Let's have one little
Yeah,
quiz.
yeah, no, literally. And then the office side,
All right, we'll watch different kind of tire. We'll watch a video instead. Okay.
Well, let me see how many slides I have, and.
Are you at the? You're still in this section still?
Yeah.
Just kind of always gotta be on. Yeah, like you're always looking for the next sale. Exactly. So it's like, but you can never use like every day really. I kind of just want to put my head down and do my job all day.
I only got a.
Job is talking to people. So you have like so much small talk, right?
Yeah.
Yeah.
I got one more slide, Mike. I'll just do this slide here,
Okay.
and then we'll. If you can find the video.
Some of the old ladies.
Oh, I could run the video from here.
Could you?
For like 2 hours. I'm like, yeah. Oh, really? Yeah.
Yeah, I can
Oh,
run
I
it.
gotta go.
Just, we just have to unplug the USB and plug it in mine. Or unplug this cable, plug it in mine. When you're done.
No,
that
I'm
slide.
done. Let's just put it on.
Okay.
It's only one slide.
Just announce it.
Okay.
Oh, yeah.
So, guys, my apologies. I don't have enough safety glasses to get into the lab, but we're going to get the video from.
Tomorrow, Paul's going to be talking about the various tests. That's kind of oil analysis day is tomorrow. So come on in. So we receive all our samples come in by courier, and we get them early in the morning, and samples are broken down. Every sample will come with a QR code or a sample form or something, and those are scanned into our system, and then the samples are all put into sample racks like you can see behind you. So that process happens here, and then everything comes in through the lab this way. Our racks are all numbered, so we have like a day on our rack. Every sample gets a unique lab number. You can see on the top here. And we also have a rack and position. So we have good continuity on samples. The samples sitting here are samples that are in process. So as samples get completed, they'll eventually be moved into intermediate storage, and then eventually they'll go into a lawn storage we have in the back. So we'll keep samples for up to 2 months in case you phone and need a retest in something or need additional testing done. we keep those samples. But every sample is going to go through a series of batch tests in the laboratory that are pretty common. And then depending on the type of equipment it's coming from and the type of testing package you purchase, we're going to do additional testing in the laboratory as well. But everything starts with a visual screen. And all of our samples here, inside here is a little picture box. And the samples go in there and we actually take a picture through the oil with a clarity scale. And we take a picture from the bottom to see if there's anything visual. And then the technicians are actually entering in any visual information as well into the computer. So this is kind of a guide for techs. But they can report up to if there's visible white metal or yellow metals, or if we see precipitates or dirt or silt, if it's layered, if it's cloudy, if this can be indication of varnish or water or air entrainment. The clarity scale gives us an idea of the clarity of the oil. It's nice, so when you're looking at your sample reports or you're pulling samples up in WebCheck, you'll be able to actually see a trend of any color change or any haziness being created in the oil with this visual scale. So this is an important part of our process because this can trigger additional tests. If we see an unusual amount of debris in the bottom of the sample, that can trigger it for going for a particle debris patch and then go into the room over there to get microscopic examination. So then we'll be looking for abnormal types of wear. And that all depends on the type of system. I mean, if it's a hydraulic and we see a little bit of metal, that's going to get a filter patch and be examined. If it's off of a differential, off of a large construction equipment, we expect to see a little bit of metal. But if it's a lot, then that would get a patch and be examined as well. So, we use our own sample bottles. It's very important to the process. First of all, it's a PET bottle, so it's a type of plastic we use that's stretched, so it won't deform when you put a hot oil sample into it, but it's also clear, so we can visually examine if there's any visual debris. Because we're going to talk about our spectrometer in a minute, but spectrometers, as you'll learn and you probably get on your MLA test, they're blind to particles over a certain size range, usually about 5 microns. And I mean, a 5 micron is a very small particle. So this is a very important part of our process, visually tracking the color, clarity, and any visual debris on the oil sample itself. But everything inevitably is going to start with ICP. So ICP is an inductively coupled plasma spectrometer. And what a spectrometer is doing is we take the samples here, the racks load onto our diluter. The diluter dilutes those samples into sample trays that go on the ICP. This is taking up a small sample of oil. It's bringing it into this little flow assembly inside here. You can come over if you want. This is a nebulizer chamber. So it's mixing in here with argon gas and creating an aerosol. And then that aerosol travels up into the plasma and it's ignited and everything in the sample is atomized. So that's the reason for this limitation. So any particle over about 5 microns you won't see because it can't be contained in the aerosol, and even if it does, there's not enough energy to atomize it in the plasma. So this is looking at the very fine rubbing wear particles that are always being generated in systems. And that's actually very useful for trend analysis, oil analysis, because those very small particles increase with increasing wear, and we have certain levels for all different types of equipment, whether it's a Cummins engine versus a Detroit engine, or whether it's Sumitomo gearbox, or we have expected limits for those types of systems. So when this is atomized, then every single element that's in that oil is going to emit light at a certain wavelength, and around here is a whole series of what are called CMOS chips. It's like in a camera, you have a CCD camera today, everything's digital, and it's capturing the light. Well, these chips capture spectroscopic light at different wavelengths, and that represents different elements. So we may have potassium on this low end, and on this side we may have lithium. So this can capture, probably 70 or so different elements, but we look at about 30 of them. So when this is sipped up and atomized, we capture the data from about 30 different elements, including things like iron and chromium and nickel and aluminum bronze, copper. Those could represent wear in the system. We also look at things like potassium and sodium and silicon, which represent contaminants getting in the system. And then we look at other elements like phosphorus and zinc and sulfur and boron and magnesium, and those represent the organometallic additives and some of the properties of the base oil as well. So we're getting a lot of information from the spectrometer itself, and it's going to help us make decisions. Yeah, so there's some of the data coming off, and that'll all be captured into our LIMS. And once the sample is entered in our system and we import this data, we'll have all that spectroscopic data with the historical data as well. Samples you took 3 months prior, 6, 9 months. So this is one of the primary things. The second most primary test that we do is viscosity. And before we go over there, we can also look, we do infrared analysis. So this is a different type of spectroscopy. So whereas this is literally looking at the different elements that are present in the oil, this one's looking at the types of molecular bonds that are in the oil. So we take a rack loaded on here. Let me just get this out of the way. It's going to take a sample of oil and pass it through this cell in here. So this is a zinc selenide cell, and the oil gets spread out into a 100 micron path, and you shine a heat source and a laser through there. And the laser aligns it, but the heat source is actually allowing it to emit infrared energy into the sample. And what that does is excite the molecules. And depending on what is in there, it will elicit a response at a different wave number. So this is a very big peak because this is what we call a carbon-hydrogen bend. So oil contains a lot of carbon and hydrogens. It's big hydrocarbons, right? Carbon molecules. So this is looking at the hydrogens wiggling on the carbon, for instance. But more interesting things for us are things like oxidation, nitration, sulfation, which all come up in this area. So we can look at a variety of different parameters in the oil. We look at soot concentration in diesel engine oils. We look at oxidation level of the oil. Again, for engines, we look at nitration and sulfation. We can detect things like water and glycol and fuel, but we use other tests for that as well. It's usually just done to trigger it because it's not very accurate, but it's a good screening tool. So we capture a good bit of data here as well, and then we move over to viscosity. So this is, this is a series of viscometer baths, and the most important property of oil is the viscosity. And that's the one thing we're going to check. If you got an engine and it's a 15W40, when we do a viscosity at 100 degrees, it should fall somewhere between about 12 and 15 centistokes. If it's outside that range, it could mean there's contamination or the oil's out of spec or degraded. An ISO 320 gear oil, we run at 40 degrees, should have a viscosity somewhere around 290 to 350 centistokes to still be in specification. So this system, we have 2 baths that run at 40 degrees centigrade, and we have 2 running at 100 degrees centigrade. Those are the 2 different measurement temperatures for viscosity in centistokes. If we do both, we can also calculate a viscosity index. I think Paul might have talked about that today, okay. So the less that an oil changes with increasing temperature, the better the viscosity index, the higher. And that's a good thing. So if you look at mineral oils without viscosity modifier in them, they usually have a viscosity index around 90 to 100. If you use some synthetics, like polyalpha olefin, like synthetics you put in diesel engines, they might have a viscosity index of about 160. It's more desirable. Some ester-based oils can have viscosity indexes as high as 200. So this system we've outfitted with a robot. It just takes away the need for technicians to be loading tubes. It also is a lot more accurate because when we load in our sample racks, we know what oil you told us is supposed to be in there, so we know what the anticipated viscosity is. So we're able to pick the tube that has the factor that is most appropriate for that type of viscosity. So this system does tend to improve the accuracy of the system. But the basis of this is these viscometer baths. There's a calibrated tube in here that's held at a specific temperature. When the oil is introduced in the tube, it travels down this tube, which allows it to reach that 100 degrees Celsius before it hits the bulb. On both sides of the bulb, there's a little light sensor. And when the oil enters, it starts timing, and when it leaves, it times. So based on the calibration, it can calculate using a factor the centistokes based on the amount of time through the bulb. Pretty straightforward. So every oil that comes through the lab will get a viscosity test as well. Then we get into specialty type testing. So here we have a couple titrator units. In plant environments, one of the important tests that we do on hydraulic and gearbox oils to determine if the oil is still suitable for further use is an acid number. And then as oils oxidize and age and begin to degrade, the acidic content in the oil increases. So we're doing titrations. We're essentially taking a small sample of the oil, mixing it with a solvent, and then titrating it to determine what the acid number is. In a typical mineral type of gear oil, when the acid number increases by 1 unit, that's generally a sign that it's beginning to be ready for a scheduled oil change. We also do base number, which is for engine oils, and the base number is sort of the opposite of the tan. Base number starts at a high level. So engine oils contain detergents, and they impart a alkalinity or base number to the oil. So we measure that, and as that goes down, it gets to a point where it's time to change the oil. You'll see that the tan will start to increase when the base number goes to a certain point. But that's pretty much just for oils that contain detergency like engine oils. So these are two critical tests in engine analysis. The other one is our particle counters over here. So this is, again, one of the more critical tests that we're doing today. So a lot of your companies, I'm sure, so if you're embarked on an oil analysis program and we're detecting problems with moisture, particulate, or high acid numbers in your oil, you take appropriate corrective actions. When it comes to particle counting, though, and we're finding high particulate, usually the corrective action is running a filter cart or putting on some permanently mounted filtration. I mean, Paul was just showing you the Lubriguard side of the business. This is what's triggering a lot of that. So testing the cleanliness of the oil is done with this test called a particle count. And we're taking a sample of the oil. These systems from Synergy, we have a small format and a large format particle counter. We dilute the oil. So we take one part of the oil and we mix it with 2 parts of a solvent. And the solvent we use is a mixture of toluene and isopropanol. Because this test, what we want to measure is solid particulate. And as oils age and degrade, they create varnish precursors, insolubles. So the toluene masks that, and the isopropanol masks water. So we will test for water on another test over there. But here we just want to see solid particulate. So the solvent eliminates any particles that are phantom particles that are detected because you may have a bit of moisture or some insolubles in the oil. So the sample is mixed with the solvent. It's then pulled up through this syringe and then pushed through a laser sensor. So the laser diode in there, there's about a 400 micron path, and the oil is pushed through a very thin film again, similar to the infrared. And the laser light there is going to be occluded by particles. So there's a lot of particles going by, different size ranges. That laser is actually able to see a voltage pulse when a particle obscures it. And the peak and the width of the voltage pulse tells us the size of the particle. So it's counting particles in different size ranges. So Paul's already reviewed the ISO cleanliness code chart with you. And I don't know if he explained, but they're at 4, 6, and 14 micron ranges are the ones we're most concerned with. 4 micron are what we call those silting type particles, and they tend to lead to sticking servo valves. The 5 micron is a representation of small particulate, or the 6 now, sorry. And the 14 is gross particulate ingression, like may have seal deterioration or large particles coming in. So this unit does measures the quantity of the particles at 4, 6, and 14, and then that amount can be converted back to an ISO cleanliness code, like a 1917-14. So this test has been very critical in filtered systems. So anything that's pressurized usually has its own filtration. Gearboxes in the past, the OEMs don't tend to supply them with any type of filtration. But as you say, a lot of today with lubrication management, people are running filter carts. They're using other bypass filtration systems. So this is what you're using to measure the effectiveness of those engineering improvements you've done on those systems. So the other contaminant we're concerned about in systems is water. So we can look over here at Carl Fisher. So if you've ever pulled oil out of a gearbox or a compressor or a hydraulic system and it's cloudy, generally there's only 3 reasons. There could be insoluble in the oil, could be very degraded and you're getting varnish precursors. There can be air, that's very common. So if you have sight gauge or windows on return lines and you look at the oil, it actually looks milky coming back in the return line. And the reason for that is there's so much air entrainment. But if you take an oil sample, let it sit for a while, and it's still cloudy, chances are there's water. So we do a Carl Fisher titration to measure the, so there's a milky oil sample. Probably a good indication there's water present in it. So we take a small sample of the oil, and we put it in a vial like this, and the system pushes the vial down into a little oven, and what that oven does is heat up the oil, and any moisture in the oil will elute through this into the reaction vessel, and then we titrate it with a Carl Fisher reaction. It's an iodine type solution, and it'll give a very accurate measurement of the moisture content in the oil. So this is suitable for down to less than 100 parts per million, which is 0.01%. So most systems, hydraulic systems, we get concerned about 500 parts per million or 0.05%. For something like a final drive in an off-road construction, probably 0.3%. 3,000 ppm would be a kind of a threshold for a problem. So Carl Fisher's that next good indication of the types of contaminants we're trying to keep out of oil. And again, what Paul was talking about on the Lubriguard side is that's why you're installing desiccant breathers. Try and keep that head space dry, draw the moisture out of the oil, keep the oil dry as well. It's really critical. Moisture in the oil accelerates the degradation process and creates strong acids. So those are the fundamental tests that we do in here. And then on the other side, we've got some tests that we do for more advanced testing. Some of them you'll see tomorrow, so we can go through some of those as well. So we call this our performance testing laboratory. This is where we tend to do tests on more critical asset oils or systems that have larger volumes, turbines, steam turbines, aeroderivative turbines, hydroelectric, large injection molding machines, anything over about 5,000 liters tends to get some tests in this room as well. This is a series of RPVOT instruments, rotating pressure vessel oxidation tests. Commonly used to be called the RBOT in the past, rotating bomb oxidation test. And what we're doing here is like a stress test for oil. So similar to when you go to the doctor and they hook you all up and make you run on a treadmill and then do ultrasounding, look at your health. This is a stress test for oil. So inside of here, we have a small beaker, and we're going to take 40 grams of oil. We're going to put in a copper catalyst because this accelerates chemistry, and oxidation is specifically what we're trying to do. So we put the copper catalyst, we put 40 mils of distilled water. We put it in here and lock it in. We pressurize it with pure oxygen. so in that headspace, and then we rotate it and heat it up. We pump 25 psi of oxygen into the headspace, and then we start the test. And what we're looking for, and this is kind of neat, so the water, the copper catalyst, the temperature, it's all going to promote that oil degrading and oxidizing. So what is oxidation? When the antioxidants in your oil get used up, those additives that provide resistance to oxidation, the oil will actually start to extract oxygen out of the environment, and it will begin initially to cleave the hydrocarbon molecules apart, and eventually they'll all kind of line up and tie up together and make very high molecular, high weight compounds, kind of like the sole of your shoe that drop out of the oil. So this test is accelerating that. So when we see that pressure curve drop, we wait till it drops by 25 psi, and then we discontinue the test. And we record the number of minutes from the start to the end of that test, and that's considered your RPVOT value. When it falls below 25% of the new oil, that's when it's time to schedule an oil change. On this side of the room, you go around, I'll go around this way. We've got some other tests. One of the, in large volume reservoirs, one issue that can be experienced, well, you can experience this in low volume sump gearboxes. You ever see foaming issues in any of your systems? So foaming can be a result of, if the oil gets heavily degraded, it doesn't shed air as well. If oil gets contaminated, if you guys do water washdown of equipment with detergents and a bit of detergent gets in the oil, that will really affect the ability for the oil to shed water or shed air as well. So this is called a foam test, and we take a 180 mils of oil, we put it in a large 1 liter cylinder and insert it in here, and then we put a little, we blow air into it through a stone, and the oil will actually create foam on the surface, of course. And we do that for a period of time. So if you look here, this is a good, you can actually see a test in operation. So it's not uncommon. You're going to see foam being created on the surface of the oil itself. So we run that for, is it 10 minutes? 5 minutes. 5 minutes. So after 5 minutes, we stop blowing air in there and we record the amount of foam. And that's called the oil tendency of foam. And then once we discontinue running air through there, that foam will collapse. And then after 5 minutes, we record if there's any foam left on the surface. And that's the stability. And that's actually more important. So that's a typical turbine oil. They can generate up to about 450 mils of foam before it's considered outside of the spec. For a gear oil, probably only 40 mils is acceptable. You can imagine on the return line that the oil dumping back into a large reservoir, there's foam on it, but it has residency time in there. And by the time that oil goes under the baffle and it gets sucked up again, the foam should be gone. So that's really what we're measuring. In a small gearbox, if we're experiencing 100 mils of foam on that gear oil, that's a different story. It's a small little reservoir. We know there's constant air in there, and air and oil doesn't make a good lubricant. So we can do this test that we do another sample at a higher temperature, and then we take the higher temperature one and run it at a lower temperature. So we do it in 3 stages. That's demulsibility. So this little bath behind here, another property of oil that will become worse over time and as the oil degrades is its ability to shed water. And that's if it is, say, a circulating oil or an oil that is meant to separate from water. So we have emulsifying oils and we have demulsifying oils. Oils like some compressor oils and engine oils are meant to hold the water in suspension. So in an engine, you create moisture through condensation and through combustion. You want to hold that water in there so when you drain the oil out, it's gone. We don't want the water separating the engine because it will be attracted to the parts and cause rust. But in circulating oils, in turbine oils, we want that oil and water to separate, and that's happening in the reservoir. The oil goes back in, the water should separate down. Usually you have a sloped tank, it gets to the bottom, and you can drain it off in the BSW glass, sight glass. So this test is measuring the ability of the oil to separate from water. So we take a graduated cylinder, we put 40 mils of oil, 40 mils of water, and we stir it with a paddle. Basically, like making oil and vinegar salad dressing. So we form an emulsion, and then we let it stand, and we see how long it takes until either the oil and water separate back out to 40 mils and 40 mils, or if it goes past that, past 30 minutes, then we measure how much oil, how much water, and if any emulsion is still remaining, and report that. So a typical oil, circulating oil, should return back to a 40-40-0 within 10 minutes is pretty common. If it doesn't, then it means if you ever have a cooler leak or some other issue with water ingression, you're probably going to form emulsions and be passing that through things like main bearings, and that's going to be an issue. So foaming is a surface issue. Behind you is an air release test. This would be fun to see in operation because we take a sample of oil. We do a very accurate measurement of the density of the oil with this small densiometer system, and then we pump it full of air. I mean, we put a ton of air into the oil. We then, once we finish blowing in air, we put it back on the densometer, and we see how long it takes to return to 99% of the original density, and that's the air release time, and it's measured in minutes. So new oils, typical air release is going to be somewhere between 2-4 minutes. And as oils degrade and age, and their ability to shed air is reduced by that, then that number increases. In a R&O oil, turbine type oil, when it gets over 8 minutes, that becomes a concern. Because again, you got to figure that by going through the system and coming in, that return side is going to be full of air. And as I said, when you look at a pipe, return line pipe that has some sort of a oil window on there, you'll see it looks white or milky, and that's air. So that oil has to be able to shed that air before that oil travels through the reservoir and sucked up on the other side. Otherwise, you're putting air through a bearing or something, which is a very poor lubricant. So those are the predominant tests we do in the laboratory. This is rust. Another characteristic of large volume iron oils is they should be able to resist rust. So we literally take a steel ingot like this that is shined and polished using a particular ANSI steel. That's immersed in the oil with a bit of deionized water and kept at a certain temperature and rotated for 4 hours, and then we take the rod out, clean it, and look for any visible signs of rust. If there's any visible sign of rust, it's a fail. Otherwise, it's a pass.
Can you show ruler?
Oh yeah, forgot about the ruler. Come on. So I like this test because usually what we're doing in the laboratory, if you may have noticed, is we're sort of inferring the characteristics and properties of the base oil and the oil itself by looking at other tests. We see how long it takes to demulsify. We see how much air is creating, how much foam is being created, or how much air is being released, or how quickly it's being released. Or we do an acid number to look for acids that are created when oxidation is happening. But we don't have real direct measures of the additive levels. So this test is called the ruler. It uses a technology called linear sweep voltammetry. So it's very similar to the RPVOT over there. So RPVOT, we're putting the oil in and we're stressing it, and we're trying to use up the antioxidants. And when it begins to absorb oxygen, we know the antioxidants are being used up, and we're oxidizing the oil. So this is an actual direct measure. So instead of using copper catalyst, water, temperature, and time, we're using a voltage. So we can do chemistry with electricity. So we take a small sample of that oil, we extract out the antioxidants with a solvent, and then we put the probe in, and we begin to put in an increasing voltage across that oil. And eventually what that will do is oxidize the antioxidant, and we'll get a peak. And if there's 2 antioxidants, we'll get a second peak as well. So we measure that millivolt response of the new oil for each of those peaks, and then we compare it to the used oil, and we just measure the area under the curve, and that tells us how much of each antioxidant is remaining. So, sounds great. It's a little trickier than that. You get very different response rates from different oils. But when you combine this test with the RPVOT, and then we have another test called MPC, where we look for insolubles in the oil. We filter the oil through a very fine micron patch. It captures any of those insolubles, and then we use a small UV spectrometer to measure the color change. And that is an indication of what we call color bodies in the oil. And those color bodies are insolubles that tend to sort of pleat out into the system especially when you go through the cooler, and the oil gets cool and it can't hold those insolubles. They'll all go onto the cooling coils. You'll find that amber material in your reservoir if you clean it out, the sticky stuff. So here's our little hockey guard collection of some of these MPC patches. So obviously the lighter the patch, the lower amount of insolubles, heavy amount of insolubles. So this goes into a little UV system that shines light off on an angle and detects the amount of coloration there. And that gives us a valueless number that we use to both trend that and compare that to certain limits. So really in large volume systems, those three numbers, the ruler results, RPVOT, and the MPC, are a really good indication of what's happening with those large volume oils. And then we can recommend different technologies or different maintenance strategies to try and remediate that. You may just bleed off 25% of the oil and put in fresh oil. You would be doing that with some of your turbine systems at Bruce Power, for instance, and then seeing what effect that has. You could use electrostatic filtration, or you can use
depth media.
Depth media. There's a variety of different technologies that are available to extract out the insolubles and return the oil to good condition as well. So that's the main tests that we do for oil analysis. There's also some additional ones that you'll see in the training tomorrow. But yeah, thanks very much.
Thanks, Bill. Appreciate it.
Any questions?
Laboratory, I think, There's a lot of key pieces to a lot of different industrial components that you need to be aware of, especially on the larger oil volumes and turbine systems, that kind of stuff. There's some pretty outrageous levels of testing you need to do. A lot of times it's just the small routine stuff in the natural routine lab. But if you're going to experience working with large capacity tanks, you need to be informed on that. So let's the OPG coal-fired plant, which is no longer there, but these are the coal crushers, and there, I believe at the time they had 8 of them. And of course, they would take 1 or 2 out at a time to rebuild them and get them refurbished out of the 8. And their oil analysis program had detected that one of them, let's call this one number 2 and this one number 1. Number 2 was having these issues, and the analytical testing over time was showing them that they were in severe wear mode and severe fatigue mode. So they made a decision to open this one up, and lo and behold, there's his boot. So you can see the size of that plate and the amount of damage, right? It's just massive. This tooth is completely gouged out, and this is all the metal that's finding in the oil sample. And of course, when that happened, they had already scheduled for number 1 to come out and get rebuilt. So they said, no, we better put the kibosh on number 1 and get to work on this one. And that's what they did. By doing so, that meant that they could fix this one and not interrupt the power service. So if they would have had started number 1 and let this one fail, then the cost would have cost them about $12 million, because they would have had 2 machines out, and you get charged big time if you can't produce your power. So 2 units out, not good. 1 unit out, you're okay. So they saved about $12,500,000 by finding that. We talked about OEM with Bill. These are the large portions of the test that we need to do. And of course, AOM1s, you have all your routine tests. Where it shoots into the bigger stuff is your varnish potential test, your voltammetry ruler, your analytical ferrography. If you jump it up to a level 2, we'll add the RPVOT, or does that up here, analytical. If you do the 3, you get the whole package, and that's everything up here, plus RPVOT, foaming, air release, water separability, right down to sediment. So that test there, if you do that one, that's like your overall oil condition start. If you're having issues with big tanks, you really got to start there, and that'll tell you what's been compromised. If everything comes back and you've got a couple of these out of whack, you can use a sweetener program and try and bring somebody AdPack back. But you got to start at least with number 3. And I believe that's somewhere around $1,300. This one I think is $500, and that would be like $350. But it tells you exactly where you need to be. Bill spoke about that in the video, MPC, or membrane color patch. That tells us basically at what stage that oil is in. If it's producing varnish, you put that thing through the little slide maker here, and lo and behold, if you have a 0 to 15 number, it will be normal as green. And as it gets more tarnished on your patch, if you are over 40, we're considered critical, meaning that you've got some varnish layout. And I'm sure that most of my clients will start just doing MPCs with their routine. If that comes out at a 40, 30, and over 40, odds are their AdPack is stripped. So we would ask them, you know, we're seeing this now, time for you to do an AOM3. But you don't have to do that. You can start with just an MPC to see where you are. The ruler, again, that would come in. That's a definite backup to this. If you're having this, it's because this test has failed. If you look at this test, in this particular one, you have antioxidant 1, antioxidant 2. When you do your new oil sample, they're usually at 100%. It's like having two armies, right? The first one will be your marine guys, and the second one is your land army. And those are your soldiers. When you have a new base, these are all brand new. They're right there ready to fight oxidation and varnish. As you age the oil, you use up your warriors. One of them will use up quicker than the other, but you can manage it and get it through to where it doesn't degrade to the point that you get into a greater than 40 patch. Once you're at a 40 patch, you're probably not going to fare very well in that AdPack. The second thing is this RPVOT. Again, that estimates the oil's oxidation stability. You put the catalyst, oil, water, and oxygen, and it'll run it over a test over minutes. And by the time it takes in 25 psi of oxygen, the test finishes, and you calculate the time it took. If your new oil is 600 minutes and you only did 125 minutes on the test, your oil's pooched, right? You gotta do something. Guys, they keep running it and running it and running it, and eventually it catches up to them, right? This is just a quick example, this 10,000 liters. There's his color. His color is 5.5. His RPVOT one from 600 to 182, almost done. His antioxidants are not too bad though. He's still in line, and his MPC patch is pretty good. That tells me that if he did some sweetening here, he'd probably clear it up and get more life out of that oil. So it's not at a point yet where I got to change it. This is a case study at a plant, a hydroelectric in Kingston that I did. And again, he's got 10,000 liters, but there's 16 of them. And they pull 4 of them out at a time. So they'll pull 40,000 liters out and they'll go to work on the 4 units. Takes them about 6 months. And then they refurbish everything as much as they can. While that oil is out, it's in a 40,000, 50,000 liter red tank. And while they're doing the work, they're filtering that red tank, and then they put it into a green tank that's certified to go back in. But what they weren't doing, they were just doing routine sampling, acid number, viscosity, and particle count. So they invested heavily into particle count filtration, but that was it. And they just kept putting it in. So we found out that after 54 years of use, they never changed the oil. It hasn't been changed yet. And this is the results. RPVOT 600 minutes, he's 66. Oxidation 1 and 2 start at 100%, 13 and 0, and just a mess. So I don't know, they never did anything. I guess it's hard for them to write a PO to change out 40,000 liters, perhaps 160,000 liters, right? And they're run by Ontario government, so they don't want to give you any money if they don't have to. So they just kept running it. 54 years. And you got to wonder, right? So you ask them the question, well, okay, it's 54 years old of oil. How many times has the 16 units been rebuilt in 54 years? And you say, oh, probably once or twice each. How much is a rebuild? Oh, $3 to $5 million. Well, it's okay because the government has a ton of money, right? They're very stingy at giving you the money when you need to be improving things, right? But when it breaks and you need it, oh, they got all the money in the world, and it's fixed. So that's what they do. They just run it, and when it blows up, hey, give me the money, I'll fix it. Taxpayers paying. Who cares? So there's foaming. Again, Billy talked about that. It's an important test because if you can't get foam out, foam is not a great lubricator. And a lot of these big bearings and these big systems, they're all lifted under hydrodynamic lift, right? You got pumps, and the pumps have to push the bearings off of the plate. So when you got a large turbine, you've got a ton of weight in that bearing, and it's on a jack because they don't want it sitting on the metal to metal because it just wears out just sitting there. It's not good. So they put it on a jack. They do the repair, and then when it comes time to put the power to the system, they inject that oil underneath the bearing, and it lifts it, and it loosens off the jack, and then the jacks come out, and they're able to turn it on, and it's on a nice bed of fresh oil, and it goes, and then they remove the jacks, and you're good. Once you've got that hydrodynamic lift, it can run for 30 years straight if you want, or 10 years straight, or 3 years straight, because there's nothing impeding it. It's strictly running on a bearing. But you need to keep the oil in good shape to keep that bearing rolling pretty nicely. But as soon as you put something that messes up that foaming, can you imagine pushing foam underneath that bearing? What happens to the foam when you take those jacks off? Well, the air bubbles collapse, and the bearing falls right through the foam and goes metal to metal, and it starts turning. So in their industry, it's called a bearing swipe. They swipe the bearing. Holy moly, that's a $5 million swipe, right? So it's important for them to know what the hell is happening, and they do these foaming tests. Here's one here where they didn't fare out very well, and that's the problem right here, is the foaming didn't come out quickly. So what they did here is they just kept sweetening it and bringing back the properties. So they were able to sweeten it for another 12 months, I guess, and then they were in the process of getting shut down by the government, right? The coal-fired ones. So they didn't bother changing the oil. They just said, let's keep running it and make some money, and we'll put the Band-Aid in. And the Band-Aid was just keep adding new oil to it. Take 25% out, drop 25% new, and see how far we can bring it. And that's what they did. They did the same with the water separability, and but Bill talked about that, where you make it up into a vinaigrette and you see how fast it sheds. And if you go 50-50, I think you're in good shape, right? Here he wasn't in good shape. 40-40-0, he went 2.573. Not a good deal. This case study was a power plant air derivative gas turbine, 25,000 liters of this Qualco turbine oil 32. And this was out of Qatar. This whole, it's just one massive jet engine, right? But 10 times the size. And they send that over to Qatar. And the guy that was hired to install it and get it up and running, he's a Canadian. And he used WearCheck to do all his sampling over his time in Canada. So before he did any work, he sent the samples back to us. We did the samples, sent them back. And lo and behold, this is what it should have been. Water separability should have been 40-40-0. It was all brand new oil. No calcium, no phosphate, no zinc, and no sulfur. This is what it came back with. So he didn't do any work. He didn't start that up yet. So once he found out that there's ZDDP, he kind of understood there that, hey, this is something that the bearing or that manufacturer did. And when he went back to them, they said, yeah, we have these sitting in a bath in oil, in a big swimming pool of oil. And it was engine oil. Why did they soak it in engine oil? Because engine oil has detergents, so it wouldn't rust. So when they pulled it out, they let it drain off and do as much drain off as they can, and then they ship it out. But any little remnants left, when he put it back together, got it installed, put 25,000 liters in it, he says, whoa, before we turn it on, let's send the samples. Well, that little mix of engine oil protectant messed up his additives. And we've seen the additives. So if he would have turned that on, that thing could have exploded on contact. Just didn't have the right oil in it, or the right mixture. So that's a hell of a save. You know what ended up happening? He had to flush that system 4 times. He used 100,000 liters of oil to get that out of there. Yeah, he needed oil, but that wasn't even old oil. That was new oil. It was just contaminated with the. But it took 4 oil changes to rid. Oh, I have no idea. Oh, somebody paid. Yeah. Hey, let's do 4.1 to 4.5, and we'll get through the sampling hardware real quick. Then we'll do training real quick, and we'll be out here by 3:30, 4.
Yeah, just keep going. You're good to go.
Feel free to grab a coffee, guys, if you want. Tea. The coffee, you can use the Keurig.
So I wanted to ask you a question on filtration.
On filtration? Okay.
For additives. You
Yeah.
mentioned APS.
Yeah.
What type of additives do you normally see pulled out? And what
That I don't have the real additive on the top of my head, but the Petro-Canada working with with the Linamar group
Mhm.
at Skyjack. They had the evidence. They didn't share that with us. They kept it between them and Petro-Canada, but the filtration systems that they bought from another group, not from WearCheck, or not from Lubegard, right?
We haven't, so that's a question that keeps coming back. And my experience at R&D, it's a tricky one to answer. Because
Yes.
it normally shouldn't. Like, I think the only additives that I have seen that could be pulled out are antifunks.
Yes.
Not functional.
Yeah,
additives,
no,
because those
just
are
it would be.
dissolved. Like anything that is not dissolved and it's dispersed. So could potentially, but like we had only seen antifoams.
Wow.
And nothing else. And in our experience, it wasn't.
Oh yeah.
Sometimes it's not a direct.
Because we did a whole heat exchange.
Factor of the filter size, mesh size. It was more of a material, because sometimes it's like surface absorption
Okay.
rather than
particulate.
Yeah.
Yeah, rather than a
size.
physical
Yeah.
size of
It's just the
it
surface.
was more the surface, and it would blind off the filters probably.
Or there's like it's attracted on the filter medium.
Yeah.
And I just wanted to
I wonder, because it disappeared, because they went, here's what they employed. So they bought filter carts from Descase with added particle counters on them, right? So they would use the cart, bring it to the tote, fill the unit through the filter once, take the sample. If it passed, it went. If it didn't pass, they took the machine and ran it till it reached its code. And then when it would reach its code, it would go. And then they started having failures.
But what was the root cause of the failure?
It wasn't foam. It was particulate. We'll finish up. So let's go through oil sampling. So Jimmy Finch here from Noria says proper oil sampling is critical to an effective oil analysis program. Without a representative sample, future oil analysis endeavors are futile. So that means you're just taking phantom samples if you're not getting it from a really good source. So we take samples to obtain a clear indication of the operating state of the equipment. And then, of course, taking representative samples is dependent upon many factors, and they are dependent on the sample port location, the hardware and apparatus, the method and procedure, the frequency of the sampling, and recent activities, maintenance activities. Sampling pressurized systems, you want to sample before the filter, after lubricated components. Mini-mesh sampling valve is preferred, and you flush the sample pathway prior to drawing your sample. So here's some poor opportunities. This one here is under pressure on the cooler of the system. So he opens the valve, it feeds pressure, he pours that, I don't know, on a 5-gallon pail or on the floor, who knows? But it's a large pathway to filter out or to do. Here he's got to drain out quite a bit, drain out, drain out. So these are not preferred areas to pull good representative samples. Even if you do the right thing, and the guy pulls the plug, opens the valve, doesn't flush it, just takes it, we're going to see it. We're going to see debris. It might even be gold, but you're going to see debris in the bottom of your clear bottle. And the guys, Kevin or Billy's going to look at it and say, you know what, we suspect it's a poor sample point, probably from a drain or something. The guy will say, yeah, how did he know? Right? So you know when you see that kind of debris. So what do? Well, instead of going into these areas, and these are all pressurized, let's find a pressurized point. And if we can find that right pressurized point, we can identify it, hang a tag from it. This is my sample port. Put the tag on the chain. If you're low pressure, under 1,000 PSI, you can use these nice little push buttons. We use them on our filter carts and stuff. Most hydraulic systems, they don't use these. They use them on heavy equipment because they can bring the units out to a panel. So a heavy piece of equipment might have 6 of them on a panel. One's an engine, hydraulic, transmission, and it's all push button. Works fine there. Hydraulically, usually these are in place, usually on your servo heads where you're going to test the actual actuation, and it's got the pressure gauge. So it's all it is a pressure sending unit. But we use them for oil analysis because these are 15,000 PSI rated. These hoses, I made this up because I got caught one time doing a service for one of my clients, and I just used to use this side just to cut off, put it in my pump, and then I'd tie that up to the fitting with my fingers. And I got caught one time where the actuator kicked on. I couldn't really hear it, it was so loud. I turned off, got my sample flowing, and then it kicked on full pressure, and I couldn't undo it. It just locked on, and it sprayed oil, blew the canister on the ground, and I got the oil, and I'm pouring it on the floor in the guy's plant, and I have to wait till it uncycles, and then I got to finger take it off. But by then, the plant is full of oil. I'm about to get sued, right? So I said, no, that's never going to happen again. So I made this little needle valve. This is a 5,000 PSI needle valve. I've got the mate that goes in and opens the valve. So I don't care if it's at 1,000 or 5,000, it goes pressure to here, that's shut off. That's inside my vacuum bottle. It's acting as a cradle. Because if I don't have this, I got to put the bottle, I got to remove the cap, and I'm messing around with a cap. If I'm in a heavy piece of equipment outside and I open up the gates, there's dust and sand and everything floating around, and I got an open bottle, well, I'm getting sand and dust and dirt into my bottle. But if I load it up into my sample pump, I don't have to use the vacuum. It's just there to cradle the bottle so nothing falls in. And then, of course, I open the valve. I can drip it or I can flow it. And I can set my flow rate the way I want it. Very safe, very easy, very quick. So if you're going to do high pressure samples, make sure you use this thing, because that'll save you a gazillion dollars in mess. And then, of course, they've got the L series, which is the bigger, but that's more for gear oils. And of course, Unpressurized systems, you're going to use the pitot tubes like we showed you in the back. This is a pitot tube where I'm pulling oil from a pitot tube that's inside this gearbox. He's got it hooked up with the oil level gauge and the quick connect and the sampler. Here you've got the bad sampling areas that are hard to get at. You can imagine the guy pulls that out, opens the valve. What's he get? All the shit from this level gauge and everything that's in the tube. So it's not a good sampler. Here he has nothing, can't get anything. He's got to make a hardware change. Here he has to make a hardware change. This is not good either. So you want to be able to use things like pitot tubes, either with a level gauge hook to it. You just simply tie that to your gearbox, get it set up, tighten down the lid, and you are golden. You can sometimes put a bend in it. If you're looking at the oil level gauge, it's got a little clear glass here, clear poly. So now you got your tube, you see the oil level, and it's going down into the box. Put your pump on it, and you extract your nice oil sample. And some of the hardware kits you need cutters, mini cutters, benders. Those are always good to have it around. And of course, there's your pitot tube going in. I usually use a swivel on all my stuff because eventually, if that's too low, you're picking up this crap, right? But if I can come in and put a bend on it away from the gear, then I'm up into this zone. If this was down here, or if it was underneath, I could put it up and just come up a little bit here into the oil, but it gives me good options there. Evaluating your analysis test data is very important, and what's needed to get good data, you need the good sample consistency. Ensures that trending will be relevant. Proper test selection, provides the most revealing data to evaluate. So you need to do the right test. You notice when I did in industrial test 1, 2, and 3, 90% of every customer that we deal with uses number 2 because it has the most effective data. If I only use 1, IND 1, because I'm too cheap to pay for the 2, I'm going to miss all the data. If I'm doing hydraulics on a 1, I don't get acid number and I don't get particle count. If I'm doing gears on a level 1, I don't get the Carl Fisher and I don't get the TQ. So this is critical data that you need. So you have to set your selections that it fits. If I've got a 10,000 liter turbine system, I don't do an industrial 2. I need to do AOMs. I need to know what my ADPAX is. I need to know how old that oil is. The dummy tells me it's 54 years old. Where should he be? He should be in the tank with it. Right? Come on, common sense. You need to know knowledge about the equipment. 100%. Know your equipment. Knowledge about the fluid. If you don't have knowledge about your oils and what type of oil's in there, you have no idea. Start learning. Get to know it. Knowledge about the test employed. All this stuff is crucial. Feedback from the operator/user. You guys are the field guys. You guys are the guys that are right in front of this thing. It's vibrating like crazy, but you don't tell anybody. Well, I was only sent down to pull the oil sample. And I did 12 of them, and guess what? There's 2 of them with milky white. But they're in the box. Johnny will look after it. Dumps it on his desk. Johnny says, "Thanks, Billy." And Billy goes off. Johnny's got the things, and he's going to do all the paperwork and send them to the lab. But guess what? He gets a call Friday. Your kid's sick. You got to come to the school. Guess what happens? He's gone to the school. Friday, the kits are there. Saturday, the kits are there. Sunday, Monday, Tuesday. He doesn't come back till next Monday. So now they've been on his desk for 10 days. He gets back to work. Well, that's waiting because I got 50,000 emails now. So that waits another 5 days. So now it's 3 weeks. Then he sends everything in. We get the 2 watered samples that are milky white. And of course, they're severe. And Johnny looks at the reports. Holy shit, I better get a hold of Billy here. Hey, can you go change the oil on these 2 units that are full of water? Don't have to. Why? Because we just blew both of them. So how easy would it have been to get the feedback from that clown? He would have said, "Hey, Johnny, here's the samples that you told me, but guess what? Unit 1 and 2, full of water. We should change them now and check out why they're full of water. That makes a great sense. But no, he just dumps them and it takes off. And it happens all the time because they don't give these guys that do, the good things that they need. It's getting better. I hope you guys don't have to deal with that. It's communication. Absolutely. It's responsibility. It's having a team leader, a champion. Because it would only happen once, and then I'd figure it out. Oh boy, did we ever mess up? How come I don't have a relationship with my team, right? It would only happen once. But operator usage, hey, yeah, that machine's hot. I got my little tester there. That bearing's really hot. This one's vibrating. It's making noise. The pump is squealing. Well, what's that tell you? You're cavitating the pump, right? But if he doesn't say anything, this is all a waste of time. When you're using a system, you got to work with a laboratory that's able to give you real good documentation, a portal that you can go in and easily find your reports, easily find your knowledge, find out what samples are severe, which ones are normal. If you got severe, which ones are they? Oh, look at that. I've got 53. I've done 344 samples. Out of them, 307 have ISO code problems. Well, what's ISO code? Dirt. How do you fix that? With a filter cart. Do you think he's got a filter cart? Not a chance. He's just taking samples. Make everybody happy. So that's how you see management. You got your severities, you got your abnormals, and you got your normals. You should run 75% of all your samples are green, normal, 15% yellow, and 5% red. If you keep that ratio, you're in a pretty good state. If you make some proactive improvements, you can probably bring it to 85 green and 10 and 2, change it up. But the better you get your green, the less yellow, the less red, the more money you're saving, the more time you get. On this here at WebCheck, you have a choice of going into your portal and really dissecting information that you think is good, as long as you got the training and you're happy with the training and you can go in and get more opportunity. But it doesn't mean that you have to load in. A lot of my customers, I would say that heavy WebCheck users is 10% of our clientele base. The other 90% don't even log in. But doesn't mean that they don't get the email notifications. So on this one here, when you get an email notification, he sent in one sample, he's got abnormal viscosity, you want to see the report, you go here, you click that, up comes the report, and there's all your problems. You can email that down to the boys, say, yeah, this one here needs to be changed. Can't do much, you need better viscosity oil, so it means an oil change, right? A lot of companies use these programs. Entech, Dingo, Lubricascan, Intelligence, Maximo, SAP. So you've got these CMMS systems. Most of the WearCheck stuff is compatible with them through APIs. So we can mold right into your system. So now your vibration data, your thermography data, your oil analysis data is all in one shot. You're not changing out the WearCheck and Lube here, there. It's all in one. So that works really, really well. And it's all part of an API portal. Sometimes we attract customers that are using another lab. And we might have say they got 10 branches, right? 10 companies. And one of them is using this lab, the other guy's using that lab out in Calgary, this guy's using this guy here. And then the maintenance helm says, no, we should be using one lab because we want consistency. We want training, that everybody's trained on one system, they understand everything, and they put a bid out. So hopefully we come in with our bid. But a lot of companies will give you a hard time because they say, well, if I change I'm in Calgary and I've got my machinery and I've been using Fluid Life for 15 years. And I've got 1,000 samples in my histories. The guy says, well, I don't want to change, I lose all that. Well, That's the furthest thing from the truth. Because your API portal, we just suck all that information into the new portal, right back into your system through WearCheck. So you never lose your historical data. The only thing it does is it reshapes it so that you can start using that in your system, and you can start pulling managerial reports based on 15 years ago, right up to today, and anything ongoing.
I have a question here about, we can get access, like normal access for API for our company?
Yes.
Okay.
Yeah. Yeah, your IT department and Billy and Kevin make it happen.
Okay.
Yeah, that's how we do global contracts, right?
Yeah, it's
all over.
website and we have access.
Everybody goes through and it all downloads. So, you know, you take a company like, say, Lube, you know, out of Sweden. Well, they have us here in the US, some places in Europe, and they manage it all. One manager, and he can find anything and everything from any piece of equipment in this region. And it happens in seconds. He wants a report, he gets his reports. Boom, 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 boom. So when he meets up with his people to do their summary of how good the program, what did we find, how many saves did we get, how much money did we find and save potentially, within minutes it's there. If there's something missing, he'll call up Gloria. Gloria will say, what are you looking for? This, 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 and this. Okay, give me 5 minutes. Bill, what do we do? Okay, there's your report. It's fantastic stuff. People don't realize the potential of API and what it does for us. Sampling information forms. This is for Industrial 1, or Industrial 2s, and this is Mob 1, different setups. You have your SIF form. You have the bottle tag that you put on your sample bottle, and this is your tracking form. You put that on your tracking form, you put that on your bottle, and you put this with your sample bottle in the package, and you ship it off. If you're still writing stuff, I need this, right? If the guys are still writing in stuff. If you're using the apps, you don't have to do anything. You don't even have to put your name. But if you order your kits, we know your code name anyway, right? Like New Forest, that would be their code. They order a box of 12. We send them 12 with 12 labels. They don't have to fill anything in. We know who they are and we know the equipment. They just tell us the hours and the date, if there's hours. But mostly it's the date and the whatever they want. The sample kits, packages, the barcodes, apps, you can pull your reports from it. You can get your managerial reports. Anything that you want is there. It's customizable to you, and it's a matter of setting up the onboarding opportunities with Gloria and Bill, and you are set up and you're ready to rock and roll. No mistakes. Just an image of what happens, right? You log in, you get to sign into the web and download your WearCheck app. You scan this one's looking at a booklet. He finds the number of the press, clicks it, or he uses the ID tag, clicks it, it loads it up, presses it, takes a scan of the bottle, submits it, it downloads it, and it's ready for the lab. Takes about 15 seconds. Once you get there and you start getting histories and good sample reports and everything starting to go, a year, 2 years, 3 years, now your KPIs are starting to develop. You can find out what you're doing, where's it going, who's doing what, when and where. We have a huge program with a company called GFL across North America. They have 3,000 branches and probably 50, 60,000 pieces of equipment, and it's run by one group. Try and put that in one file, but they do it and they manage it, and he wants to see whatever he can. Show me who's not complying. Then all of a sudden, boom, Sudbury, it's got 100 pieces and hasn't sent a sample in 2 months. He's in trouble. So he gets the call. So he either conforms or you don't. right? So they manage it, and I'll tell you, Gloria feels a lot of calls from guys in a panic at the end of every quarter, because if you haven't done what you're supposed to be doing, they're going to catch you. But it's all in the process of saving money for the company, right? Making sure that you don't want to lose an engine to glycol. You don't want to lose an engine to fuel dilution. And that's kind of what we're looking at. Program health, sample conformance. That means the number of machines in your fleet that have been sampled during the current period. We're doing 90, 80%. Fleet health is really good. Lab turnaround, 1.14 days. Sample latency, meaning how long are you keeping it on your desk? 4.1, getting into the gray, into the yellow. Online submissions. When we see online submissions, meaning that they're taking advantage of the ID tags, whatever they're using with their phones and their apps, that online submission goes into the green. When they're using paper forms, you're in the red, because they're missing the hours, they're missing the oils, they're missing whatever it is. They're not getting the complete data. And then it matches your data compliance. A calculated score given based on the oil sample information provided at the time of sample submission. So if every sample they send me, they're missing information like how much oil is in the machine, what type of machine is it? Is it a transmission oil? Is it an engine oil? Is it a gearbox? Is it hydraulics? And they're not telling you, that score drops. So if I'm managing my program properly and I can't get data compliance, I'm making sure that, why aren't you giving the lab what they want? It's just laziness, maybe, I don't know, but I can manage it. And it's not like we don't tell them, hey guys, you're missing all this information. Can you please provide more information on this particular unit? You do that 10 times, that shows up, and guess what? The manager sees it, and he goes down to the guy and says, how come they're asking this 10 times and you're not doing anything about it? Oh, I just didn't have time. Well, you're going to make time now, because I got it on my radar. So it's all stuff that you have to have if you're managing a big program. It just has to happen.
So program health is the overall.
Yes.
And the fleet health is the overall average of the equipments.
Yeah, measures the number of components in your fleet that have no oil or wear related problems. Let's do 5.1 and 5.5, and then we're almost at the end. We just got to do the training side, which is very quick. Case study, and we should be out of here in about 20 minutes. This training portion. So this is quite an area where a lot of companies are missing the boat. I think it's crucial for your educational journey. Let's have a look here. Sometimes you ask a lot of questions about oil analysis, about filtration, proactiveness, and we really don't have the answers because we haven't dealt in this very often. So like at the beginning, you have all these questions. 68% say it's crucial and they believe they're there, but they don't really know if why they're not seeing any saves or any real good value. So that's the worst thing as an oil analysis firm is here. We don't see any value. Well, it's because we probably haven't trained the people strong enough or whatever the case may be. But with that saying, it's knowledge. So we go about looking at things. So if you're in the reliability department, you're a reliability engineer, this CLS is a Certified Lubrication Specialist certificate. That's probably where those guys are. There's not too many guys around that are reliability that don't have it, but it helps them when they're looking at the full scope of their condition-based monitoring. They make sure that the protocols and procedures are in place, the right sample reports on how to do the work, create work orders, and then they review it with their program people, maybe semi-annually basis. But that's a really good thing to go. If you're in the planner or foreman level, you can use MLA1, MLT2. We do them online. There's no, you might find maybe 1 or 2 live courses in North America per year, but you might have to go to, who knows, Timbuktu. I don't know. It depends where they decide to post it, right? And but if you're really interested, we have them online. So you register online, and it's a 3 days. Yes, Mike?
No, they're 1 day course.
Is it a 1 day?
1 or 2 days, 1 or 2.
Okay.
Yep. They're $750 each.
Yeah, and you can do it, and it's just narrated through, and you get your booklets, and you can do it, then write the exam, and you can be certified level 2. Millwrights, operators, oilers, this is basic knowledge 101. But if you do MLA1, MLT, MLA stands for Maintenance Lubrication Analyst 1, and MLT is Maintenance Lubrication Technician. And we do a 3-day course. The 2 first days are MLT, the 3rd day is MLA. We combine them, and the people usually write the MLA1 exam, and then a few days later, they'll sign up and they'll write MLT exam so that they don't lose the knowledge. If you're going to spend the money for 3 days and you're doing MLA, you might as well do the Friday, that's the course day or the exam day, do MLA because it's fresh. The rest you can do. But yeah, if you're taking oil samples, you want to carry out the maintenance activities, you review the sample reports, you report back to the planners and stuff, then that's a really good opportunity. That's my training company, KYR, Know Your Role, and we host them right here 4 times a year. I do some offline stuff too, like guys will do. I usually have you need 5 people if you want to write the exam. So minimum 5 people in the course and 5 people writing the exam. I usually can do it on site. But mostly it's here. We'll get maybe 7 or 8 people in class, and a lot of times we'll have 15 to 20 people online, and they'll be from all over the US or Canada, and they'll tune in, and we'll do 3 days of of education. And on the Friday, they'll come in at 9. You got 3 hours to write the test. You need a score of 70 to get your certification. Then every 3 years you recertify. Not write a test. You have to meet certain criteria to build up your points. And then once you have enough points, you send in that, and here you got your recertification. And these are the groups that are really at the helm of all this training. The STLE is the Society of Tribology and Lubrication Engineers. It's the oldest organization in North America, about 150 years old. And they look after things like, you call it weekly chapters in Toronto, Hamilton. Very, very strong. They help with the testing and all of the AOM certificates. That's Advanced Oil Monitoring, or no, OMA, Oil Monitoring Analyst Level 1. They make the exams and the training for that. CLS is its own core, and that's Certified Lubrication Specialist. And then all of the MLAs and MLTs are done through ICML, which is the International Council of Maintenance and Lubrication. They are the founding entity, and then they hire out trainers across North America and Canada. And I'm their trainer here in Burlington, actually all of Canada. I'll go pretty well anywhere. And we have other Canadian trainers from other companies as well. Let's do 6.1, 6.5, and then we'll finish off with, so that'll take you like 3 minutes on that one. It's now 3:41. At 3:45 we'll finish off, and you guys will be out of here before 4. Which is about half an hour longer than most. But you were a good, patient crowd, so I appreciate your time.
Do you have any CLS courses
Online?
scheduled or online?
All CLS is all online. You can find CLS, however, on with live, but they're generally in the US. Yeah, like Vegas or Tennessee. And that's a hard place to go, right? Because you can't sit for 3 days, absorb everything, and go out drinking and partying and dancing, because you're not going to pass. So if you can find one in Milwaukee or, in South Dakota, or, what's that place there that got all the killings on the movies? Fargo. Go to Fargo. Not only will you have a good time, but you might find a mass murderer, right? But if they're hosting an MLA or go to freaking Fargo. Then when you're talking to friends watching the movie, I've been to Fargo.
So is CLS all multiple choice?
Yeah, they're all multiple choice. Yeah. And they give you a lot of practice testing, and you can order cards, testing cards, all sorts of stuff. MLA, Mike does all the questions and stuff and gives it to the people so they can study. So it's kind of like day one. If we do 3 chapters, the homework is to read the 3 chapters, because there's lots of info in there, and the questions are related only to not only the stuff that I'm talking about, but it's more, you got to read the book, right? I'm just a facilitator for keeping you guys awake, hopefully, but the real info is in there. So you read the question, you go in, you find a few key words, and you go in the glossary and you look for varnish. Oh, varnish shows up in 5 different pages. Chapter 1, Chapter 6, Chapter 8. If you're looking for the answer, you go into Chapter 1. Oh, there it is. There's the answer. So you follow the layout and you'll find your answers, right? But you can't just do the answers. You got to understand the background data, because it's important, right?
Can we go over the slide for reliability engineer? The first one, the package. Yeah. Previous one.
There.
There's something called certified professional reliability, something like this.
Yeah, there's a few other ones out there.
But I believe it's from the state. I'm not sure.
Yeah, I'm not sure. This is the biggest one, Certified Lubrication Specialist. If you can get that bodes well. It bodes well for your, if you ever move companies or you're trying to expand and move through. These certificates are looked at. Don't get me wrong. When you do your resume and you have these, yeah, you're getting noticed.
But see, CRNP, this one,
CMRP. Yeah, that's a whole different thing. That's a whole different. No, they're more on failures and risk assessments and yeah. Okay, building the business case. This is the last part, guys. So what's neat about it is managers don't care about poor lubrication, but they care about the financial impact of poor lubrication, right? These types of managers and operation managers, managers speak in dollars. They don't speak in beta ratios and micron ratings. So we're going to estimate the dollars lost per year due to poor lubrication. You develop an action plan to close those gaps. You estimate upfront cost and ongoing costs for those lubricant improvements. And then we do a calculated 5-year net present value and an internal rate of return. There's a difference between internal rate of return and ROI, return on investment. It's your internal rate of return that tells upper management that if you meet a certain percentage, we'll give you the money. Whether it's, you know what I mean? So most companies have a hurdle rate of 15 to 30% internal rate of return for a project approval. So here's one here, fixed costs. So in the back of your books, you're going to see a page there and it asks you hydraulics, how many systems do you have that have this much oil in them? How many with this much? And you fill that out and that guides us into, okay, well, we know he's got, where's my injection guys? Yeah, I know you got like 30 pieces, right? So that's a lot of machinery. So when we want to upgrade that machinery to the hydraulic ports and stuff, I know you got 30 of them. So I'm going to cost you out on 30 of them. If you want to do your lube rooms, I need to know your oils. And then I'll tell you, well, you need 2 systems. So you start building a nice order list. And then all of a sudden you come up with a total. This is what it would cost in terms of an investment. And then we look at, well, what's the ongoing cost? Well, there's spin-on filters, there's oil analysis kits, there's all sorts of stuff, and it's another 20 grand. So I write this out, so the guy goes out and he says, okay, choose low, medium, high case estimate, and this is the likely case. Annual maintenance costs, $2 million. Downtime losses, about 200 grand they lose. Scheduled PM and repair costs, 30% of that $2 million is $770,000. Amount spent on rotating and reciprocating equipment is 75% of that. So there's $577,500 there. Percent of lubricant-related problems. He figures 20% of that is related to lube. So 115.5% of lubricant problems that can be eliminated. He says 67% could be eliminated for 77 grand. So that means that his annual loss is 77 grand. He's leaving $77,000 on the table each and every year. So what does that mean? It means the Lubriguard annual losses are 77.6. The product purchases is 35. The annual cost is 19. You break that over 5 years. At the end, you have a net present value of $186,000 over 5 years because you've paid the stuff off way back here. $186,000. You're losing $77,000 a year over 5 years with all the costs recouped. 186. That's an internal rate of return of 140%. What is the company's hurdle rate? 15 to 30%. Do you think they're going to be happy with a return of 140%? Yes, indeed. And you notice that I put in everything that the guy needs. His lube storage room, his ports, his filter carts, everything. His oil analysis costs, his breather costs, everything's calculated in. And he still comes out with 140. So let's say the 2 systems are the total of, say, $30,000 to do two 3-tank systems, 30 grand. And you walk up to your manager and say, hey, I want 30 grand to put 6 new poly tanks in. Okay, what's that for? That's to store my new oil into them and get them filtered. Well, you're telling me you're taking new oil that's in a steel drum and you're putting new oil from a steel drum into a plastic drum and it's going to cost me 30 grand. What are you smoking? Because you can't tell him anything about it. He doesn't have any background. He doesn't know that your machinery's falling apart. He doesn't know that you need ports and filters and all sorts of stuff. So if you don't do it in a package that says, there's the losses, there's the package and ongoing costs, that's my hurdle. So if you're having issues trying to get the guy upstairs, it's because you haven't presented the package. Very difficult to find ROI on a storage system because they don't understand particle counts. They don't understand the loss of equipment due to wear out. They don't understand that. They only understand dollars. But that's the dollar. That's the dollar. Guys, that's the end of our course. I really appreciate your time today. I hope this is something you can walk away with feeling good about your day here with us. But I certainly appreciate your time, okay? I do this for you guys, right? And if you see anything when you get your reports, if you need some feedback, if you need me to come and walk your plant, whatever it is, if you need assistance, I'm here for that. Don't be shy. You got questions, I'll answer them. You need stuff, I'll get it for you. If I don't have it, I'll source it. I'm very capable. I got the experience to do it for you. But other than that, guys, thank you, and ladies, thank you so much for your patience and your giving me your time today. So safe travels home. Enjoy the vacation day tomorrow if you're off. And I hope to see you or hear from you, okay? So thanks again, everyone. Appreciate it. Happy Canada Day.